Ellis crossing that boundary with real abandon. George Ellis thought flowing from one to the other.
Slow down now. Did you read?
No, I haven't. I was under the impression that we were permitted rather than required, being encouraged.
Can you hear me all right at the back? That's right. So, welcome to Oxford if you're visiting again. My name is William Simpson. I'm one of the organisers of this colloquium. I'm a research assistant professor in the Department of Philosophy at Durham and a visiting scholar in the Faculty of Philosophy at Oxford. The other organisers are Robert Koons, Professor of Philosophy at the University of Texas at Austin, who will be one of our leading speakers this morning, and Jonathan Price, who is a fellow at St. Cross College and runs the Centre for Archaeology, Law and Culture at Pusey House. Jonathan has been helping me with the logistics of this event, including the organisation of the lovely dinner that we had last night. So if you find yourself anxious saying, what should we eat, or what should we drink, or what should we wear, Jonathan knows that you need these things. He knows where they are. But before I hand you over to Jonathan, who will be doing some housekeeping and introducing the speakers for our first session, I'd like to say a few words about the workshop for the benefit of all of our participants. The title of our colloquium mentions science, theology, and metaphysics. Unsurprisingly, we are a mixed group of academics from different specializations, but a very special group of specialists, if I may say so. Many of our speakers are world-renowned scholars in their own fields, and several of the scholars of more than one. Today, we have scientists and philosophers with special interests in the philosophy of physics, followed by philosophers of mind, a philosophical anthropologist. Tomorrow, metaphysicians in the analytic tradition, followed by scholars in the field of science and religion. But this colloquium is not composed of watertight compartments. Indeed, it's clear from the abstracts which you can find in the program that we can look forward to some fascinating crossovers between all the different sessions as we contemplate the nature and reality of visual science things from our different standpoints. I've also been tasked with saying a few words about the question which has brought us together. Why does middle size matter for science, theology, and metaphysics? Some of you may discern a reference to the Oxford philosopher J.R. Austin and the emphasis on medium or middle-sized things. So let me begin by observing that there has been a tendency in Anglophone and analytic philosophy to make a distinction between fundamental and non-fundamental reality, and to identify the former with the microphysical things that are supposedly disclosed by our best physics. In this vision of reality, middle-sized things, such as scientists and philosophers, are typically conceived as arrangements of micro-sized things. More recently, however, there's been an opposing tendency to identify fundamental reality with the cosmos as a whole, as philosophers have endeavored to come to terms with physical phenomena like quantum entanglement. In this rival vision of reality, middle-sized things, if they exist at all, are at best fragments of a cosmic-sized thing. It has been less usual in modern philosophy to admit middle-sized things within the ranks of the fundamental, as Aristotle did when he identified living organisms as unified substances, which have causal powers to act in the world according to their own natures. I suspect that we have representatives of all these conceptions of reality with us today. Robert Koons, for instance, will be advocating for a retrieval of the Aristotelian vision. But why should middle-sized things matter for any of these scholars gathered here today? Why should philosophers or theologians be concerned about giving an account of the nature and existence of middle-sized things? And how should they go about doing so in a way that's properly informed by physics and yet does justice to the reality of middle-sized things, such as the scientists engaged in doing physics? So it might be helpful if I said something about what I was thinking when I suggested this title, but confining myself briefly to the topics of today. First, why should middle-sized things matter to physics, and in particular for our interpretation of quantum mechanics, the focus of some of our talks this morning? Well, quantum mechanics is a remarkably successful theory, and we're all beneficiaries of its successes, from the smartphones in our pockets to the MRI scanners in our hospitals. And some philosophers think that's a good reason to suppose that quantum mechanics has gained some traction on the nature of their material constituents. As a guide to reality, however, quantum theory is notoriously perplexing. Any realist interpretation that tries to say what the theory is about is going to have to settle the ontological status of the wave function, which is supposed to specify the physical state of a quantum system. And that's a task which faces two significant challenges. In the first place, there is the measurement problem, which you may have come across in connection with the famous thought experiment involving Schrödinger's cat, which is both dead and alive at the same time. This problem concerns how quantum systems evolve from states that are physically indeterminate to states which are measured to be determinate. It's a problem that has prompted some to speculate about the existence of many worlds in which different measurement outcomes are realized. George Ellis has a very different view of how this problem ought to be addressed. Secondly, there's the problem of macro objects, the focus of Alyssa's talk later this morning, which concerns how three-dimensional middle-sized objects, such as scientists and their measuring devices, could possibly exist in a quantum world. After all, the wave function is not defined in ordinary three-dimensional space, but in a mathematical space of many dimensions. Yet the possibility of scientific inquiry seems to presuppose the existence of middle-sized things which can be handled and observed, such as scientific instruments, as well as the scientists who handle and observe them. world in which neither scientists nor their instruments exist would not be a world in which scientific inquiry would be possible. Later today, Daniel de Haan will be considering whether middle-sized things like Sánchez and their measuring devices need their own middle-sized causal powers for scientific inquiry to be possible. Emily Quershi will be considering the problems that the Aristotelian interpretation of quantum mechanics poses for the identity and persistence of human persons, and Robert Koons will be soon pondering Aristotelian approaches to quantum theory, which seek to do justice to the reality of middle-sized things. Secondly, why do middle-sized things matter to the philosophy of mind, our focus this afternoon? Well, we ordinarily think of mind as something that exists at the scale of the middle-sized. After all, it is physically complex, macroscopic human beings who engage in the kind of conscious and intentional activities that are involved in scientific inquiry. According to many physicalists, however, the world consists fundamentally of microscopic constituents disclosed by best physics. These basic constituents are not conscious entities and are distributed according to laws which are void of intentionality. Such philosophers are committed to giving an account of the psychological properties of middle-sized things in terms of the properties of their microscopic constituents. Yet it is widely recognized that there are serious difficulties with such accounts. In the first place, there's the hard problem of consciousness, which concerns how the mere shuffling of unconscious physical constituents could give rise to the phenomenal experience of middle-sized subjects like humans and animals. In the second place, there's the problem of mental causation, which concerns how mental realities, such as a scientist's belief about the best way to conduct their experiment, could make a causal difference to what happens to physical things, such as the bodies of the scientists who are conducting the experiment. These are problems which have prompted some philosophers to speculate that consciousness and agency are some kind of illusion. This afternoon, however, Philip Goff will be considering whether we can grasp the mind-world relation by locating the roots of consciousness and rational agency at the level of the fundamental physical constituents, and Timothy O'Connor will be contemplating some ontological implications for middle-sized things if mind is something strongly emergent. Well, I think that's enough framing from me. I'm very much looking forward to hearing all of our speakers and participating in the discussions, and I hope you have a very enjoyable day. Over to you, Javier.
I'm sorry for my voice. I got a frog in my throat hanging out on the Pusey Tower last night, but no, we never made it up there. So tomorrow, if some of you want to go up the Pusey Tower with me or someone else, it's not a euphemism, it's an actual tower, and you go up to the top and look out over the colleges of Oxford, and we can tempt you, offer them to you for a price. But one of the few towers in Oxford that health and safety has still allowed people to go up, so it's a bit of a treat. If you want to do that at some point tomorrow, let me know, and then we can do that maybe 2 by 2 or 3 by 3. With that said, at some point during the day, you might need relief in a smaller and private room, and those are not easy to get to, but they are present in the college. It's one of the secrets of the college, as our host, Professor Sirks, whom I'll draw more attention to in a moment, has told me. Now, if you go down these stairs, which you should be very careful on, because occasionally someone falls down them and hurts himself, and then take a right, you'll see a door that's probably open. And there's a sign there that usually says toilets. If not, just go for the first door in front of you and down. There is men's and accessible toilets. So, should you want a ladies' toilet, go to the bottom of the stairs, take a right, and then take your first right, and go through the tunnel. And then you're going to find yourself out there by the bike shed. Don't go toward the bike shed. Take another right, and go straight toward the Hoffmann room, is that what it's there? So the Wharton room.
It's next to the Hoffmann room.
It's Hoffmann room, yeah.
Along the wall, stairs up, straight ahead.
Yeah. It's basically there. If you were to go through walls, you'd get down there. But you have to get there in a bit of a roundabout way. So make your choice. Those or those. But there are toilets here.
Yes, and if you are, the other thing is also you go that way, through the big doors, and then straight ahead, and then you will see at your right the commons room, and then if you go behind the coffee machine to the left,
It'll be
there's a
tested.
corridor, and there you have toilets as well.
Okay, some of you probably have a really good visual. If you could draw this for us later when someone asks. Or you could go left and ask the porter where the toilets are, and he could tell you what we just have. All right. That being said, you've now had an introduction to the pleasant and learned Professor Sierks, if you want to say correctly, Sierks, from the Netherlands, but also a lifetime fellow of this college, and he was the professor, the Regis Professor of Civil Law in this college, and taught the Roman Law course here, but has a background actually, having done degrees in philosophy, theology, and has great interest in the natural sciences. And he's our host here locally and has made it possible for us to enjoy the access to this college and to the provisions that we'll have today. So thank you very much for helping us with this and for cooperating and joining us for the day. Yep. And finally, well not finally, but initially I guess, as commencement, we're going to have two persons whom we've been introduced to already yesterday, but now we can have a chance to really wring the necks of their ideas during this session, yes? And this is Professor George Ellis who will speak first, who is Emeritus Distinguished Professor of Complex Systems in the Department of Mathematics and Applied Mathematics at the University of Cape Town. And he's a leading cosmologist, has co-authored numerous books, including The Large-Scale Structure of Space-Time with Stephen Hawking. Robert Koons is Professor of Philosophy and a Fellow at the Civitas Institute at the University of Texas, and holds many degrees, as does Professor Ellis. I tend to think that you should be born with lots of degrees, and as you learn, they're subtracted from you. So when someone has no degrees, they become learned, but we decided to do it the other way. So we won't speak about the many degrees that everyone has, but about some of their learning, and this has included books on Thomas Aquinas' Philosophy of Nature, Realism Regained, and a comprehensive guide to metaphysics, including describing this neo-Aristotelian world that some of us are inhabiting. The papers you'll hear are listed for you with abstracts in this program, so I won't take any more time to detail them. I'll just invite Professor Ellis to enjoy that time as part of his paper.
Thank you very much. Well, it's a pleasure to be with you again now, and I need to work out how do I shift. Okay, got it. Okay, so I'm going to talk about Aristotelian causation updated, characterizing why specific things happen in open systems. And I must immediately say I am not an Aristotelian scholar. I rather use his ideas as a basis to jump off and update things in a way which to me makes sense in the light of the way we understand science today. So, how does purpose and agency rise in middle-sized systems? And the basic point which I'm going to talk about, modular hierarchical structures at these scales underlie function. This allows Aristotle's four kinds of causation extended, as I've said: efficient causation, which is making things happen; formal causation, causation via shapes or forms; material causation, causation via the nature of matter; and final causation, causation due to purpose. And very important, underneath all of this, stochasticity underlies agency. So, the four sections of the talk: the basis of emergence is modular hierarchical structures. Efficient causation occurs at every level.
Can I pause for 1 second? Your respondent has shown up. We need to admit him. Yeah, that's all. Sorry.
Downward causation takes place via formal, material, and final causations. And the really important point, causal closure only takes place when all related levels are taken into account. So, the basis of emergency is modular hierarchical structures, and huge stochasticity occurs at the molecular level. And you saw this yesterday. You have the physics base, you have the basic level of life, the cell, tissues, organs, body systems, organisms, the basic emergent entities of life, where agency occurs, the crucial context of the population, the community, and the ecosystem. And this is the hierarchical structure of life on Earth. Now, why structures? Because that's how function emerges, and biology is all about the interaction between structure and function. Why modular? And the basic principle is you break up a complex task into simpler tasks. You make modules to handle them. You break up the modules into even simpler ones, and you keep on going down until you've got a module which is very, very simple and where you can handle it. Then you merge the outcomes to complete the complex task. And why hierarchical? Because hierarchy naturally emerges on combining the modules. And the details of why this has happened, and it needs abstraction, information, hiding, and other principles, is given in a wonderful book by Grady Booch called Object-Oriented Analysis and Design. And he's a computer scientist. And what one must realize is computer scientists are the people who have constructed incredibly complex systems. And so it's really worth listening to what they have to say. So, here is the hierarchy at the bottom: particles, atoms, macromolecular chemistry, cells, tissues, physiology, and the level of agency or psychology. And here is a picture from Churchill and Sinofsky in the central nervous system. You have molecules, synapses, neurons, networks, maps, systems, and the central nervous system as a whole. And function takes place at every level. Efficient causation takes place at every level. Synapses work in a certain way, neurons work in a certain way, networks work in a certain way, and you can characterize the functioning at every single one of those levels as effective causation. And the effective causation is different at every level. You use different variables to describe it at every level, different effective laws. Now, key point is the vast numbers underlying biology. The emergence of life arises after vast numbers of atoms and molecules. The number of 10 cells in the human body is 10 to the 13, which I've written up there. It's not obvious. We didn't know that there were cells until relatively recently in the time scale of human understanding. The number of protons in a single cell is 42 million. The number of atoms in a typical cell is 10 to the 14. If you put that together, they're 10 to the 27 atoms in a human being. Now, none of this is remotely obvious, but it is because of this vast numbers that our kind of emergence is possible. And the crucial further point, it's a very, very dynamic context. The oxygen and nitrogen molecules in air at normal room temperature are moving at between 300 to 400 meters a second. A biomolecule undergoes 10 to the 13 time collisions every second with water molecules. So it's not as if this is all sitting statically. There's this incredible stochasticity and variability. So there's huge stochasticity at the molecular level. And if you want to understand some of this further, there's a wonderful book by Philip Ball just come out called How Life Works, and he talks about biology has discovered the stochasticity and makes good use of it. Biology loves stochasticity and turns it into useful purposes. Now, the open systems issue, which I mentioned yesterday, because middle-sized objects are middle-sized, they have an exterior, interior, and closed boundary separating them. Forces impinge on them, that's the green things. Matter, energy, and information enter and leave them. This means that 100% knowledge of the interior state is not sufficient to predict their future, and I emphasized that yesterday. So the Laplace's demon for them can never predict their human state. And so if some physicist tells you that Laplace's demon will do it all, and therefore the way the brain works is basically physically trivial, it's simply not true, because the brain has been constructed to take into account that all of this other stuff is going to coming in, and it's got to be able to preemptively anticipate and act on the basis of what is probably going to happen. Now, efficient causation occurs at every level. Both time-independent and time-dependent versions occur. It's very important that there are static versions and dynamic versions. This takes place by a formal and material causation at each level. So, efficient causation is enabled by formal and material causation, and these chain down to affect lower levels. Now, efficient causation, the effects that make things happen, if you like, forces in action. I'm using force in a slightly generalized sense there. It's same level causation, and each of those in the hierarchy, it happens at the same level. It occurs at the underlying physics level, and some of my physics friends say, well, that's all that matters is efficient causation at the physics level, and everything else is just froth on the top of it. But efficient causation is not confined to the physics level. Efficient causation takes place at every level, from the underlying physics level to the psychological and social levels. And Dennis Noble, who is a great physiologist at this university, calls this the principle of biological relativity. Indeed, the existence of efficient causation is what defines emergent levels. If you ask, how do I know what those levels are? The answer is efficient causation is what defines them. They're characterized by specific variables and laws, and incidentally, by particular academic departments, the academic departments that study each of those levels. Now, so let's just look at the psychology, predictive processing, analyzing events, making choices, physiology, pumping blood, enabling breathing, seeing, and so on. Tissues, providing boundaries in terms of our being small things. Our skin is the boundary defining the exterior and interior, and the skin has a lot of very complex properties. Tissues, muscles as an example, contracting enable us to do things. At the cell level, they divide, they transport oxygen, they convey information of their neurons. Macromolecules control ion flows, I'll mention that in a minute. They absorb photons, they're used in signaling. Atoms combine to make molecules, they collide off each other and so on, and particles attract and repel each other. So there's absolutely different kind of efficient causation occurring at each emergent level, described by different laws and different variables. Now, they are both time-independent and time-dependent forms of efficient causation. And as I've said, this takes place by both formal and material causation at that level. And this then involves downward causations to the lower levels. Now, how does downward causation work? And I'm going to discuss this in some detail. Firstly, by setting constraints on lower levels. That's formal causation because it's to do with shapes. Shapes are governed by constraints. And in physics terms, there's a constraint term in the Hamiltonian. And this allows conditional branching, and that's a very important thing which I will mention. Secondly, downward causation takes place by changing the nature of components at the lower levels, which is material causation. And this is a crucial thing in biology. Downward causation creates or alters or deletes lower level elements such as cells, molecules, and so on. This is all affected by what happens across our boundaries. Context alters the outcomes because we are open systems. So this picture, this slide here is a very important one about static and dynamic formal causation. On the left at the top is static causation. It's a glass vessel with water in it, and it's static formal causation because it's the shape of the vase prevents the water running out into the room. The vase shape holds the water in. It causes molecular reversals as indicated on the right of the micro level. So this macro level thing is shaping what happens at the micro level by causing the molecules to reflect back at the boundary. And that's static formal causation. And I'm emphasizing it occurs at the macro level, but it shapes what happens at the micro level, so it's downward causation. On the right is a tap. And at the top it's closed, at the bottom it's open. So that's dynamic formal causation because the constraint changes with time. I turn it on, then I turn it off. When it's closed, the molecules can't get through. When it's open, the molecules get through and drip down. So it's controlling in a downward way what happens at the molecular level. So the macro determines micro in both cases. Now that's material causation involved as well. On the left, it's made of glass. And if it was made of some other material, if it was made of plastic, it wouldn't hold the water in. In fact, it's made of glass as part of what's happening. On the right, it's mainly metal, and again, that metal is impervious to water, and there's also some other stuff in the washer. And so you're seeing here material causation as well. Now, dynamical formal causation in open systems. I've mentioned here the change of shape at the macro level, and another example is closing a switch in a circuit. When you turn the light on, you're making a macro change which changes the macro topology of the circuit at the micro level. It lets electrons flow. This changes down to affect dynamics as the micro levels, as I emphasized. Now, you can also get dynamical formal causation at the micro level, where you get a change of shape at the micro level, and this is the foundation of biology, is macromolecules. And macromolecules change shape. It's a discovery of molecular biology, and it allows logic to emerge from the physics. It allows an if-then-else statement to emerge from the physics, and it's this logical branching which is absolutely essential to the emergence of agency and purpose. Now, this is an example of an ion channel, which is a protein, and it controls ion flows across the cell wall. And on the left, the gate is closed because the voltage gradient is upward, as indicated by that arrow on the left-hand side. And so the sodium ions cannot enter into the cell. The cell exterior is above, the cell interior is below, and the ion channel is closed. It's closed because it responds to the voltage across. Now, on the right, the voltage is downward. If you look at plus at the bottom instead of the top, the plus and the minus are inverted on the right, and that causes the gate to open, and then potassium ions can cross from the exterior into. So it is change of shape at the microscopic level, which is the causal agent in this place. And so that is formal causation at the micro level. Now, this enables logic to emerge from the underlying physics, because the logic is if the voltage is upward, then the channel is closed. If the voltage is downward, then the channel is open. And this is how logic, this is one way that logic emerges out of physics. It's via this kind of time-dependent form of causation. It's a key feature, logical branching is a key feature of biology at all levels. There's also material causation. You have to ask yourself, how did these incredible molecules come into existence? And it's the shape of these molecules, but the molecules are material things. And so the question is, how does these molecules come into existence? And of course they came into existence via Darwinian evolutionary processes, which selected them because they enabled our brains. This happens in our neurons, and it enables spike chains to travel in them, enables us to think. And evolution, in effect, discovered that we could think if we had these kinds of molecules in our body. So this is how that came into existence. Okay, then you have dynamical material causation. In open systems, there are three kinds of dynamic material causation. Creating elements, or allowing them to enter the system, maintaining elements when in the system or altering them, and deleting elements or expelling them. And this is material causation in a very important way. The higher levels control what kind of materials exist at the lower level. These can happen at the macro level, so you can create elements at the macro level. For instance, a chemist mixing elements, mixing chemicals in his laboratory produces new things, and then they chain down to lower levels, or they can happen at the micro level alone. In biology, components are structured so as to fulfill higher level purposes, and this can allow logical operations to occur. So, in physics, creating lower level elements, for the physicists on the left, is Cooper pairs that underlie superconductivity. Now, this is very puzzling. Electrons repel each other, so how can a pair of electrons move as a unit? And the answer is the lattice distorts, and that enables them to occur. And so the Cooper pairs are created by the existence of the lattice. A completely different example on the right is stellar nucleosynthesis. That's a picture of a massive star, a giant red star, and in the insert there's an example of nuclear reactions taking place. It is the structure of the star with the way that the temperatures change with radius, which controls the rate of nuclear reactions, and then enables the creation of the elements like nitrogen, oxygen, and neon. And so this is acting down from the scale of the star to the creation of the elements of nitrogen, fluorine, oxygen, and neon, and incidentally the elements of life out of which we are created. In biology, this is the whole topic of developmental biology. You have different kinds of genes expressed at different places in Drosophila, and then that creates different proteins, and so the proteins are created in order to create this body, and again this is through evolutionary processes. And so the lower level elements, the proteins, are created by developmental processes based on positional information. Basically, the context of the developing larva tells the the circuits controlling gene expression, which gene should be expressed where, at which place in the body. And so this is creating lower levels in biology, it's creating the proteins which are needed in order to create those parts of the fly at different positions in the fly. Now, maintaining elements, the heart keeps us alive. And again, my colleague Dennis Noble has done a wonderful multi-level computer model of the heart. It's shown on the left, and it shows the top-down effects from the heart to the cell and the gene level that keep the heart level pumping blood. And I won't go into the way that the heart pumps is based through cells and genes and so on. But the point I'm making is this is what keeps us alive. And so this is downward causation from the level of the heart to keeping us alive. If the heart stops pumping, you die within a couple of minutes. And so this is material causation. It's the way that you maintain the cells alive in us by the action of the heart at the physiological level. Now, deleting elements is the core of adaptive selection. Meaningful information is gained by discarding all the information and stuff received that is not meaningful. And conceptually, you've got an ensemble of stuff coming up from the bottom. It goes through a selective gate with some selection criteria, and you get an ordered set of stuff coming out. And you've got the criteria C. If X lies within the criteria, then you keep it. If it's not, you delete it. And the classic example for that is deleting unwanted incoming emails. You select what is meaningful, and you delete the one that you don't. Now, the example of this is natural selection, and this happens in many ways here. The environment basically tells the animal what's good for it, and in this case, this is a polar bear. It's good for it to be white, not black, because then it can creep up on its prey. The animal, metaphorically, tells the animal that it chains down to configure the DNA sequences so that it will produce proteins which will make the fur white. And so it's the environment which acts down to tell the DNA that you should be producing proteins that are going to make the fur white, and that's top-down action creating at the bottom level the proteins which make this bear a successful hunter where it lives. So the selection principle of survival and reproduction is a downward causation. Yes, a different environment, the Canadian forest, results in a black or brown bear because it will get different genes. So this is changed material stuff, proteins at the molecular level, and it's a multi-level affair. Each level is selected to enable ecological adaptation. Driving this is ecology, because the bear has to survive in an ecological context. That drives down to shape the genes and the proteins. Now, downward causation takes place by a formal, material, and final causation. I basically explained that. What I want to talk about now is multiple realizability is a key aspect of these processes, and final causation is where agency enters, enabled by stochasticity. So multiple realizability, you've got some higher level, and you've got many, many different ways you can realize it at lower levels. Any higher level can be realized in numerous ways at lower levels. For instance, if you have a cell has got an incredibly complicated structure. It doesn't matter the specific atoms where they are. What matters is the atoms are configured in such a way that the cell functions as a cell. And you can shift around the atoms a huge different number of ways, and it will still function as a cell. Which lower level realization occurs is immaterial as long as it does what is needed. Billions of molecular configurations will give the desired high level result. And there's a great book on this by Wagner called Arrival of the Fittest, and he talks about this in the case of the phenotype-genotype maps. Final causation, why? This is the teleological issue of functional purpose, which is the core of life. What's the reason things happen? All life and its component, all evidence has a purpose or function. Staying alive, pumping blood, seeing, walking. In an extended sense, this is final causation, which distinguishes life from physics. Physics, and we discussed this a bit yesterday, a planet, the moon has no purpose. Final causation shapes dynamics at the highest level and thereby entrains lower level efficient causation downwardly. And it requires agency, it requires effective free will. We have this, otherwise iPhones and aircraft wouldn't exist, as I mentioned yesterday. I'm applying a pragmatic philosophy here. What happens at the micro scale is not obvious. But what happens at the macro scales in daily life often is. It is obvious that iPhones exist because we created them. And you don't have to question that in some serious philosophical way. It's just the way things are. And thoughts have consequences. Yes, a lot of what happens in our brains is unconscious, like when driving a car, but some is thoughtful and clearly conscious and has material outcomes. And to claim consciousness is an illusion is a contradictory statement, which I won't go into here. Agency arises in this way from the underlying physics, and this paper by Raymond and Dennis Noble, Can Reasons and Values Influence Action? How might intentional agency work philosophically? And what they say is you harness stochasticity, which can be the basis of creative agency. Such harnessing can resolve the apparent conflict between reductionist micro-level accounts of behavior and behavior's outcome of rational and value-driven macro-level decisions. Neurophysiological processes can instantiate such behavior. The processes involved depend on three features of living organs. They are necessarily open systems. Micro-level systems therefore nest within higher-level systems, and causal interaction must occur across all the boundaries between the levels of organization. The higher levels constrain the dynamics of lower levels. And the highest level is ethics. The choice of purpose and criteria for what are acceptable and desirable shapes goal choices at all levels. So levels change down. If your purpose is to kill people through a war, that will change down to your psychology, to what's happening in your physiology, biochemistry, physics, and so on. If your aim is to provide help to people by running the Red Cross or similar organization, that will change down through all those levels and affect what happens at all those levels. Options at the social and psychological level are shaped by what is acceptable and desirable in your viewpoint. These moral values act top-down to guide physical outcomes at lower levels. And here, ethics is causally effective in the world. This is an example from the war going on between Russia and the others. And you see the starting thing, and you've got this great building, and then what you end up with. So values are causally effective, and you see it in this kind of picture. And the final thing I want to say is causal closure only takes place when all related levels are taken into account. The claim that any physical level by itself is causally closed is simply wrong. And the example I want to give is smoking causes lung cancer. Now, the top level is sociology and economics. Smoking advertising is there for the explicit purpose of trying to persuade you to smoke. And a lot of money goes into that advertising. And there's social pressure. Your friends say, why don't you smoke? And so the topmost level is the sociology and economic levels. This changes down to the psychological level. So you think, I enjoy smoking, and then your rationality says, but maybe it'll be cancer, but then your emotional list says, but anyhow, I enjoy it, so I'm going to go ahead. This changes down to the human physiology level, where it is an established fact that smoking causes cancer. That's a causal relation established by Judeo-Pearl. And that's incontestable. How does that happen? It's because the particles go at the cell biology level called uncontrolled cell duplication. Things take place at the cellular level. How does that happen? Through gene regulatory networks. Protein production based on DNA is altered by the smoke particles. How does that happen? It's through macromolecular chemistry. The regulatory molecules binding conformational changes are what underlies how the gene regulation works. How does that happen? Through quantum chemistry. Molecules bond to create macromolecules which change shape. How does that happen? Atoms bind to molecules. How does that happen? Particles, electrons and protons interact. And the causation chain down from the bottom to the top enabled by its chaining back up again. Efficient causation takes place at each level. I've indicated that. It's driven in a downward way, starting off with the advertising. You wouldn't be smoking if people hadn't put all that money into that advertising. But it's enabled in an upward way. You can follow the chain up all the way, and you will see how this happens in an upward way. But the whole point is only the whole set of interacting levels is causally complete. If you omit any level, you don't have a causally complete system. And the statement that the particle physics level is causally complete is simply wrong. It doesn't take into account the context. If I give you Maxwell's equation and say, now what's going to happen? The answer is, Maxwell's equations by themselves simply don't cause anything at all. What causes things is this complex context. So, That's back to my summary. How does purpose arise at middle-sized scales? How does biology and agency arise from physics? I've tried to indicate that. Modular hierarchical structures of these scales underlie functions. This allows Aristotle's four kinds of causation extended in the way I've indicated: efficient causation, making things happen; formal causation via shapes or forms; material causation via the nature of matter; and final causation due to purpose, including values specifically. And stochasticity, huge stochasticity, due to this vast number of particles. This wouldn't be possible if we were made of much, much less number of particles. This is the way that it happens.
You know, find the right point.
Oh, yes, sorry.
Yeah, thanks.
And actually, we've realized the problem with the room. If you want to see his presentation, it's probably better to sit back on the other seat. Sorry. It's going to be musical chairs.
Well, especially without just say how grateful I am for we all to be here. It's a real privilege to be able to interact with folks at this high level. What I'm going to talk about in this talk today is I'm going to lower my guard to some extent. I'm going to share with you some uncertainties and confusions, and hopefully during our discussion you can help me sort this out. My general program, as you know, the last few years has been to try to develop an Aristotelian framework for understanding quantum physics, but also chemistry and thermodynamics as they relate to that. And I'm going to focus mostly on the quantum physics side this morning, and I'm going to lay out, I think you have a handout, right? 7 sort of open questions, as far as I'm concerned, about how one might pursue this kind of program, what sort of directions it might take in the future. So,
Show the screen will be there.
Jonathan, that's the wrong.
Sorry?
That's George's.
This
this
is still open. It's still open. This is yours, right?
No,
Oh, that's already this yours.
So it's options for Q.
It's above you,
Bottom, Jonathan.
Rearranged by date modified.
That's good.
Okay, so now I need to show the screen. There.
Like you're in charge of this, not me. This is very complicated to dance here. Yeah.
It's so simple, but only a child will use it. Okay, and then that should be ready.
Great. Thanks very much. Yeah. So, just an overview. I'm going to start off just with a few minutes talking about why hylomorphism, but I'm going to give a very short version of that here, and hope that you'll give me the benefit of the doubt and say, well, okay, this is worth thinking about further and worth developing. Most of the talk's going to be in this second section, where I'm going to go through these 7 choice points, 7 sort of open questions, and then the conclusion, which will be some very tentative ideas that I have about where to go. So why hylomorphism? So Wilfrid Sellers made this distinction between the manifest image of man, the scientific image of man, and the problem of relating those two. We can make that more specific, I think, by talking about the experimental image. The image of the world we get as an experimental scientist dealing with laboratories, instruments, making observations, and then the more fundamental microphysical or quantum image. And what we've seen with the quantum revolution really is that these two images come even further apart than ever before. So in pre-quantum sort of classical physics, there was considerable overlap in both ideology and ontology between the two images. Lots of properties like primary qualities, even things like temperature and so on that were shared by the two images. But now there's almost no overlap at all, right? Very little overlap between the two. And that creates some real problems in terms of recovering that experimental image. Because obviously if the experimental image is completely illusory or non-existent, then that makes science impossible because it deprives us of the empirical basis for our belief in quantum physics in the first place. So I've been arguing in recent years that the quantum fundamentalist, the one who thinks that all properties that are natural, all natural properties, belong to the quantum image, and therefore all fundamental entities belong to the quantum image. I've been arguing that is that program is failing in terms of its accounting for this experimental image. I'm not going to talk too much about that this morning. There is a paper in the Dropbox for yesterday where I discuss, in particular with many worlds interpretation, argue that there's some real difficulties involving the explosion of real worlds that you get that prevents us from being able to say that this world, or a world like the one we're inhabiting, is the one real world at the macroscopic level. So that's one of the real challenges that the fundamentalist has. I also think that so that Oxford Everettians, Everettians in general, have the biggest problem here, the biggest gap between the quantum image and the experimental image. But I think that other versions too, like GRW and Bohmians, still have a difficulty. That the quantum image of Bohmians, of particles, perhaps featureless particles moving around in space and time, very, very strong non-locality involved. That creates real problems in terms of recovering the experimental image. The GRW's views, either in terms of a peculiar sort of matter density idea, or the flash ontology, in both cases, again, there's quite a large gap between that and the experimental image. So there's some reason, I guess, I want to argue here in this first section, some reason for exploring an alternative view in which one takes the view that in the experimental image, in these middle-sized objects, there are fully natural properties, and therefore fundamental entities, and therefore causal interactions that are of fundamental nature, causal powers of fundamental nature at that level. And that, I think, that's basically what I'm calling a hylomorphic or Aristotelian sort of approach to it. Aristotle was the one, a philosopher from antiquity, who takes seriously the fundamentality of the middle-sized world, in contrast to Democritus and the atoms and the void on the one side, or Parmenides and the whole universe on the other side. So it's useful, I think, to look at Aristotle as a potential guide here. So as I say, there are really several alternatives, I should mention, to a kind of microphysical fundamentalism. One is the pluralism, the hylomorphic kind of pluralism I'm defending, in which some properties of the experimental image are perfectly natural, fundamental properties conferring causal powers, supporting fundamental causal laws. But there are other alternatives, which I know some of you in the room would prefer. Versions of dualism or phenomenalism or even idealism. In this case, the additional natural properties and fundamental entities would all be mental in nature. And I think both agree that there's a need for a kind of formal top-down constraint of some kind on the experimental image. So I'm not going to discuss the debate between these two in this talk. I just want to set that out there. My own preferences would be obviously for the pluralistic account. Not that I don't believe in the mental, but that I think having an account of this middle-sized physical world is actually very helpful in developing a more sophisticated kind of emergent dualism ultimately. So, let's see, sorry. So what would the hylomorphic picture look like? Quantum wave function represents a kind of bottom-up material causation for the Aristotelian. And what I'm arguing is that that's not sufficient. In addition to that, there has to be some kind of formal cause from the real essence and the accidents of composite objects. So the presence of substantial forms and of accidents, so both of these things are formal causes in the Aristotelian kind of framework. Excuse me for a second, I want to mess this up. The presence of form and accident in particular places and times has a diachronic explanation in terms of efficient causation. So that forms are generated when the new substance is generated. All accidents are generated through alteration by other objects at that middle level. So there's in potential two versions of this sort of hylomorphism. One could be an imperialist, and one could argue that these kinds of middle-sized properties are the only fundamental ones, and that quantum mechanics is treated instrumentally, anti-realistically. Or you can do it in a more accommodationist way and say that the fundamental properties of the world are both at the quantum level and at the middle-sized level. And that's the first that I'm going to defend this morning. But I think the other one's an interesting option. So how are fundamental laws governing composite objects possible at all? I mean, if there are fundamental laws at the microscopic level, you might think that leaves no room for any kind of fundamental laws or fundamental causation at higher levels. But I think there's at least three cases in which that could happen. The laws at each level, including the quantum level, could be explicitly indeterministic. Even the final probability of an event would be determined by laws or conditions occurring at multiple levels. So all the different levels contribute to the final probabilities. It could be that the quantum laws are only approximately true. You're getting more and more from actual results as the time and space scales increase. So even if they're explicitly deterministic, they're implicitly or de facto compatible with micro-indeterminism, in which case, again, in option 1, the final probabilities can be determined at multiple levels. Or thirdly, the quantum laws might be just local in their application, depending on non-quantal boundary conditions and pre-quantal structuring of the state space. And so now the dynamics of the pure quantum mechanics are actually embedded in larger phase space, one defined in terms of extra quantum quantities like those of chemistry and thermodynamics and biology ultimately. And these are not mutually exclusive options. Actually, one could combine the two of them in various ways. Okay, so that brings me to the main point of the talk, and that's to go through some of these hylomorphic choice points. What are some of the options? So one that I've struggled with for quite a few years now, and still have not resolved, is what to do about the wave function. Should we posit a cosmic wave function, a wave function that defines the behavior of all the particles of all the substances in the world, right? Is that necessary? There's a pretty strong case to say no here, I think, from a cosmological point of view. Namely, one could argue, as George and Barbara Drossel have argued, that quantum mechanics is really only valid for small scales and short time frames. And so if you could construct a cosmic wave function, it would be pretty much useless because it would deviate so far from what actually happens in the world. You could also argue that quantum mechanics is always applied in some sort of concrete context, and the universe doesn't exist within a context, in a concrete context anyway, so there's some question about whether it even makes sense to talk about a wave function in that sort of setting. One could point out that quantum cosmology, one place where this sort of thing is used, is highly speculative. We haven't derived a lot of, at least in the quantum realm, a lot of observable results. And then finally, this relates maybe to the second point as well. You might, if you think of quantum mechanics as really defining or determining the probabilities of measurement events of some kind, then you might say, well, if there's no way to measure the whole cosmos, there's no way to observe it since we're all part of it. And so those are all recent considerations that push one in the direction of no. But I want to push back a little bit and wonder whether that case is compelling, or perhaps the hylomorphists should, in fact, look at some kind of cosmic wave function. First of all, I'm not really clear, and maybe George and others can help me with this, whether both space and time constraints are needed. So could a cosmic wave function provide accurate predictions, at least for a very short interval of time? And if so, then there would be some reason to do so. Even if it couldn't model what would happen in a year or a day or even a few minutes, and if it could, for a few nanoseconds at least, tell us something interesting that might be still worth doing. And secondly, is there really an upper bound of the number of particles that can be included in an accurate quantum mechanical model? It seems not, right? Because we do have quantum mechanical explanations for the behavior of macroscopic bodies, like supercooled or superconducting bodies, Bose-Einstein condensates, phonons, and so on. So it doesn't seem to be clear that we can say that because quantum mechanics is, even if it is in some sense limited to small-scale objects, it also seems that we can build models that apply to macroscopic objects with many particles, including the whole universe, perhaps. And thirdly, about this context. So does the context that's required for wave collapse require further substances rather than just further natural properties? Right? So you remember again, for the Aristotelian, the quantum wave function does not exhaust reality. There's more to reality than the quantum wave function. There are also these substances with their natural properties at the middle-sized sort of level. You could certainly conceive of like a EPR, Einstein sort of thought experiment, where a given substance is both the source of the pair of electrons, and also then later acts as one of the detectors of one of the electrons as well. And so in this case, the very same substance would be, in a sense, measuring its own result. I mean, you just send one of the electrons in a circuitous route and send it back to the original substance at some point to register it. So couldn't we have a universe where different parts of the universe, or maybe the universe as a whole, sort of measuring itself, so to speak, through these higher level properties, right, beyond the quantum realm. Now, I think from what I understand the Ellis-Drossel model, I think that there is this idea that in addition to the system that's being measured, you need a thermal heat bath of some kind, otherwise the measurement can't take place. So that's, I think, an argument in response to my third worry here, which is maybe it is in fact impossible to have a wave collapse of the universe without, because there could be no external heat bath, right, beyond the universe relative to which it could be resolved. And that, I think, is the most important argument, actually, from their program against the cosmic wave function. But here, I sort of put on my philosopher's metaphysical hat, right? And I say, well, wait a minute, couldn't we do a thought experiment where we take what is actually the universe and now embed it in a counterfactual context where there's an additional heat bath out there somewhere? And so we could ask, what would happen in that situation to the universe? And it seems like we should have an answer to the question, what would happen? And to answer that question, you need a wave function, a cosmic wave function, right? Which you can then carry into that. Now, what this, I think, shows is that the cosmic wave function, if there is such a thing, is only contingently or de facto cosmic. Right? That is, it might be a wave function that applies to the things that are actually the totality of the universe, but they're not de jure cosmic wave function, right? That is, it's not a wave function that belongs to the universe as such, the totality as such. That, I think, these arguments suggest is probably incoherent. But the idea that there might be a de facto wave function of the entire cosmos strikes me as plausible. So I would, at this point, sort of lean in that direction to suppose that that makes sense. Now, you might still worry that the idea of a cosmic wave function is just superfluous. I mean, even if you could model it and make some sense out of it, maybe it doesn't have any use. Because suppose entanglement in the universe is very local and temporary, then the cosmic wave function would just be a sum of lots of various local and temporary wave functions. It wouldn't really add any interesting information to us. It wouldn't really promote our understanding in any way. And so this seems to turn on the question of whether the whole universe itself is entangled. So this is another issue that I've been working on, which is, as an Aristotelian, should I think of entanglement as something that happens within a single substance in every case, right? Within the different aspects or different parts of a given substance? And I think there's pretty good reason to think no. That in fact, different substances in an Aristotelian world can become entangled via parts, quantum level parts. And this is the European Stoller thought experiments from 1992, where they show how to set up an EPR-like correlation involving two completely independent sources of electrons, or photons, whatever you're using, right? And as long as you send them along paths through various reflectors, so that the paths of these particles overlap in certain ways, you end up with EPR correlations, even though the original sources are completely independent. So this seems to show that it's quite possible for multiple substances to become entangled with each other, and therefore quite possibly the whole universe, that all the substances in the world are mutually entangled in this way, in which case, again, we would need a cosmic wave function to represent that massive entanglement. Okay, that brings me to the second choice point, which is, should the dynamics be exclusively unitary, Schrödinger-like, or should we adopt some sort of objective collapse picture? Right? So if we say no to the first question, right, there's no cosmic wave function, all wave functions are local affairs, or temporary local affairs, then it seems to me that it's a very compelling reason to go with the collapse interpretation, right? To suppose that as the wave function that we're modeling is measured in a relevant sort of way by macroscopic objects, the wave function collapses. But what if we say yes? What if we have a cosmic wave function? Then it seems to me both options seem to be available, and I'm not sure which way to go or what the considerations are that would push us one way or the other. We could have an objective collapse of the cosmic wave function, resulting in something like a GRW or Penrose kind of picture. The difference would be that instead of in Penrose and in GRW, the collapse itself is a microphysical kind of phenomenon. It just depends on how many particles are entangled or what gravity is doing at the macroscopic level. Whereas an Aristotelian is going to have a kind of top-down objective collapse of some kind, where these middle-sized properties are going to play an irreducible role in explaining the collapses. And maybe we could do something that sort of adapt or modify the Ellis-Drossel account of the classical and thermodynamic features that precipitate the collapse. Again, in a kind of counterfactual, hypothetical sort of way, since there's no actual feedback to do it in this particular case. But we could also go with a no-collapse model. And so it's quite possible, I think, to give a hylomorphic account of the Everett interpretation or of something like a modal interpretation. So Alex Proust, in his chapter in our book 2018, develops what he calls a traveling forms model, which is basically a modal interpretation that uses Aristotelianism. So the thought here is that you get the privileged observables in a top-down way by looking at these essences and accidents that belong to substances, and those are realized at the quantum level by particular observables, and so that gives you the privileged basis, right? The determinables at the quantum level that are always have some sort of value, the ones that correspond to these forms of accidents, right? And then you use some sort of dynamic like the Bouverie-Dixon dynamics from 1999 as a stochastic kind of model for how you can evolve those sorts of determinables in that way. And that's connected to my third choice point, which is whether we should have one world or many. So, as I said, it's possible to combine an ever-ready many worlds interpretation with Aristotle. So one of the great problems that the many worlds people have is how to recover what they call branches, right? So in the quantum formalism itself, there are no branches, there are no worlds, right? There's no three-dimensional objects, no splitting apart and so on. So you have to somehow make sense of how you extract that from the quantum wave function. I know Alyssa is going to talk about that later more today, her model of how to do that. I think it's a difficulty. Hylomorphism could help, I think, because hylomorphism can appeal to these essences and accidents of middle-sized objects as defining, again, which observables are the ones to look for that will define the real branches, right? So you could go that way. But in fact, I think the one-world option seems preferable. Multiple branches can be considered as really as representing, from an Aristotelian point of view, I think, multiple potentialities. So each branch on this picture would be a kind of potential world, but there'd be one actual world, right? I think that's the key Aristotelian commitment, really, is that there's a distinction here between actual and potential. And Arrhenians, in a sense, attempt to abolish that distinction and treat all the potential worlds as equally actual. I think an Aristotelian should resist that, ultimately. And this also gives us a basis for the interpretation of probabilities by something like the Savage axioms. So I've argued that you can't really make sense of the Savage axioms except in a one-world kind of setting, because if you cared about things that were realized in multiple worlds, you would violate the sure thing principle, right? So if I were a Rawlsian about all of these alternative worlds, instead of trying to maximize the average, I was just sort of worried about, well, here's a world where the welfare's going to be really, really low, so I'm going to have to avoid that action. If you start thinking that way, then you won't be able to recover the probabilities, the Bohren rule probabilities. So I think there's some reason to go with the one world kind of picture, and something like a modal interpretation seems to be like the best way to go there. Fourth choice, should the dynamics be universal? If the dynamics are universal, if there's no collapse, should we have a deterministic or stochastic dynamics, right? So Bohm's version of his theory has a guidance equation which was deterministic, right? So all probabilities were just reflecting our ignorance in the Bohmian picture. On the other hand, Bell proposed a stochastic version of Bohmianism, and that's further developed again by Bouverie and Dixon as a more general strategy for the modal interpretation of quantum mechanics. And I think there's good reason to prefer stochastic dynamics over the deterministic one. Here's at least three reasons you could mention. One is an argument that I gave in 2000, that indeterminism can be used to define an intrinsic direction to time and causation. So if you imagine that the future is branching and the past is not branching, that gives you a kind of determinate direction to time, and that kind of branching future fits really nicely with indeterministic kind of dynamics. Indeterminism at the quantum level is necessary if composite objects are to be real difference makers, so avoiding Kim overdetermination kind of worries. This goes back to the slide I had earlier. And finally, indeterminism avoids an objectionable form. I think an objectionable form of action at a distance in quantum mechanics. So there's a distinction in the literature, going back to Shimony, between violations of parameter independence, which is bad, according to Shimony and me, and violations of outcome independence, which is okay, I according to both of us. And to get this sort of to go the right way, you need to have a stochastic rather than a deterministic dynamics. So when is action at a distance problematic? I think it's only problematic when you have what I'm calling positive non-locality versus negative non-locality, which is fine. So a negative non-locality occurs when an event at one location nomenologically entails of something at a space-like separation. So again, far away and you can't get there in time, loses some stochastic causal power that it will otherwise have. Right? So in an EPR type experiment, you observe one electron, it's spin up, you now know the other electron has to be spin down, right? All that's happened is that the other electron has now lost a certain power that it had before, the power to go spin up. It can only go spin down, right? It's not able to do something new that it wasn't ever able to do before, so to speak. It always had the capacity to go spin down. Now it's just lost one of its other capacities. Where positive non-locality occurs when an event entails that some space-like separated object gains a new power it didn't have before, or gains some other kind of intrinsic property that it wouldn't have had before, right? And that seems to be an objectionable kind of action at a distance. And the reason for that is not primarily to do with relativity. I mean, I'm not so worried about that, actually. But I'm definitely worried about the epistemology of action at a distance, right? So if you look, again, at something like Nancy Cartwright's models of how scientists learn how things work, you build a nomenological machine, you sort of isolate things from their environment, you pair them up and see what happens when they interact, right? If there's action at distance that's immediate, has no limit on distance, there's no limit on its intensity, so it can be very, very strong influence at a very, very great distance instantaneously, that's going to create epistemological problems, I think, for all of our experiments. How are we ever going to have the confidence that we've successfully isolated things in order to figure out what's going on? Whereas if the non-locality is really negative, there's no problem, because you won't see anything that couldn't have happened. If you see something happening, you'll know that it happened locally, right? That is, there'll be a local explanation for the powers. It's only the things that don't happen, right, that have non-local explanations. That brings me to choice point 5. Is the dynamical law or laws of quantum mechanics grounded? And if so, by what? Right? So scientists generally take for granted that they can explain things in terms of laws of nature. We metaphysicians are not satisfied with that as the final answer, right? What's a law of nature? Why should that explain anything, right? And there are a number of different options here. There's the sort of Humean option that says that laws of nature are just theorems of the best system of generalizations. I won't go into detail there. There's been a lot of dissatisfaction with that account, I think, and I'm certainly one who's been very dissatisfied with it for a long time. You could take subjunctive conditional truths to be fundamental, like Mark Lang does. Again, that seems to a lot of us to be pretty strange. Conditionals are be true by something, it seems. You could take the domic realism of Thule, Dresky, and Armstrong. So laws are some kind of peculiar metaphysical tie between universals or Platonic forms of some kind. And then finally, there's the neo-Aristotelian or causal powers of account. So no surprise, I like the fourth account best. It provides a basis for the causal laws. Right? The causal laws are grounded in the essences of substances and the causal powers of those essences and accidents as well confer upon those powers. So the reason that it's sort of the law of nature that water boils at 100 degrees centigrade is because it's the nature of water to do that. It has a causal potentiality that expresses itself in a regular way in that way. The Thule, Dresky, Armstrong thing, the problem there is how do you get from this peculiar law of nature to real things happening in the world and not happening in the real world, right? I mean, it looks as though you need something like God to be the enforcer of the law of nature, right? And say, no, you can't do that because it's against the law of nature. But then you're back to version 4, actually, because now you're just appealing to the power of God, right, to enforce the laws. So why not just go for a simpler account here and just give the powers directly to the creature? So again, the essence of a substance determines what kinds of powers and accidents and actual parts it could have, and to what collectives it could belong under various circumstances. So what actual powers a substance has depends on its parts, accidents, and memberships it has at the present. So these in turn depend on its history, its past interaction with other substances, and interaction with each other. So there's plenty of room for diachronic bottom-up explanation in this picture. Sometimes when I defend the Aristotelian view, people assume that I'm saying it's all top-down, so there's no bottom-up influence or constraint at all. That's certainly not the case. So Aristotelians should, I think, take the Schrödinger dynamics, the wave function, to be grounded in the essences of the relevant substances. Right? So it's the substances of the world that have certain essences. Those are what ground the Schrödinger dynamics. So for contextual quantum mechanics, if there's no cosmic wave function, it seems pretty straightforward. You can say that the contextual wave function is always grounded in the essences and accidents of the substances involved in that particular wave function. Now, in the case of a cosmic wave function, it gets more complicated, I think, because substances come into and go out of existence over time. So which substance is it that ground the wave function, cosmic wave function, at any given point in time? Well, presumably it's the substances that exist then, right, that do that. But then does that mean that the cosmic wave function itself is constantly coming in and out of existence as new substances come online or substances go out of line? And there's a worry here that both Alex Cruz and that William Simpson has pressed, that this kind of story leads to a kind of, either to a dilemma here of, to a sort of dilemma that is either the cosmic wave function and Schrödinger's laws are over-determined, right, determined by the essence of each substance individually, and therefore massively over-determined, or we face the problem of how to parcel out responsibility for different parts or aspects of the quantum wave function among the various substances in the world. And that's a non-trivial, it seems to be a pretty non-trivial task. So my suggestion, though, is that we try to address that. So rather than just avoid it. So there's a choice here again between a cosmic substance as the ground of the cosmic wave function or a cosmic group. And so I'm going to press here a kind of analogy with Aristotle's conception of the city. So in a sense, the cosmos is a sort of city, and the substances are citizens within the city. So in the case of the political realm, citizens are substances, right? And cities are not. So cities do not constitute substances. The possibility of the city depends on the essences of individuals. So it's the essence of individual human beings that are driving that possibility. Nevertheless, the citizens of a city are deeply entangled. There's a kind of political entanglement, very similar to the quantum entanglement. You can't give a complete explanation of what's going on in each individual citizen except by referring to the social relations that individual has. And citizens can survive the gain and loss of individual citizens. Cities can survive the gain and loss of individual citizens while still being the same city. So it seems in the same way one could argue that the quantum wave function persists as a kind of joint activity of substances, and it persists even though substances are coming in and out of existence over time. They say it seems to me a possible line to take. Choice point 7, if we did decide that there's a cosmic level substance, so I disagree with my view about the cosmic group, we face another choice, which is, should we have just that one substance, the whole cosmos, and demote everything else to a non-substantial kind of status? Or does the cosmos coexist somehow with localized substances, right? And so this brings us, Jonathan Schaffer's defended this sort of view of priority monism that really, he doesn't use the substance language, he's not Aristotelian, but if I were to translate Schaffer into my language, he's basically saying that the cosmos is the one and only substance, right? The only thing that's fundamentally real and everything else is a fragment of the cosmos. Whereas Aristotelians, I think, are going to argue that we want to have these individual things, middle-sized things, be substances, right? So now the question is, can you have them both? Can you have a cosmic substance and individual ones? And there you run into what Schaffer calls the tiling principle, which I think is a very plausible principle, which is that if you look at all the fundamental things in the world, Schaffer argues, that they shouldn't overlap with each other. They should be jointly exhausted, but they should be individually disjoint, right? Because after all, if they're fundamental, right, and they overlap, then it looks like that overlap is going to be overdetermined in terms of its nature, right? And if it doesn't exhaust the reality, then there's new stuff floating around that doesn't have no fundamental basis at all, and that also seems pretty weird. So I think, in fact, Aristotelians should agree with Schaffer here, that some kind of tiling principle is reasonable. So I've got what I call an Aristotelian tiling constraint. Everything is wholly composed at that time of substances, parts or accidents of substances, or remnants of substances, and no substance overlaps any time another substance or a remnant of another substance. So I won't go into what remnants are, I've got a paper on that, but the substances can leave remnants behind. But in any case, that principle is still pretty plausible, and it's going to create problems for the view that has both cosmic substance and individual substances, because you might assume, actually, that the individual substances would be parts of the cosmos, and that would violate this tiling constraint, would create these problems of sort of metaphysical overdetermination. It's a bit worrying. Now, what's wrong with cosmic monism? It doesn't fit into, again, I'm a metaphysician, but I often resort to epistemology. So I think one of the main problem with cosmomonism is that it doesn't fit in well with an Aristotelian essentialist epistemology of science, right? So we understand things in Aristotle's view by understanding the essences of substances, right? And that means discovering their real definition. But we never study the cosmos as such, right? Because it's a one of a kind by definition, right? So we can't really fit it into a species and then construct a Porphyrian tree of genera and differentia and so on. There's just the one thing, right? And then we can't apply a kind of Nancy Cartwright study of the cosmos by putting it into an homological machine and interacting with things with it. So there's something sort of mysterious about the cosmos if it's a fundamental entity, if it's not just a collection of substances that are themselves fundamental. Now, William Simpson has proposed recently a version of this that I think avoids some of my objections. So you could say that actually there are both the cosmic substance and the individual substances, and they don't overlap, right? So in this case, the way Quilliam works it out, there's various ways you can do this. The particles are parts of the local substance at the point of creation, and then immediately become parts of, after that, of the cosmic substance. And the particles are constantly being created, so the substances have something to do. They're sort of responsible for these stochastic creation events and annihilation events. One difficulty, we talked about this with him yesterday, is it does look as though these substances will have a kind of gappy existence, because in between creation events, there will be nothing there, so to speak, except the substance itself. And that resembles sort of the soul in the intermediate state, I guess. So maybe you could just combine those two problems in one and resolve them in some way. But it does seem to be a bit difficult.
We'll have to wrap up around a minute.
One more minute? Yeah, I'm good. Just about there. So do we need a cosmic substance? I think it would be anomalous in various ways. It would be an impassable thing outside of space and time. And to me, there's a danger here of falling into a kind of Malebranchian occasionalism, where it looks more and more like the cosmic substance is something like God. And then the difficulty is going to be, science would then become literally trying to think God's thoughts after him. God's intentions are pretty opaque most of the time, I think. Much easier to understand if those intentions are realized in particular substance natures that we can study individually. So I think that's, again, plausible. So I've got this idea of, one last point then before I run out of time. How to divide responsibility. I think if you look at an algebraic kind of approach to quantum mechanics, then it turns out that you can look at the sub-algebras of the algebra of the cosmic wave substance as restricted to some space-time regions. And so that is maybe a natural way to divide responsibility for the wave function among the various individual substances. So anyway, there's my very tentative conclusion. Let's get there.
I don't know why that went off. That was perfectly timed, I see. Is this yours? Or oh. Okay, now we're going to try a really fancy thing of getting a friend in, Professor Halverson from Princeton, and a video to play that has been pre-recorded. So we're going to try to access, talk amongst yourselves for a minute or so. I'm going to try to access the Dropbox and get it up now.
Coffee. I feel like we might have been served decaf this morning. I feel like.
Oh, at breakfast.
I just feel so tired.
A certain level of tiredness, caffeine doesn't really help. It just makes it feel jittery.
Yeah, how they painted these little guys. Must have taken forever. It looks like there used to be paintings in all of these squares around. Yeah. I wonder what happened to them. Right?
Yeah.
I wonder what happened to them.
This is outlook here in the access. Oh, you mean you've already said it? Okay. And I think it can't be I've sent it. So, what's the name? What's the Greetings from North America. Okay, we have a pre-recorded response, and then we will have discussion in the room. And Professor Halbert. Thank you. We will have a short video prepared by Professor Halverson, and then he's joined us from Princeton live to interact with the two speakers and with all y'all, as some of us used to say. Here is his response. Can you hear it?
I'm grateful for the chance to join you virtually since I couldn't be present in person, and I'm grateful for the chance to comment on these interesting papers by George Ellis and Robert Koons. Let me point out that my comments here will be based on the preprints of these papers, and so there might be a slight mismatch, at least in emphasis, with what you just heard. Ellis and Koons make some strong claims, and claims that go against the grain. It's one thing to take a stand against microphysical reductionism, and quite another thing to tether one's wagon to Aristotle's natural philosophy. But it's the latter course that Ellis and Koons take, and urge us to take. I myself am not convinced that Aristotle was so prophetic in his vision that he could have anticipated the issues that we face today. But I'm not going to bicker about that point. For me, and for many of you, I suspect, the most interesting choice point is whether one is going to adopt the program of reducing the manifest image to the scientific image. Ellis and Koons urge us not to adopt this program. They urge us to adopt what may seem like the opposite program. So what is interesting is the arguments they give against the reductionist program. In my comments, I'm going to focus on three strands of argumentation. First, the argument from top-down causation. Second, the argument from elementary quantum mechanics. And third, the argument from the quantum theory of infinite systems. There is no longer any orthodoxy about causation. Some philosophers agree with Bertrand Russell that it is a relic of a bygone age. Other philosophers think that causality does have a role to play, but only really at the fundamental level, which they identify with the microphysical level. There are even philosophers who agree with Russell that causality has no place in fundamental physics, but does have a place in the manifest image of the world. George Ellis has a rather nuanced view of causality. He claims that each level is relatively causally autonomous, in particular has its own causal laws. And yet he claims that no physical level is causally complete. How these two claims hang together is not totally clear to me. but so far the disagreement with the standard reductionist is not that great. A standard reductionist might be willing to grant that, say, the laws of hydrodynamics are relatively autonomous from the laws of microphysics, but that the world of fluid flows is not causally complete. Where Ellis's view is likely to raise the hackles of philosophers is his claim that there is top-down causation. I have many questions about top-down causation, some of which may be answered already in Ellis's other papers, and which I hope he might take the occasion to comment on here. First of all, what is meant by macroscopic constraints controlling micro-level dynamics? Is this just the claim that macroscopic creatures such as ourselves are able to implement micro-level dynamics, for example, to set the Hamiltonian of a certain quantum system? If so, then won't the reductionist just answer that there is no proof of the causal incompleteness of the microphysical, since the microphysical is thought to determine the causal agency of creatures like us? In other places, Ellis hints that certain macroscopic forms play a causally determining role vis-a-vis the microphysical. At one place he mentions macroscopic circuit topology as causally relevant, and yet not reducible to microphysics. Here Ellis is on to an interesting issue that comes up repeatedly in physics, and especially in so-called gauge theories. For example, in the Aharonov-Bohm effect, the microphysical dynamics is also sensitive to the global topology of the underlying phase space. I grant that holism does appear in several places in contemporary physics. However, it's not immediately clear to me that this holism belongs to the macroscopic, in the same sense that medium-sized objects belong to the macroscopic. After all, the phase space the topology of phase space is not exactly part of the manifest image. I now turn to the second issue, that is Robert Koons on the measurement problem of quantum mechanics. As Koons points out, Heisenberg himself claimed that quantum physics opens the door again to Aristotelian potentia. But is there anything like an argument here? Can we make the theses of Aristotle precise enough so that quantum physics could be taken to provide positive confirmation of these theses? That would be what we might call what Abner Shimoni told us to call experimental metaphysics in the best possible sense. Let's consider the infamous measurement problem in the formulation given by Tim Maudlin as an inconsistency between three claims. First, measurements have outcomes. Second, the wave function is complete. And third, the dynamics is linear, or put even more technically, unitary. This formulation of the measurement problem is slightly different from the one that Koons gives, and we might ask how they're related to each other. Or more importantly, does the Aristotelian have the resources to solve the measurement problem? There are some ambiguities here in the statements, both of Koons and of Ellis. At places they mention that the microphysical dynamics needs to be stochastic so as to provide room for downward causation. But in that case, they seem to be rejecting the premise of linear or unitary dynamics. And if that is what they are doing, then their move might backfire on them. If they're willing to reject the Schrödinger equation, then why not adopt something like the GRW theory that promises to maintain the causal integrity of the microphysical realm, and which would be a triumph for microphysical reductionism? After all, the GRW theory is a favorite of those who are committed to the microphysical reductionist program. I suspect that Ellis and Koons, upon reflection, would also be troubled by the statement that the wave function is complete. It does sound a lot like some kind of statement of causal completeness. However, in the typical case, rejecting the completeness of the wave function amounts to accepting yet another more microphysical layer of reality, for example, the hidden variables of Bohmian mechanics. But perhaps, and again I invite them to comment on this, perhaps Ellis and Koons would suggest that the wave function is incomplete in a different sense. But in what sense? Finally, I turn to Koons' interesting invocation of facts from the quantum theory of infinite systems. Here the claims are quite controversial and quite technically daunting. To be honest, I myself would be greatly surprised if the fate of Aristotelian natural philosophy depends, for example, on the mathematics of infinite quantum systems that are beyond esoteric in a certain sense. But nonetheless, it's worth asking what role these considerations are meant to play in Koons' account. I can see two distinct options. First, the quantum theory of infinite systems may be taken to be the solution to the measurement problem. Second, the quantum theory of infinite systems may not be taken to be the solution of the measurement problem, but it might show other ways in which the old mechanical philosophy and microphysical reduction in general is inadequate. I will leave aside the first possibility as it has been argued quite convincingly by others that moving to the infinite limit does not solve the measurement problem. However, what happens at the infinite limit is indeed interesting. Essentially what happens is that a single quantum state space breaks into a plurality called the superselection sectors of the system. And the distinction between these sectors is, in a certain sense, classical. That is, each sector corresponds to a value of a quantity that has no conjugate, as for example, position has momentum as a conjugate, and so this super-selected quantity can be always definite, that is, always have a value. Koons indicates that the distinction between these super-selection sectors is macroscopic. I quote, "Two situations can be microphysically indistinguishable and yet chemically and thermodynamically different," end quote. That is certainly true in some cases in quantum thermodynamics, but unfortunately it is not always the case. For example, in quantum field theory, the superselected quantity is itself a microphysical quantity, typically called, in the generic sense, the charge. Nonetheless, I don't think this is a damning point against Koons' use of quantum theory of infinite systems. In fact, it may be a point he can accommodate, namely that non-quantum forms, so for example, the form of the quantity related to superselection sectors, are not necessarily macroscopic forms. In conclusion, Ellis and Koons ask us to bring physics into interaction with the manifest image of the world. That is, to take seriously the call for consistency between theory and appearance. The task, as we've seen, is dauntingly difficult, and I'm grateful for their courage in facing it. Thanks, and I look forward to the discussion.
George, for the discussion, if you're here, then Professor Hoffmann will also be able to see both of you because of the camera's angle. Let's try to get him up. All right. Professor Hoffmann, would you like to make yourself seen to us and heard? Ah, there you are. Hello. Could you speak and see if we can hear you here? Would you?
Hi. Good morning.
Excellent. We'll go forward directly then with, we've just watched your video. I don't know if you watched us watching your video, but we watched it. Yes. The fifth wall is going to be torn down eventually. Can you see your two, those who you're responding to? Yes?
Yeah, always good.
Okay. Let's go forward then. I will make myself scarce.
I can't really see him though.
Oh, you can't see him.
Unless he sees the back of my head.
Working over you.
I can try to get into the Zoom call, so maybe we can start with the
No, it's all right.
Let's start with the question, and I'll try to get my computer into the Zoom call.
You can see my profile, yes.
What, do you want to stand here?
Well,
Well,
yeah.
it's connected to everything. I'm
Yeah,
just a little.
Yeah.
Okay. But I think I can. It's a discussion first, so actually, he asked a few questions. If you want to jump in and try to answer them in turn.
Yeah, well, thank you for the response. Firstly, effective laws at each level are what we determine in physics, we determine in the special science. How do we do it? We do it by setting the context so that we can determine the special laws. So it actually, you set up a laboratory, you set up certain apparatus in precisely such a way that you can verify what the laws at those levels are. So there's no paradox between them being affected in the top-down and existence of those laws, because that's what the whole of science does. It's what all of those laboratories, chemistry, biology, microbiology, that's what they're all doing. So I don't think there's a problem there. Now, the Hamiltonian contains two things. It contains a potential in general, and it contains some constraint terms. And those are what describe the context. And so you have to ask yourself always with a Hamiltonian, where does that potential come from? Let's take a very, very simple example, the two-slit experiment. How do you describe that in quantum terms? And you have to have either what you can call it a constraint or a potential, which tells the Schrödinger equation there's a two-slit sitting here. Where did that come from? And it came from the context above. And so one kind of just says to yourself, there's a potential, and I take it for granted, or maybe there's a constraint. But the question is, where did those come from? And they came from the person who set up the experiment in order that it would represent two slits. And so that potential term is not in itself expressible in quantum terms. If you express the potential in quantum terms, you'd end up in an impossible cycle of indeterminacy. And so I personally don't think that there's a problem in that case. Now, a further really interesting point, which I would like to just mention, is quantum field theory. I've talked about creation of elements at the lower levels. And if you ask how does that happen through quantum theory, the answer is it happens through quantum field theory, creation and annihilation operators. If you now look at any textbook on quantum field theory, you'll find a long description of creation and annihilation and what they do, but what you will not find is a statement when does a creation or annihilation operator act. And I've actually spent I've talked with a couple of people about this who are experts in quantum field theory, and actually the action of the creation and annihilation operations is determined by the higher level context. For instance, I send a photon down onto a photodetector, and that causes the creation operates, or a photon arrives at a leaf or in your eye, and it sets in chain a set of conversions whereby the photon is absorbed, annihilation, and an electron is emitted, and so on. And so I think all of those fit in within the general viewpoint that I'm expressing. And if you're asking what is my definition of causation, I go with the view that definition of causation is difference making, whether counterfactual or experimental. I think that's what I'd want to say.
Do we get Hans respond to that, or do you want me to do?
Yes. Would you like to respond directly to that, Hans?
Yeah. I don't think I have any. So I think my feeling at this point is largely curiosity, because I agree absolutely in principle with. So let me actually give you an example that's maybe a little bit controversial. At least I hope. If there's, I can't see everyone who's there. If there's any convinced Bohemians in the audience, I may get in trouble here. But so I would say, for example, the Bohemians who say, look, our interpretation is great because the observer does nothing in our interpretation, right? The observer is out of the picture, and my reaction to that is. No, not at all, because where does the Hamiltonian come from? And in typical cases, right, it's actually, so I think one problem in these discussions often is when people talk about the observer, they're forgetting, right, the physicist, set aside whether it's an observer or not, the physicist is the person involved in setting up the experiment and so on. So I completely agree in principle that there is this, the lurking free variable, so to speak, of the Hamiltonian that's involved in all of these interpretations. I would say, I'm not sure yet how strongly we should take that as, so in general, of course, we have this issue that, laws are something that remain unexplained, right? Laws in the typical sort of natural philosophical approach. I know we're now getting already into very controversial territory because on a more Aristotelian approach, we wouldn't want the laws really to be fundamental. In some sense, we want the powers to be fundamental. But in general, people are happy enough to say once we have the laws, those don't need to be explained. Those are just sort of the unexplained explainers. And yet, of course, in the actual practice of quantum theory, we typically are talking about local systems, and local systems where we want to have free parameters we can adjust in the laws. So, like I said, I think I don't really have a strong point to make. I think I'm just largely curious about the role of the Hamiltonian and its free variables, and I think it's really great that Professor Ellis has brought this to our attention in a way much more vivid, and it's typically, I think it's typically sort of pushed under the rug, this issue of the Hamiltonian.
I just want to make one further point. So firstly, you have to ask where does the Hamiltonian come from, but prior to that, you have to ask where does the Hilbert space come from. And people are complicated. They just take for granted there's a Hilbert space. Who decided what the Hilbert space is?
That's a great point.
Maybe I should respond briefly. So yeah, Hans, I agree almost everything you said. I guess, so I do make some bold points, but I don't think quite as bold as you attributed to me. So I'm not really claiming that Aristotle provides the only solution to the measurement problem that's possible. Right? I mean, obviously, yes, there are alternatives. And I've tried to, I've written on the many worlds interpretation, trying to criticize that. I think, as you say, there's problems with Bohm. But GRW, sure, that seems like a very viable option. But now let's just look at the situation. Right? We've got now multiple proposals on board now. The one that I'm advocating is, I think, well supported by the actual practice of science. By the way, chemists and thermodynamic scientists actually practice. Whereas GRW is at this point, completely speculative idea for which there's no confirmation. So at the very least, I think, the Aristotelian position should be treated as a serious contender, right? Something that we need to develop and to continue to compare to the other options. And then the point about the infinite system stuff, I appreciate your feedback on that, because I'm very interested in learning more about how this would work. So I think you're right that I don't think I had to claim that these superselection sectors are all macroscopic. All I need to claim is that some of them are macroscopic, right? And then I think I've got enough to make the case that there are fundamental properties at the intermediate level as well.
Yeah, let me just add one. So so not everybody's had the chance. I would encourage them. So Rob, now you have several papers, both completed and in progress, and I think they're a great benefit. And one thing I thought was really wonderful about your papers was the actual incredible intellectual humility you show, saying, that sure, there's resources here. I'm not saying, I noticed repeatedly that you repeatedly said, I'm not saying there's a proof here. I'm saying there's resources here to understand. And I actually think this is one of the most refreshing ideas. So let me say a real point of commonality between your view and something I've recently become more and more convinced of is there's a very strong urge in contemporary analytic metaphysics toward what you might call some kind of actualism. And that includes, of course, David Lewis, the arch anti-actualist. But still, it's strange because Lewis, he still believes everything has to be reduced to what's actual. He just increases the scope of what's actual to all the possible worlds. Right. So I think this is one of your most strong claims, but also I'd say I'm increasingly convinced of this, the role of the possible, right? So in other words, saying don't try to eliminate the possible, and I include in that sort of, I would love to hear more about your views on this, but the idea that form is, in a certain sense, active. I think this is a really fascinating idea. So form is, I think this is common between you and Professor Ellis, form is explanatory. And so I think that's one of the most, an idea that really would push against unorthodoxy and analytic metaphysics.
Yeah, absolutely. Thanks.
We could at this point open up for broader discussion. We're operating on a 15-minute delay, so we have another 18 minutes. Is that what the schedule? I've lost my schedule. Yeah, so we have 18 minutes, right? So we're operating on a 15-minute delay. Yeah, good. All right. Yeah. So then so we have about 18 minutes for discussion or questions. Yeah, please. What I'll do is this. I'll take note of you if you put your hand up so that you don't need to compete with one another. We'll start with you, and if you have a small point, I think I got everyone up there. If you have a small point that's on point, you want to jump in and skip the queue, you can do that, but it needs to be quick, like 30 seconds or less, and I'll be the judge of what's 30 seconds. So if I had...
Yeah, John Pemberton.
John Pemberton.
Yeah, great. So thanks both. I mean, there's so much to ask you, but if I could just focus on one specific point, the downward causation which George Ellis talks about, which I'm just really interested in how this is, works for you. So
please speak quite loudly.
Okay, so one question I have, George, is the downward causation you envisage synchronic, or is it a diachronic form of causation? And I guess going with this question is the thought, downward causation is often thought problematic because the whole is then thought to cause change to the parts, whilst the parts are surely causing change to the whole. So one has this concern about self-causation. So I'm just interested in how you overcome those concerns about self-causation.
So is your self-causation?
Yeah, well, is downward causation diachronic or synchronic?
It happens in both. Firstly, it happens in both forms, and secondly, you do get causal circular causation. That's part of what's happening. In fact, that's what I was saying. The thing is only causally complete when you take the whole loop into account. So circular causation, yes, it happens. Yes, it does. An example is the ion channels, where the ion channel opens in response to the voltage, and then the ions flow through, and then they alter the voltage, and then they close the channel. So that's a classic case of... But
that's linear form of causation. That could be linear causation.
That could be linear causation.
Non-circular, you're saying?
Non-circular. Just one, the ion channel opens, something else happens, you get a transmission down the neuron.
So in other words, you don't get a cycle of events, right? You get a linear ordering of events at different levels. Is that right?
Yeah.
Well, it's happening across different levels because the ion is a lower level in physical terms than the ion channel, so it's downward causation in that sense. But in time, it's a linear series of events. The channel opens, the current flows, then because the current is flowing, the voltage is changed, the channel closes, and that's where those spike chains come from, which occur in our brains. It's where the spike chains come from.
Thank you.
Would you pass it to the fellow there with excellent beard? What's your name?
Paul.
Paul.
Yeah. I have a question for Professor Koons. So the first question you addressed on the cosmic wave function.
What?
The first question about the cosmic wave function.
Yes.
Such a thing. And you mentioned that in order to make sense of the wave function, we need something like context or a heat bath.
Yeah.
And I was thinking the way an Aristotelian might want to solve this. So Aristotle has these things as potential parts, but what about the contrary, having potential holes? So some word that is like junky in this way.
Yeah.
And we wouldn't have so it wouldn't make sense to talk about the wave function of the universe because there's no such thing as a universe.
Right.
But you would, for every system, you would have a context.
Yeah.
Or feedback for which, and I wanted to hear what would you think of such a proposal?
Yeah, that's a really interesting possibility. Yeah, so as you all know, the junky world is a world where there are wholes and parts, but no ultimate whole, and the wholes encompassed is a proper part of something still larger.
So yeah, if there were a junky world, then there'd be no cosmos, and so no cosmic wave function. That's right. And I'm certainly open to that possibility. I think that possibly makes sense. I mean, I think what we typically think of as our universe, right, seems to be the sort of thing that is bounded in some way. But of course, it could always be part of some larger whole that we're not aware of. That's true.
Alyssa, I have Alyssa and then Mateusz, and then I'll go down the line here. Yeah.
I guess I have a lot of questions about the cosmic wave function, but maybe I just was irresistible on the non-locality, and it doesn't matter if you're losing negative powers.
Yeah.
Just if all of a sudden something you did made me not be able to raise my hand or something, what does it matter if I'm gaining or losing? It's still like very puzzling how that could work.
Yeah, I mean, it's admittedly there's something sort of counterintuitive about it. The idea that these kinds of power manifestations can be coordinated at a great distance. It seems to me that you're sort of forced to accept that to some extent. I don't know any way around it.
Unless you have that word interpretation.
Well, okay, right. Good. Well, I'd like to hear about that. And that would be good because I mean, in general, Aristotelians like locality. So this is something we have to try to accommodate. But I guess the thought again is epistemologically, it's relevant. So if I can tease out certain causal interactions, and I can be confident that the powers that are being exercised are local powers, right? Then I can gain some insight into the essence of the thing involved. Right? Whereas if changes or powers could be acquired, changes occurred by virtue of some completely non-local agent, distant agent, then that creates, I think, a real serious epistemological problem. So I just see an epistemological asymmetry there.
Is this a little one? Okay, after you're done, then please pass it to the first Dominican on your left.
So just to, sometimes part of the explanation of what happens involves things that can't happen, and so losing a dispositional property is like about what can't happen, and that's part of the explanation of what does happen. So I'm not sure I can see the epistemic asymmetry.
Tell us your name.
Right.
Oh, Aaron.
Okay.
I'm Marius.
Good point. I'll think about that.
So that's a question or comment. There is an effect in quantum theory that deals with interaction with the fundamental level of, let's say, quantum vacuum fluctuations and the macroscopic bodies. It's called the Casimir effect. I had some work in it, William Simpson as well. So do you think it could be useful or interesting to deal with, understand such effects in a way that there we can do like rigorous mathematical quantitative predictions and try to grasp this interaction between the fundamental level and the macroscopic objects, actually without even having the measurement. I mean, the macroscopic body is not involved in the measurement, it just changes the quantum state of the vacuum, and eventually it gives like macroscopic force that attracts all of the plates, let's say. Do you think that this could be interesting for this discussion about the interaction between fundamental level and macroscopic bodies?
The Casimir effect. He's talking about Casimir effect is a good case in which you've got a macroscopic object acting on the quantum vacuum.
Yes, absolutely. I agree. Yeah.
Did you want to comment on it, or do you?
No,
you affirm.
Yeah,
I agree. I like it.
You can follow up if you want.
No, I will do it here. Or maybe if the Professor Hans Carlson wants to add something.
About the Casimir effect, Hans, did you have any thoughts on that?
Okay,
We don't hear.
Sorry, I was muted. But are we talking about the same? Is this another name for Rindler Unruh? Is that what you're thinking?
I didn't hear. What?
Is it another name for?
Is this the observer in the vacuum with the many particle creation? Is that what you're thinking of the Casimir effect?
No, I'm talking about the vacuum, the quantum vacuum, the electromagnetic field vacuum that interacts with let's say plates. That's the original case for the Casimir. It's not connected with this creating of particles. It's a different effect. you have two plates, let's say, that just in the vacuum they attract each other because of the interaction of the quantum vacuum with the macroscopic bodies.
I can't. It is an example of a top-down effect from the plates to the vacuum. I'd like to add in that to me one of the most spectacular effects in quantum physics is the Aharonov-Bohm effect, which is a non-local effect, and it cannot be described in a local way, and I think it's a fantastic example.
That's another,
So let's do it like this. We're going to just keep passing the microphone. We'll collect them in groups of 3. So if you would ask your question and then pass it, and then we'll have the answers. So do speed rounds now to get. So
like speed
Okay, mine is pretty. I have a rather basic question for both of you about what talk about formal causation amounts to. And we could rephrase it as, what does it mean to say that A is a formal cause of B? Would it, for instance, mean that A is a shape and B is a composite object truly describable as having shape A, and that A synchronically or diachronically determines the type arrangement and interactions of these components? Similar analogous question could be formulated for the correct criterion for Professor Koons' account.
you got that?
Are we going to answer?
I think we should compile. We should compile.
Yeah, go ahead. Yeah, I'll remove that. So just a question about what formal causation is exactly. Is shape an example of formal causation?
Yeah, it's shape. Shape is what I would define as formal causation. Form and shape. Form is shape, so from my viewpoint.
Yeah, I would think of shape as just one particular kind of form. There are actually many others.
Okay.
Yeah.
But let me just add something. There's a very interesting question. How does quantum chemistry describe the shape of molecules? That's actually quite a difficult question.
This question is for...
Please give us your name, sir.
Howard Robinson. Yeah. This question is for Professor Ellis. You cited many cases of where there is top-down useful explanations for certain purposes. But what you need to show is that under those circumstances, the bottom level, the atomic, subatomic, is not behaving according to the rules, as it were, that the physicists would say they are, that they're being interfered with in that sense. It wasn't clear whether you thought that they were, or whether, if they're not, whether that really makes any difference to the claim that there's completeness under physics.
No, this is a major misunderstanding. I'm not saying that top-down action changes anything at the physics level. What it changes is the context within which those physical laws are acting. If I have Maxwell's equation, I say, tell me what's going to happen as a result of Maxwell's equation. You say, I can't tell you until you give me the context. Maxwell's equations by themselves don't determine anything whatever, nor do Newton's laws. You have to say, what's the context? And that's what a downward causation, or what these things do. So I am not claiming any change in the laws of physics because of downward causation. And that, I've been accused of that on various occasions. It's not what I'm claiming. Physics is absolutely the same everywhere in the universe at all times as far as we know.
And does that mean that Laplace's demon, who was a real demon, and it could also allow for the input from outside, would still tell you what everything was doing then? If he could,
so the Laplace's demon at the micro level.
Yeah, if he could tell you about, he could tell about the inputs from the context as well at the micro level.
So when the Laplacian demon would have access to the context as well as the law, so couldn't it predict everything from the bottom up?
Well, we've been talking about open systems. They have a boundary and it doesn't work for them, as I explained in a lot of detail yesterday. Your brain cannot explain what you are going to do in half an hour's time because other things are going to impinge on your brain from outside. So the Laplacian demon is simply not able, because you're an open system, to predict what you are going to do in the future. It's not possible.
I mean, if the conditions are not themselves microphysical, then you haven't established the...
And the example I gave yesterday was a woman driving a motor car and all of a sudden her car runs into another car. So now her brain has got a whole lot of new information which she did not have before, and if you had total information about what her brain was before the accident, there's no way it can predict what she will do after the accident. So Laplace's demon it's irrelevant basically with an open system.
But the demon would know also the movement of the cars and everything, yeah?
But then you're just positing God at that point, right?
Right. So, I mean, that's just, but in a sense, that's begging the question, I think, against the Aristotelian. You're saying that the car and its collision and so on is nothing but microparticles. That's what the question.
No, but it isn't. It's how the driver of the car behaved. That whole thing.
If I may, I have
your name?
Question. Chris Oldfield. Hi Hans, thanks for your work as well. I have a question about Schaffer's tiling constraint and the notion of there being non-overlapping individuals in a merological sense of overlapping, but in the same place and at the same time, of categorically different types. So if you have an activity in virtue of which somebody is where its parts are, for example, that's a categorically different type of thing. I wonder, Hans, if it might relate to your subject-object distinction.
It's a question. There was a question for Haan. There was a question for Hans first. Did you want to answer that?
So it's relating actually to a line in the Metaphysics where Aristotle says form is energeia.
Right.
So I'm wondering about activity in the same place as object.
Right.
Whether that would violate the tiling constraint.
Yeah, so the tiling constraint, first of all, does not say that you can't have two things in the same place at the same time. Right? It's a constraint on mereology. And so, so I would say, you know, the activity of my activity and me, right, are probably located in the same place, but they're not. It's not a part of me, I think, and so that wouldn't violate the tiling constraint.
You probably have time for one more. Hans was going to answer. No, you were addressing that to Hans.
Well, it's got a kind of edge of standpoints of subject and object. If a subject can be in the same place as an object in a totally different way. I just wondered what you think.
Yeah, I'm not so sure about that. I guess I think subjects are objects in some sense.
He's an objectifier.
Yeah.
Would anyone else like to one last question or discussion point?
Ignore it. Really ignore the anything.
Tell us who you are.
My name is Ewan. This is Hylomorphism, what we was. Because I'd like to ask if I've interpreted this discussion on the class's demon properly, should we see the tendency of the question and the response to the question, this question on context, as pointing, as showing the tendency of microphysicalist reduction towards a cosmic monism? In other words,
towards what?
Towards a cosmic monism, in the sense that yes, you can do microphysicalist reduction, but because of because of the closed systems which Professor Ellis is pointing, in order to do that, you have to embrace a sort of monistic, totalizing account in which one can give an account of all contexts and all parts in order to work.
Yeah, I've got a question for George that's related to that. Maybe it could fit to my question. So in cosmology, if we apply quantum mechanics or something to explain it, there's no context, it seems, in that case, is there? How would you?
Well, I'm personally very skeptical about quantum cosmology for a whole number of reasons. The Wheeler-DeWitt equation, which is usually supposed to underline it, is not a well-defined equation. It was actually rejected by DeWitt. Eventually, he called it that damned equation. The way that solutions are supposed to be obtained for it are very dodgy, and there's not the slightest evidence that the Wheeler-DeWitt equation actually describes anything whatever. So I'm a skeptic.
That pushes against the cosmic monism, I think, is what I'm saying.
we'll have to end with that bombshell. We'll have to end this session and thank the speakers and thank Professor Halverson. Are you staying with us for more of the day on Zoom?
No, unfortunately, I have to run off to my next thing. And it was a great pleasure to feel like going from a distance, and I really look forward to reading more of his work.
Thank you for that. We're recording the day as well, so these will be up on our YouTube channel eventually if you want to drop in later. So thank you so much. We'll give a round of applause. Happy is in the hall, and I'm now going to draw a few maps to direct you toward the hall.
Yeah,
What,
through the maze.
What we'll do actually is just if we go down.
Time's up.
No, it's a builder. It's a special place in hell for builders. Now, what we'll do is go down the stairs carefully, and then we need to turn right and go under the tunnel, and we're going into the hall. So it's basically just to the left of the St. Cross, the All Souls Hall, and we're going to have a slightly truncated break, so about 20 minutes to try to catch up a little bit of time. is also sometimes unheard.
Okay. Welcome back to the second part of the first session. We're a bit behind schedule, so I'll be very brief, but hopefully not polite. I'm delighted to introduce Professor Alyssa, Professor of Philosophy at UC Davis, whose research focuses on fundamentality and interpretation of quantum theories. Alyssa is the author of The World and the Wave Function, Metaphysics for Quantum Physics. I'm also very pleased to introduce Dr. Emily Quershi-Hurst, who is a junior research fellow and college lecturer in philosophy at Oxford, whose research spans many areas: ethics, philosophy of physics, philosophy of religion, and is the author of, working on at the moment, to finish the book on God's salvation, the problem of space-time. Congratulations.
Can you say the title again? God's salvation
and the problem of space-time.
Oh, yeah.
Alyssa will speak to us first, followed by Emily. I'll give 9 to 10 minutes response to both papers, and hopefully after that we'll have some time for Q&A if John gives us the green light.
We'll see.
Well, thank you so much for having me here and William for the kind invitation. So I was asked to talk about this account of how middle-sized objects come out of the wave function. If you think the wave function is fundamental and what's everything that I gave in the last chapter of my book, The World and the Wave Function. So that's what I'm going to talk about today. There'll be a lot to kind of build up to my solution because there are some problems that I need to explain, but just to kind of give an overview of the background, where I'm starting from. In this book, what I was trying to develop and defend, get clear on the arguments for, was this framework for providing a metaphysical interpretation of quantum theories called wave function realism. Now there are many ways of being a realist about the wave function, but what I was interested in this book was developing this framework that's been promoted, especially by David Albert and Barry Lower, according to which any kind of quantum theory is going to be fundamentally about the wave function interpreted as a field on a high-dimensional space with the structure of a configuration space. So that framework could be applied to different quantum theories to give different, more precise ontologies. So we could look at non-relativistic versus relativistic theories. You'd have a different kind of notion of a configuration space there. You could apply wave function realism to non-hidden variables theories like collapse theories, Everettian quantum mechanics. Like I prefer, you could also apply it to hidden variables theory like Bouverie mechanics, like David Albert likes to. Either way, you're going to take a wave function as a field in high-dimensional space to be like either all of or a lot of the fundamental ontology. So let me just, it's going to be the idea of the configuration space is going to be very, very important to the whole discussion today of the recovery of middle-sized objects. So let me just be clear what we're talking about here. So the notion of configuration space isn't special to quantum mechanics. It was developed in the 19th century to model classical systems. So like, for example, we can talk about a simple system of 2 points in a 3-dimensional space. And if we want to, capture the evolution of the positions of those particles over time, we can use 2 points in a 3-dimensional Cartesian space to do so. But we could also represent them using 1 point in this higher dimensional configuration space. In general, for the configuration space, it'll have 3 n dimensions, where n is the number of particles in the system. So here we're talking about 2 particles in a 3-dimensional space. If we wanted to represent that in a configuration space, we would use 1 point in 6-dimensional space. To say it's a 6-dimensional space is to say any location in that point is captured by, can be captured by 6 numbers. And here the intuitive idea is like 3 of those numbers, like the first 3 will correspond to the x, y, and z coordinates of the first particle in the low-dimensional representation. And then the next 3 numbers, the next 3 dimensions will correspond to the x, y, and z coordinates for the second particle. So that's like, there's a natural mapping between the representation of a location in this high-dimensional space and the locations of a system in 3 dimensions. So that's just like how configuration space representations work in a classical setting, but of course in quantum mechanics, we think that particles generally don't have definite locations. Instead, you can think of them maybe somehow, if you like, as fields kind of smeared out over that space where their locations are indefinite. And in that case, when you move to the kind of higher dimensional configuration space representation, again, you're going to have something that's more smeared out like a field. And one of the arguments for wave function realism that I discuss in the book, The World of the Wave Function, because it's one of the arguments that has been used by especially Jill North and David Albert when they try to defend this way of viewing the world, is that actually it's not possible. So in the classical case, you can move back and forth between the low dimensional, the representation of the system in ordinary space and the representation of the system in configuration space. Nobody thinks a configuration space is the real space. It's just like a convenient way of capturing the state of all these particles really simply as one point at a time and then a line over time. But in the quantum case, since we have entanglement, it isn't going to be sufficient to capture the quantum states of the system using just a representation of particles as these like independent fields in a low-dimensional space. In this case, Albert, North, and actually me too in earlier papers argued that you need these extra dimensions. Those are really enabling you to capture the relationships between the correlations between these subsystems in the lower dimensional picture. But what I want to get at today, I'm not going to get waylaid about the arguments for wave function realism. What we're trying to do here today in the short time I have is to explain, if you did think the world was fundamentally a wave function, how could you also see there being low-dimensional macroscopic objects? But I'm happy to talk about the arguments in the discussion if you'd like. So here's a problem. So you might at first say like, oh, it's straightforward. If we've got this wave function in this high-dimensional space, it's very straightforward to say how to recover low-dimensional objects out of that. After all, I've already said, if you are, if you say, for example, the amplitude of the wave function is all clustered around this particular point in the high-dimensional configuration space, we could say, well, that means that something like it's very likely we've got a system, or we've got a system that is mostly composed of individual systems that have 3-dimensional locations corresponding to the location of this point in the configuration space. So if like the coordinates here of this point are, let's just call them now x1, y1, z1, x2, y2, z2, then we say that means there are 2 particles that are pretty much at these locations, x1, y1, z1 for the one, and the other one is at x2, y2, z2. That's the other location here. So because there's this nice mapping between the dimensions in the high-dimensional configuration space that the wave function lives and the coordinates of these particles in the low-dimensional space, it looks like it's going to be very straightforward to map, to find the low-dimensional objects in the high-dimensional ontology. But what many critics of wave function realism have pointed out is that's not the case. So they're not going to argue that there is some mapping between points in a high-dimensional space and locations of a system of 2 or more particles in a low-dimensional space. But what they're going to say is there are too many mappings. So yes, you could say, okay, I've got a particle at this point, and that maps onto some particles that have these kinds of locations where, if we're talking about a system like we observed, this point maps onto a system of particles spread out in these locations, like to make up the kinds of objects that we see here, the middle-sized objects we see here. But what Brad Monton and Tim Maudlin and others have mentioned is there are all other kinds of mappings, perverse mappings that you could do from this any kind of location in this high-dimensional space to a low-dimensional ontology. And it doesn't seem right to say that all of those other weird low-dimensional ontologies are also real. So what privileges this one mapping that would take this kind of way a field would be spread out in this high-dimensional space to a system of low-dimensional objects of the kind we see? Okay, so here's a quote from, this is Tim Maudlin's 2007 paper, Completeness, Supervenience, and Ontology. He said, what the wave function monist has is just a field evolving in this very high-dimensional space, quite unlike what we take ordinary space to be, okay, this high-dimensional configuration space. It's true that under a certain fictive mapping, one can associate that evolution with the motion of local beables, meaning objects that have space-time locations or spatial locations in 3 space, in an ordinary-looking space, and that motion corresponds to what we see, but under other perfectly well-defined fictive mappings, it will correspond to a bizarre evolution of local beables in ordinary space, or a bizarre evolution and a bizarre space, and so on. I call this Monton's challenge just because I found it earlier in Monton than Maudlin, but for all I know, Tim Maudlin's been complaining about this for a longer time. So the Monton's challenge, and this is like the kind of account of how we get these macroscopic low-dimensional objects out of a wave function ontology, is that I'm going to be presenting here is directly a response to this Monton, what I'm calling Monton's challenge. The challenge is what privileges the mapping that takes the coordinates of the high-dimensional space onto coordinates in a 3-dimensional space that track the locations of systems of the kind we ordinarily observe. Okay, so the first thing I guess I want to say here, just put this a little bit in context, is what I say to this problem is not the same as what David Albert has said in a series of works, like over kind of 20 years of discussing this problem, from his early 1996 paper, Elementary Quantum Metaphysics, through this paper on wave function realism, through his 2015 book, After Physics. In all of those works, he had proposed a solution to this problem that's based on a kind of functionalist understanding of 3-dimensionality. So the basic idea here, the way that he wanted to respond to this challenge from Monton and Maudlin, that, oh, well, you can map a low-dimensional ontology onto the high-dimensional ontology in all of these ways, so a mapping isn't sufficient for really getting 3-dimensional objects out, was, yeah, I know. A mere mapping isn't enough to get 3-dimensional objects out. That's not my account. What he said is, here's my account. Here's how you get 3-dimensional objects out of the wave function. I'm a functionalist about 3-dimensional objects. So I say, you have a 3-dimensional object just in case there's something that plays the causal functional role of a 3-dimensional object. And that wave function, or bits in the wave, parts of the wave function, play the causal functional role of a 3-dimensional object. So if they play the causal functional role of a 3-dimensional object, then all it is for there to be a 3-dimensional object is for there to be something that plays a causal functional role, then we thereby get a 3-dimensional ontology. And it's not because of mapping. It's not because, I mean, one thing you can pay attention to, it's about the dynamics of the wave function, and about the fact that over time it's able to play this kind of causal role. It's not a synchronic fact about, I can take this static wave function at a time and map it onto a 3-dimensional ontology. All right, so what is this causal functional? So here's the question. If this is going to work, Albert has to have done 2 things. One, he has to have convinced us that there is a certain causal functional role that's like definitive of being a 3-dimensional object. And then 2, he has to convince us that the wave function, or bits of the wave function ontology in this high-dimensional space, are capable of actually playing that causal role. So I've been arguing for some time that he doesn't succeed in either of these in this earlier work. But let me just say briefly, and I'm sorry this is so fast, but I don't know this song. So this is what he says in all these papers. What he says is, if you want to know what is a causal functional role associated with 3-dimensional objects, well, the answer is it's being describable by a Hamiltonian like this. Okay. So this Hamiltonian is kind of giving us in physics is giving us some kind of representation of how the system is going to behave dynamically over time. And in general, in classical physics, when we're talking about a system of n particle, what do I have here? Yeah, okay, I don't have it. N particles interacting over time in three-dimensional space, we can represent them according to a Hamiltonian like this that has a sum of kinetic energy terms. So the first is like 1/2 mv squared, and then a potential term. And here the potential is just written in this kind of schematic form that the way the system is going to behave over time basically depends on the interparticle locations in these three dimensions, x, y, and z, for these particles that are labeled with the i's. And so what Albert says is, in general, if you have bits of a wave function ontology that can be like plugged in here and given these labels, then we basically have something in the wave function ontology that's playing this causal role. Okay, so that's what I already said. But there is a couple of problems with this, and actually Albert in his most recent work, so he published another book last year called A Guess at the Riddle. In the last chapter of that book, there's just 3 chapters, but the last chapter of the book, chapter 3, he says, this is not working. And it's pretty much what I've been arguing for a while, which is that, one, I mean, really that's the first thing that he's unhappy with now. The second thing, I don't know if he mentions really there, but it's the first thing. So the point is just, yes, there are many different systems that you can model given a particular mathematical representation. That doesn't necessarily mean that literally is that kind of thing. So basically the idea is, yes, we can model something using these coordinates, given a Hamiltonian, a mathematical description that looks like that, but that isn't necessarily to say that we've literally got something in 3 dimensions. And so let me just leave it there. I'm happy to talk about this in more detail. But the second kind of concern that I have with this is even if we, even if we kind of said, no, when I'm writing down this Hamiltonian, I'm not just saying, am I able to put these labels on these things? But when I'm writing down this Hamiltonian, I am really describing something substantive. So I'm really just using this to say that we've got some kind of systems that are moving with certain velocities in 3 dimensions, and whose behavior over time depends on these interparticle distances that you need to recover 3 dimensions. Even if you said all that, there is nothing in the wave function ontology that is actually whose behavior is depending on 3 coordinates. And so so there are a couple of worries with this. All right, so I guess I have no idea how much time when I started, but I'm just going to keep plugging away, and you can say stop when you want me to stop.
Do you want a warning? 5, 3, 1?
Yeah.
All of the above?
5 and 1.
5 and 1.
Thank you. Okay, so I'm concerned about the functionalism. Okay, so I'm concerned about the functionalism. I'm concerned there's nothing in the wave function. I mean, there are no privileged 3 dimensions in configuration space. I mean, that's a short story. So you've got all these, bits of wave function that are kind of evolving. You could even talk about them evolving in little 3-dimensional subspaces, and that is the picture that you have in after physics. But they're just behaving kind of over time in their own little 3-dimensional subspaces, and there's no way to link one dimension in one 3-dimensional subspace to another dimension in another 3-dimensional subspace, and so on. That's the kind of idea. So again, happy to talk about that more, but I want to now talk about what I propose instead. So I do think if you're going to be a wave function realist, it is important to respond to Montan's challenge. So I mean, you could just say that okay, fine, all you have are all these different ways of mapping the high-dimensional ontology onto the low-dimensional ontology. None of those is privileged. So yeah, there's no real sense in which there really is in the wave function three-dimensional systems as a, of the kind that we observe versus all these kinds of wacky three-dimensional evolutions or two-dimensional evolutions or six-dimensional evolutions and so on. You could do that, but I do not want to say that, okay? I want to say, no, we're starting from knowledge that there are middle-sized objects, three-dimensional macroscopic systems like ourselves, like our measuring devices. That's how we generate the evidence for quantum theories. We want to say that they're real, and all of these other kinds of strange things that you could get by mapping the wave function on low-dimensional ontologies are not there. So then the question is, well, then what privileges, is there any way in the high-dimensional ontology to say this low-dimensional mapping is privileged? And I think that there is. So the way that I think we can see it is going to appeal to certain kinds of dynamical invariances between quantum states. And so in physics, in quantum mechanics, when we talk about dynamical invariances, we're usually not kind of making a sharp distinction between invariances and symmetries. So we talk about the system having an invariance, we're talking about symmetry, and they're kind of, these things are conflated. I'm not objecting to that, that's totally fine in physics, but for the use that I want to put this in metaphysics, it's important to kind of draw these distinctions. So this is what this slide is saying. What we're going to be doing is starting from, in addressing Montan's challenge, is starting from noting that there are some kind of dynamical invariances in the high-dimensional ontology, and then we'll later talk about symmetries. Okay, so I just want to make the distinction of how I'm using these terms. And these are just terms of art here. So dynamical invariances is basically what is referred to in quantum mechanics when you want to talk about invariances or symmetries. So you have an invariance just in case the Hamiltonian commutes with the generator of the symmetry. So like, for example, if you're talking about some kind of translational symmetry, the generator would be like the momentum operator. But this doesn't matter. The point is there's a generator of the symmetry, and that allows you to transform different quantum states or different wave functions. And if it is the case that the Hamiltonian commutes with that generator, then we'll say that there's an invariance. So this just means if you took the wave function, you operated it on it with the Hamiltonian, and then you applied the generator, you would get the same thing if you took the Hamiltonian and then applied the generator and then applied the Hamiltonian after that. You get the same thing. So that's what I mean by invariance. And then I want to emphasize that we can talk about these invariances between wave functions, and that's all very abstract, and we're not talking at all about three-dimensional objects at all. It's just a fact about wave functions and how they're related to each other. But now I want to use as a separate term symmetries, and they're, when I say symmetries, I'm just going to be talking about relations like if something is a reflection of something else, or something is a translation in space of something else, or something is this something else but rotated, or with some particles swapped. That's how I'm going to use the word symmetries. Okay, so let me give, this is the idea of how I think we should be responding to Montan's challenge. So to start from the wave function ontology, and let's suppose that there are two wave functions, simple case, where we call one psi1, call one psi2, where we can understand psi1 as psi2 as psi1, where we apply this generator operator to it, and we suppose that there is an invariance between these two wave functions of the kind I just described. Okay, so just suppose that that is a fact, and now suppose that there is some way of mapping these two wave functions onto low-dimensional ontologies, onto three-dimensional coordinations, such that When you do that, you see that there's some kind, one's a reflection of the other, or one's a rotation of another, or one's a translation of it over in space. Okay, so they're symmetric in some way. And then suppose that if you had started with those wave functions, and instead of mapping them onto a three-dimensional ontology, you instead took those wave functions and you mapped them onto a two-dimensional ontology, or some other kind of perverse, you did some other kind of perverse mapping, and when you did that, you didn't see any kind of symmetries there. There was no interesting relation between those wave functions. Then I want to say, it would be reasonable to say the three-dimensional ontology is tracking something, whereas a two-dimensional one, or that other perverse three-dimensional one, it's not tracking anything. Okay, so here's the example that it's like the example that I talk in my book. So, I mean, now we're just going to imagine two very highly idealized quantum states, but it's just to kind of see the argument as clearly as possible. So imagine you have these two wave functions. One is where all the amplitude of the wave function is combined to a point where the space, that high dimensional, I just put a 12-dimensional space. This 12-dimensional space is coordinized in such a way that we can assign these numbers to this point in the high dimensional space, and we say, for psi 1, basically all the amplitude is clustered around here. And then imagine you've got this other wave function where all the amplitude is clustered around this other point. And we suppose there's this dynamical invariance between the two in the way that I described. And now suppose if it were to be the case that you were to take those wave functions and map them in a straightforward way onto a three-dimensional ontology, you would get this, where I kind of gave up. I'm sorry, I'm not good at PowerPoint. I need a helper. These should be like smeared out a little, maybe. But essentially, what you get is, you get a mapping onto 4 particles. So this is the mapping when you take this quantum state and map it onto a low-dimensional ontology, and where the third dimension again is hidden. Okay, so I put zeros here, so I don't have to worry about that. Okay, so this is a three-dimensional ontology representation of this. This is a three-dimensional mapping of this. And you can see, if you do that, this is just a reflection of this. And you're like, oh, that's interesting. There was this invariance between those two quantum states, and when you map them onto a low-dimensional ontology, you see that that's captured in the fact that there's this reflection here. These states are really symmetric in three-dimensional space. But then map them onto something perverse, a two-dimensional image, and so you say, like, here's the location of the first particle, here, right, here's the location of the second particle, here, and so on. So you take these quantum states and you map them onto 2 dimensions. Now you see, look, there's no interesting relationship at all between the two. Okay, so this is like very simple, very idealized, but I'm just trying to get the flavor here. The idea is we would have reason to believe that this was a garbage low-dimensional ontology. The reason is just that kind of low-dimensional ontology isn't capturing anything that isn't already captured in the high-dimensional picture. But when we translate this into a low-dimensional image, we really are seeing something.
Right, that's right.
Great, thank you. Okay, so that's a kind of response that I think is appropriate to give to Montan's challenge. The idea is Montan and Maudlin were asking us to say, what is it in virtue of which, if you have this wave function in this high-dimensional space, it is also true to say there are low-dimensional objects of the kind we, right, as opposed to all of these other kinds of weird things that you could get from other weird mappings. And the answer is because in this particular low-dimensional image, we find things that are reflecting this dynamical invariances in the quantum state, okay? And what we would call symmetries. asymmetries in my language. Okay, but now it's important to say that once you've answered Montan's challenge, at least in the way that I propose to, although we've explained how in a world that's fundamentally a wave function, there could also be some kind of three-dimensional reality containing low-dimensional macroscopic objects, it doesn't itself address what's been called the macro-object problem. And the way I understand the macro-object problem is it's demanding some kind of account of the metaphysical relationship between objects in the low-dimensional ontology and the objects in the high-dimensional ontology. Because you could still be like, okay, fine, now you've told me, like, there's a good reason to say that that three-dimensional ontology is tracking something real, but then you could say, but I can't understand how that could possibly be constituted out of a field in a high-dimensional space, where no three of those dimensions in the high-dimensional space correspond to any three dimensions in our low-dimensional space. So you have to answer that as well, but I think like we've got our foot in the door because now we're justified in claiming there are these three-dimensional objects. And so, but to answer the macroscopic, the macro-object problem, what I want to say is, first of all, you know, we've got to find a kind of metaphysical relation that's appropriate. And what I do in the book is say, well, let's just use the simplest one, which is your parthood, the parthood relation. And I can't see any reason why we shouldn't view the three-dimensional particles that we've now recovered from the low-dimensional ontology, or from the high-dimensional ontology, literally as parts of the wave function. Okay, so there's nothing in kind of near...
We're down to one.
Oh, really? Okay.
1.5.
Okay, no problem. Okay, so to get the three-dimensional objects of the kind that we observe, that just gets you particles. To get the kind of macroscopic objects like us, I think you need to do more. You have to talk about their behavior over time. And I do this in a couple of stages in the book. First, by saying that we have to know the particle configurations are going to be instantiating locations, not precisely, but only to various degrees that correspond to the amplitude of the wave function at different points in the configuration space. But once you get that, then I think you're able to, you have particles that have fairly precise locations. You can just use a standard functionalist analysis that we are familiar with in ordinary metaphysics that isn't in high dimensions to recover the middle-sized objects functionally, like we usually do. Okay, I'm probably over now, but let me just, because I could bring it up, it's kind of weird not to bring it up to the present day. So as I mentioned, David Albert, in his recent book, I guess at the Riddle, does say, I don't accept this functionalist analysis anymore, so you might be curious, like, what does he say? And does he say what I want to say? And I was disappointed in reading that he agreed that his functionalist analysis doesn't work, but he didn't like what I say. And I was very surprised to find him calling me a libertine, and that it was interesting, and I was intrigued, but you might be wondering what that means.
Is it an intellectual or moral accusation? What's that?
Yeah, I mean, as a physicalist, I mean, I'm used to being called a libertine, so I thought this was going to be something like that, but that wasn't the charge. So the paradigm of a libertine position is Jonathan Schaffer, like in the ground between the gaps. So, and this is also familiar from like Levine on explanatory gaps and these various papers on the phenomenal concept strategy. So the idea is libertine in general for some kind of phenomenon is going to reject a functionalist analysis and just say like from the, like in the case of the mental physical, you'd say just from knowing the physical facts, you wouldn't be able to tell that there is like consciousness there. In this case, just from looking at the high dimensional ontology, you wouldn't be able to tell there's a low dimensional ontology. What you need are these to know what the metaphysical laws are, what the grounding laws are. And then once you know those, then you can get from the physical to the mental, or from the high dimensional in this case to the low dimensional. That's Schaffer, and that's not me. So it's just, I just have to, I'm not a libertine in this sense, at least. And because what I'm doing here is saying, if you understand the behavior of the wave function over time, you can use a priori reasoning to see how an image of the world with ordinary three-dimensional objects is tracking objective structure, right? And it's just, that doesn't come by way of the functional analysis of three-dimensionality or the misguided claim that the wave function shadows are playing the causal role of three-dimensional objects. It's coming from seeing how symmetries in a low-dimensional ontology can be tracking interesting dynamical facts about the higher dimensional ontology. And so there's no role in this picture for metaphysical laws to play. Okay, so that's it. Thank you.
Thank you. Well, we got into 36 minutes, so we're winning time back. We'll do a slight change of plan in the program. Of course, Quershi-Hurst will come next, but what we will do is we will have a discussion after lunch, but not the.
You still want to get the response.
The response will be given immediately, and then we'll go to lunch and have the discussion after lunch. All right, I've got yours here. Slightly under the gun here. Where is it there? On this screen, it's hard to see. Is that it?
No.
There?
You'll that.
Yeah.
There.
That's it.
Yeah. The contrast is terrible on the screen. All right, and then we'll start it. Yeah.
Good. Right.
Yeah. Feel comfortable. Do you want to sit there so you can see the screen?
Okay, good. All right, so thank you so much for having me. Just to situate myself in this interdisciplinary milieu, I'm a scholar of science and religion who approaches the interaction between science and religion from a philosophical perspective. And today I want to give a snapshot of the research project I'm currently in the middle of, in which I examine the many worlds interpretation of quantum mechanics and see whether it's a hostile or habitable environment for theism. So I began working in this area after I was invited to participate in Professor Mark Harris's Quantum Theology Beyond Copenhagen project in 2021. And my own project has sprung out of this interdisciplinary collaborative venture, and it's that project that I'll talk about today. So in effect, I'm asking, what does the many worlds interpretation mean for middle-sized creatures, i.e. human beings, and the world in which we live? So my plan today is to start off broad and offer an overview of the project and its motivations, and then I want to narrow down to a specific couple of worries for many worlds in the second part. So in the first stage of my project, I wanted to identify key problems that Everettian quantum mechanics might raise for theism. I'm specifically interested in what many worlds means for middle-sized human beings, and this is the stage that I've been working on during my JRF, and I'm coming towards the end of it. And I'm looking forward to the second stage, which I'll undertake wherever I end up next, in which I want to develop new modes of constructive engagement between the many worlds interpretation and philosophy and theology. So science and religion, the field that I work in, is pretty much exclusively focused on the Copenhagen interpretation when it's engaged with quantum physics. I think we need to move into fresh territory when it comes to interpretations of the quantum formalism. But this would only be true if there was something wrong with the Copenhagen way of doing things. So why might I be interested in breaking with tradition? The simple answer is, although Copenhagen-style approaches still dominate physics textbooks, in philosophical circles, the Copenhagen interpretation is on the decline. So Tim Maudlin is one of many people who argue that the Copenhagen interpretation should be jettisoned in favour of a more robust interpretation that satisfies the conditions for a physical theory. The Copenhagen interpretation, according to Maudlin, is no more than a vague recipe that just tells physicists to shut up and calculate. In other words, the Emperor of Copenhagen has no clothes. It fails to give a robust account of the metaphysics beneath the measurements. And as philosophers and theologians, it's the metaphysics, the type of world that we live in, that we really care about. Whether Copenhagen is right or not, and there is of course much disagreement about this, It's time to expand science and religion's horizons and focus our attention on other interpretations. We don't want to risk becoming stale and stagnant or falling behind. And I think the Everett interpretation is the perfect candidate for this, because it has the potential to really radically reconceptualise both our understanding of reality and our place within that reality. So we need to start taking it more seriously. That being said, I just want to say I'm not here to defend Everettianism today. I just want to take it at face value and explore what it might mean for theism, if it's true. So, the Everett interpretation of quantum mechanics, also called the many worlds interpretation, but not by Everett himself, emerged in a doctoral dissertation written by Everett in the 1950s. The self-proclaimed aim of this dissertation was to regard pure wave mechanics as a complete theory, and what follows is both simple and radical. Fundamentally, reality is comprised only of the wave function of the universe, and this universal wave function evolves deterministically in accordance with the Schrödinger equation. In other words, what follows is a commitment to wave function monism. Moreover, and more relevantly for our purposes today, at a quantum event, however we define such a thing, the wave function splits into branches or worlds that contain each possible outcome of the event in question and cease interacting with each other. But what does it really mean, metaphysically speaking, to say that the universe branches? A useful way of exploring this is via the famous thought experiment Schrödinger's cat. I'm sure you're all familiar with it, but I'm just going to go over it again in case. And because we're using pictures of my lovely cat Raymond, and I do sort of like him, we're going to say that the options are asleep and awake, rather than alive and dead. So, Raymond is locked in a box with a device that will break open a vial of sleeping gas if a radioactive particle decays. The likelihood of decay during the hour the experiment runs is set at 50-50. Before measurement, the Copenhagen interpretation dictates that the particle is in a superposed state of both decayed and not decayed, leading to the paradoxical conclusion that Raymond is in a superposed state of being both asleep and awake. But of course, this is a problem, because these are incompatible states. So the many worlds interpretation solves this problem by claiming that this case doesn't involve a superposed cat. Rather, it involves multiple, perhaps superposed worlds, some containing awake Raymonds and some containing asleep Raymonds. Whichever state of affairs we observe when we open the box indicates which world we are in, but the other worlds and their other possibilities are equally real. In effect, there are perhaps a non-denumerable infinity of worlds branching off from this one each minute, bringing new worlds and new versions of us into existence. It's pretty weird stuff. And it's worth mentioning here that there are at least two versions of Everettianism, and probably more. So one is a more conservative view, defended by David Wallace and Simon Saunders, and it sees the universe as fundamentally singular, understanding the apparent multiple worlds as patterns in one universal quantum state that emerge as it evolves in time. Key to understanding this view is the notion of decoherence, but I don't have time to go into that today. The alternative radical view sees splitting as a fundamental process. And as the radical version has the most significant implications, that's what I really want to focus my attention on. Because I think if theism can respond to the radical version, it probably won't have too much problem or trouble with the more conservative version. So my project is centred around three research questions, and they're up there. So the first question relates to personal identity, and it considers the nature of the human person and, in tandem with that, humanity's relationship with the divine. The second question relates to the concept of moral responsibility, and it concerns the role of the human being as a moral agent who must interpret and practically respond to the teachings of a particular religion during the course of their earthly life. And the third question also concerns ethics, but instead of concerning the ethical parameters of the human being, it considers the moral nature of God himself in conversation with the kind of world that we're living in. So these questions, exploring where and how middle-sized beings fit into the Everettian picture, haven't been adequately explored. And in the remaining time, I want to focus on the first and third questions. I hope to be able to cover them all, but I don't have enough time. So I want to begin with personal identity. What's the core feature of the human person without which we could not continue to exist? This question really matters. Almost all of us have the deep-seated intuition that we continue existing throughout the various epochs of our lives. Though we might colloquially say, oh, I was a different person back then, or I'm going to be a new woman moving forward. We don't really mean to say that in any serious, substantial, or metaphysically meaningful sense that the person we were in the past, or the person we will be in the future, is a different person to the person that we are now. Moreover, our profound connection with a single and unique sense of selfhood is of particular importance to the theistic understanding of the human person and that human person's relationship with the divine. Theism, specifically Christianity, doesn't really make sense if individuals can't have personal relationships with their God that are developed over the course of a lifetime. The entire notion of relationship requires ongoing, reciprocal interaction that's capable of growth and development. I need to carry on existing as the exact same person if we're able to make sense of the idea that I can have a meaningful relationship with anyone, let alone God, that persists as I persist through time. Theism also requires individuals to be justly held responsible for their actions in this life and the next. But I can't be held responsible for actions that were committed by someone else. Because philosophers really love to cause problems for even our most deeply held beliefs, personal identity has received a lot of philosophical attention over the last 2,000 years. And one of the key questions is, what conditions must hold for me to continue existing across time? There are several proposals, and broadly they can be split into psychological continuity views and bodily continuity views. Psychological continuity holds that in order for an individual to continue existing, they must be connected by a stream of consciousness or some other psychological phenomena with their past selves. And this might include having direct memories of being that past person, or indirect memories of being a past person who remembers being a past person, etc. Bodily continuity views, on the other hand, suggest that we're primarily human animals whose identity is inextricably linked with our bodies. So, how do we decide what the right way to approach personal identity is? One way philosophers have tested out which of these should be favoured is through thought experiments, and a particularly illuminating set of thought experiments are known as fission cases, originally proposed by Derek Parfit. Fission cases were inspired by cell fission, a process whereby a cell splits into two or more identical copies of itself. And the thought experiments are intended to examine whether personal identity could be preserved in such a scenario if a human being could be split in this way. Discourse on fission cases typically begins by imagining an individual splitting into two persons who seem to be exact copies, both physically and psychologically, of the pre-fission individual. So let's call a being who will undergo fission at some future time Alice, and let's call the two persons who exist after fission lefty and righty. The question is, after fission has taken place, is Alice identical to lefty, righty, both, or neither? To help us answer this, we can look to various philosophical principles. So, according to Leibniz law, if two objects are numerically identical, meaning they're one and the same object, then they must have the exact same properties. The morning star and the evening star are numerically identical because both of these names refer to the same thing, planet Venus. Moreover, identity is a transitive relation, and what this means is if Alice is identical with lefty and lefty is identical with righty, then Alice must be identical with righty. But in this case, lefty and righty are clearly not numerically identical with each other. Lefty and righty have many different properties, including having distinct streams of consciousness, occupying different locations in space, they can move independently of each other, etc. So they don't share the same properties and so are different persons. Just by looking at them, we could come to this conclusion. And so on this basis, whether Alice can be numerically identical with either of them is problematised. Derek Parfit echoes this sentiment, saying that identity is a one-one relation that an object has only with itself, so it collapses into incoherence when fission occurs. This conclusion is not particularly problematic for most bodily continuity theorists, particularly if Alice's original body is gone. But the psychological continuity theorist faces bigger problems. They must conclude that lefty and righty are numerically identical with Alice because each shares psychological continuity with Alice, despite the obvious fact that lefty and righty are not identical with each other. Before many worlds, fission cases could have been regarded as interesting but ultimately unrealisable philosophical exercises. Brain teasers, if you will, with relatively limited real-world application. But if the ever interpretation is right, then fission events of this kind have been part of the fabric of the world since the beginning. beginning. So what can we make of personal identity in a world in which each of us looks doomed to split into almost an infinite number of versions of us? In other words, how can we solve the problem of personal identity in many worlds? So there are a few solutions available. I'm going to have to rush through them. But the first option is to just deny that numerical identity can be preserved during fission and say that this is actually fine. So Derek Parfit argued that philosophers are mistaken in thinking that the relation of numerical identity is what's most important to us. We shouldn't ask, am I identical with some past or future person, but instead, have I survived? Identity and survival are not necessarily the same thing. Whilst identity is an all or nothing phenomenon, most of the relations important to survival admit of degrees. Moreover, all that matters for survival, i.e. psychological continuity, can be preserved during the splitting process. Physicist and passionate Everettian Sean Carroll echoes this. He argues that the idea that each of us is the exact same person from birth to death was never really more than a useful approximation anyway, so it shouldn't be too concerning that many worlds encourages us to abandon it. Carroll writes, quote, "The lifespan of a person should be thought of as a branching tree with multiple individuals at any one time, rather than a single trajectory, much like a splitting amoeba," end quote. According to this view, Everettian quantum mechanics says that although there are many versions of us, each of whom can be traced back to an original person with whom all subsequent persons are psychologically continuous, we can still talk of our own survival in a meaningful sense. We do survive branching, even if we're not numerically identical with the past self afterwards. So, a couple of reflections on this. I think this probably does work on a naturalistic, atheistic worldview. The problem for the theist is that it doesn't seem robust enough to get a few different theistic commitments over the line. So numerical identity seems to me at least to be necessary for things like cultivating an ongoing relationship with God across time, and also for holding individuals morally and soteriologically responsible for their past actions. You need to be the exact same person to be held responsible for past actions. It's the height of injustice to punish an innocent person for someone else's crimes. Moreover, many theists want to think of identity as relating to or involving a soul as well as a body. The soul, however we might want to think about this, probably doesn't admit of degrees like the relation of survival does. So we need to ask, can a soul undergo branching, splitting into two souls, or an infinite number of souls that inhabit all of these additional bodies? I suspect that many theists want to resist this conclusion, and lots of them that I've talked to have been resistant to this conclusion. So my point here is that survival is not enough to get these theological commitments over the line. So we might need to look elsewhere for accounts of persistence that go further than survival and offer some kind of numerical identity. So one option of this kind is the multiple occupancy view, which claims that if there is fission in your future, then there are multiple occupants in your body up until the point that fission occurs. So before Alice undergoes fission, she actually contains both lefty and righty within her. Parfit argues that the multiple occupancy view greatly distorts the concept of a person, and for this reason it should be rejected. And I think I'm in agreement with him on this. Not only does the multiple occupancy view profoundly violate our intuitions when it appears in discussions of splitting into two, it collapses into complete absurdity in the context of Everettian quantum mechanics due to the sheer scales involved. According to many worlds, branching may well be occurring as many as an infinite number of times per second. If branching occurs as frequently as this, the multiple occupancy view is forced to claim that I contain a non-denumerable infinity of persons at any one time. And this is metaphysically curious, to say the least. And it also stretches our reasonable common sense understanding of identity beyond breaking point. So I think we would need overwhelming evidence in favour of supporting this view, and I just don't think that evidence is there at the moment. So let's move on to another option. So there is another option that avoids these problems, but unfortunately, it seems to imply that every time branching occurs, we cease to exist. This view is called the no-branching view because it introduces a no-branching condition into the psychological continuity view. And branching here refers to the branching of people, so not Everettian branching. So the no-branching view holds that Alice's continued existence depends on any future person's psychological continuity with her, but it adds the caveat that no other being can be psychologically continuous with her. In other words, if Alice branches into two people, she ceases to exist. The post-split persons are not Alice. They're new persons who have stepped fresh into existence as Alice was destroyed by the splitting of worlds. The justification is that identity can only be a one-on-one relation between a thing and itself. But the view has a slightly weird consequence, in that if just Righty had come into existence, sharing psychological continuity with Alice, then the no-branching psychological continuity theorist would say that Righty is identical with Alice and Alice has continued to exist. So one future person sharing Alice's mind is Alice. But when there are two minds, arguably meaning there's more of Alice to go around, we're forced to conclude that instead of her surviving, she's actually died. Once Lefty is introduced and branching has taken place, Alice has ceased to exist. Applying no branching to many worlds leads to further counterintuitive conclusions. And actually, if it's true, then the 6-year-old child I remember being is not me and is dead. I wouldn't even be the same person who started giving this talk, despite the fact that I remember coming into the room, sitting there, beginning to speak, and I've had the continuous experience of doing so ever since. So I don't think we have particularly good reasons to accept this either. So far, I've covered a few options and not found any solutions. I think this problem remains open, and I think science and religion scholars who are interested in this area need to give the question more attention if the theistically significant notion of personal identity is to be recoverable in an Everettian context. So in the remaining time, I want to talk about the final worry for many worlds. And yeah, as I've just said, if many worlds is right, then there are many individuals with whom we share a past and not a future. So we can call these the many versions of us. If there are many Emilys, each living out various possible iterations of my life, then it must be the case that there's at least one Emily living the worst life as possible for me to live. And there are many others living very bad lives. I think this should really matter to a creator God if such a being exists. So yeah, this relates to the problem of evil, i.e. the problem posed by evil and suffering to the existence of a creator God who knows, sees and can prevent evil, but seems to allow it in at least some cases. When considering the implications of scientific theories on middle-sized objects, the problem of evil frequently raises ugly head. And as you'll no doubt know, the problem of evil is the oldest and most frequently cited argument against the existence of God. So for this reason, we could fill entire libraries with the literature written on it. I'm just going to go over it really, really briefly. So the problem of evil holds that evil and suffering presents a significant challenge to the existence of the God of classical theism. Why? Because if God is omniscient, then God is aware of all instances of evil. If God is omnipotent, then God could stop all instances of evil. And if God is all-loving, then God should want to stop all instances of evil. But a mere glance around the world tells you that evil does exist. So some further explanation is required. I want to argue that Many Worlds raises both a new and an enlarged version of the problem of evil. So the enlarged problem involves claims about the significantly larger amount of evil in an Everettian multiverse, and the new version of the problem is that God chose laws of physics that seem to entail certain types of suffering that seem contingent on other universe models and necessary on many worlds. So I'll start by setting out the enlarged version in dialogue with Marilyn McCord-Adams and Stuart Sutherland. So they define a particularly problematic set of evils, which they call horrendous evils. And these are, quote, evils, the participation in, i.e. the doing or suffering of which, gives one reason, prima facie, to doubt whether one's life could, given their inclusion in it, be a great good to one on the whole. Such reasonable doubt arises because it's so difficult humanly to conceive of how such evils could be overcome. Because these evils are so overwhelming that they make you doubt whether your life was worth living, it does matter whether one of your futures contains horrendous evils or not. And this is where Many Worlds comes in. Over time, the various world branches will end up evolving in different directions, bringing real-world differences to the lives of the middle-sized inhabitants. If there are an infinite number of world branches, it's reasonable to suppose that the lives of some of them contain horrendous evils. And if this is true, then the Everettian multiverse contains far more suffering than an ordinary universe. And clearly, this is a very bad thing. Now, if you're an optimistic theist, you might make the following response. You might say, okay, there is much more suffering in the many worlds of Everettian quantum mechanics, but there's a correspondingly greater amount of good. For every suffering version of me, there's at least one version living the best life, and countless more living very good ones. So on balance, the distribution of good to evil isn't so unlike the world described by non-Everettian physics. So they might claim the problem of evil isn't actually any greater than it was before. But I think this response fails. And I think it fails because it doesn't recognise an important distinction between two equally important descriptions of God, both of which are pointed out by Adams and Sutherland. So the first is that God is a provider of global goods. But the second is that God is a loving parent of each individual person. Generic global responses to evil, such as those that highlight the distribution of evil on a large scale, only recognise that first, rather more detached depiction of God's nature. As a provider of global goods, we might understand how God could choose a design that vastly increases the number of people who are able to live joyful, fulfilling, happy lives. But, as a loving parent, it's very hard to understand why God would create a cosmos in which at least one version of every single person is living the worst iteration of that life possible. In effect, I'm arguing that any response that focuses on a global distribution of goods and evils ignores the plight of those individual persons who suffer greatly, recognising only one aspect of the divine nature. And joy and suffering are not morally equal. I think this is really important to note as well. If we encounter someone being tortured, suffering immensely, while the torturer is experiencing an exactly equal amount of happiness or pleasure, our moral intuitions tell us that we should stop the suffering. As such, the benefits befalling some versions of me in the Everettian multiverse are vastly outweighed by the price that other versions have to pay. And so for this reason, I think that the many worlds interpretation potentially increases the amount of evil, and this is a problem that needs a response. But if that doesn't convince the optimistic theist, I have another point. So I also want to argue that many worlds raises the problem of evil in a new way. So from the very structure of the Everettian multiverse, it seems like suffering follows necessarily. It's no longer a contingent matter whether one's future will contain horrendous evils, extreme suffering, or be negative. Somewhere in the Everettian multiverse, there will be versions of you experiencing these things. Moreover, traditionally reached for theodicies that place the blame for evil with humanity and original sin can't work here, because the suffering is woven into the very fabric of the cosmos. And I think this is a slightly new iteration of the problem of evil. If Everett was right about how to interpret quantum mechanics, it seems as though God chose to instantiate a particularly cruel set of physical laws that makes suffering emerge by necessity. Early pioneer of science and religion, Robert John Russell, calls this type of argument a cosmic theodicy because it concerns the very nature of the cosmos or the universe itself. Russell argues that those who deny divine responsibility for evils that follow directly from physical laws elevate the problem of evil to one of cosmology. But according to Russell, this response is doomed to fail for anyone who wants to claim that God is omnipotent. God as omnipotent creator must have had radically free choice over the fundamentals of nature, including, of course, the laws of quantum physics. So an omnipotent God could have created another type of universe altogether, in which the cruelties of our own may have been avoided. So for that reason, cosmic theodicies don't solve any problems. Instead, they just push those problems back one step. Although God isn't directly responsible for individual instances of suffering, God is indirectly responsible insofar as God created the features of the universe which cause that suffering. So I think we do have a new dimension of the problem of evil which requires a fresh and directed response.
We have about 2 minutes.
I'm almost
Oh,
done.
wow.
So yeah, just to briefly sum up, I hope to have given a brief indication of some of the problems the radical version of the many worlds interpretation raises for middle-sized objects in the context of theism. Thank you.
Thank you both very much. I'll begin with Alyssa's paper. I'd first like to say how much I enjoyed reading The World and the Wave Function, which is both a philosophically serious and yet very accessible discussion of important issues in the interpretation of quantum mechanics. As you've heard, it's a sustained argument challenge for wave function realists is to account for how the three-dimensional world of scientific observation, which includes the middle-sized things to scientists, is supposed to emerge from this high-dimensional field. And Alyssa proposes this two-step approach to recovering these middle-sized macro objects. The first involves the grounding of three-dimensional particles in the high-dimensional wave function field by appealing to certain symmetry considerations. And the second step involves the functional reduction of macro objects to these microscopic particles. I want to focus on the first step. So the microscopic particles that play the functional roles of these macroscopic objects are said to be real but derivative and constituted by the high-dimensional field. When asked to admit a non-eliminative grounding relation between the high-dimensional field and the three-dimensional micro-objects, and we're told that this is a mereological relationship in which the particles count as parts of the field. So my worry is that these particles are not being grounded in the field in a principled way. And I'll try and break this down into a couple of points which may simply represent misunderstandings on my part and be clarifying. First, grounding is supposed to be a necessitation relation, but it still seems to me, in spite of what Alyssa said, that the same wave function field could be associated with a different set of objects in these three-dimensional micro-objects. As Brad Monton has pointed out, and as Alyssa has acknowledged, the high-dimensional space of the wave function does not possess of itself any structure indicating how its points should map onto three-dimensional particle configurations, nor is there anything in its structure to suggest its dimensions should be grouped in threes. In response to Monton's challenge, Alyssa claims permutation symmetries of quantum mechanics provide a dynamical reason for preferring certain decompositions of the high-dimensional space. Specifically, the laws of the high-dimensional wave function remain invariant when we permute the particles in the three-dimensional representation. As Valier-Allery complains, however, this seems to get the order of explanation the wrong way round. The reason this invariance in the laws of the high-dimensional space exists is because of a symmetry we observe in a three-dimensional system that is reflected in the Hamiltonian that we use to characterize its dynamics. If we thought of the wave function thought of the wave function as being a physical field in the high-dimensional space, however, then it seems we would have to relinquish the idea that symmetries are a guide to ontology. So it's been argued that a wave function field doesn't transform in the right way to preserve Galilean invariance or time reversal invariance, for instance. So it seems, and I may be misunderstanding something, there's a strange inconsistency in requiring symmetries to play a fundamental role in justifying the grounding relationship between the field and the particles, whilst refusing to take symmetry as a guide to the fundamental ontology. So I'm worried that what you're giving with one hand, you're taking back with the other. But that may be a misunderstanding. Secondly, it's unclear to me that the micro-objects in the wave function field possess the right kind of properties to be mereologically related. So ordinarily, if x is a part of y, then the intrinsic properties of x and y should be determinants of the same set of determinables. But that doesn't seem to be the case here. The particles are supposed to be mereological parts of the wave function field, and yet they are essentially three-dimensional objects following trajectories in three-dimensional space. They're not located in the high-dimensional space of the wave function field. Now, it occurs to me that there could be a way for panpsychists like Philip Goff to fix this problem, elaborating on a suggestion made by Mario Hubert, who observes that we do not think of thoughts as having specific locations in our brains. So according to cosmopsychists, the cosmos as a whole instantiates mental properties, so they might conceive the three-dimensional particles as being representations of the high-dimensional field in a cosmic mind. In this sense, the particle configuration could be a part of the physical field, but the particles would not have to be located anywhere in the high-dimensional space of the wave function. In this picture, the three-dimensional particles would not be grounded in the purely physical properties of the high-dimensional field, but in its psychophysical properties, if you like, and then I think my objection would disappear. But of course, such a move would compromise the second step in our model, which invokes functionalism to account for all the properties of macro objects, including presumably mental properties. But it seems philosophers would have fun with that, so I thought I'd just mention it. Although wave function realism is supposed to be consistent with different interpretations of quantum mechanics, Alyssa has expressed a sympathy for the Everettian interpretation. So I'd like to change registers now to comment on Emily's paper, which highlights some of the difficulties Everettianism poses to theism, especially Christian theism, I think. I thought this was a very interesting way of probing the ontological implications of Everettianism. I look forward very much to seeing how the project develops. Given the interdisciplinary nature of our gathering, however, I thought it would be helpful to raise a couple of methodological points for clarification before we all start arguing about very interesting metaphysics in the discussion. First, suppose physicists are converging upon the Everettian interpretation. I don't have the statistics. Even so, some people may be wondering why you think theologians should feel compelled to make Christian theism Everettian compliant. Do you think theologians should construct an Everettian theology because you're convinced this interpretation is probably true? Or do you think this is just where things are going in the scientific community and theologians need to get on board? Or maybe the goal is to get Everettians to come to Evensong, which is 6 p.m. I raise this point because, of course, there are many factors involved in constructing and judging rival interpretations of physical theories, as you know, including the kinds of epistemic virtues people think they ought to embody and how these virtues ought to be ranked. And there's some people in the room, so McIntyre and like Dan and Haan back there, who are going to question, I think, whether there is a standard that experts can reasonably hope to converge upon, which is independent of the philosophical or theological tradition in which they are practicing, and maybe other sociological considerations. So if more physicists are becoming sympathetic to the Everettian interpretation, that might reflect a sociologically interesting fact about how they're being enculturated from this perspective, but it wouldn't necessarily constitute a reason for theologians to strive for Everettian compliance. Perhaps it's the Everettians who need to be evangelized. My second related point concerns the theoretical costs involved in the project of adapting Christian theism to make it consistent with the Everettian interpretation. I suppose I'd like to know a little bit more about the project's criteria for success or failure. Could one reach a point of crisis in this process of adaptation, in which one is adding too many disciples, so to speak, to Christian theism to make it tenable? Might one reach the stage of acknowledging that one's no longer thinking about theism in a distinctively Christian way? One of the concerns you've expressed for Christian theism centers on the notion of there being persistent persons to whom the Christian God, who is love, relates in a loving way. But there are, as you know, atheitic forms of theism in which the distinction between individuals and the divine dissolves within a boundless subjectivity, and perhaps these alternative forms of theism fit better than Christian theism with an Everettian way of thinking about quantum mechanics. If so, would that count as a reason for Christian theists to reject Everettianism and put forward some other interpretation of quantum mechanics, rather than seeking to make their theology Everettian compliant? Underlying both of those questions, I think, is a suspicion that the data which you're bringing to theology for consideration has been pre-digested philosophically. Mark Harris, I think, expressed a doubt yesterday about whether one needs a philosophical system. My worry is that if theologians try to construct a theology of science without settling philosophically where the goalposts of an intelligible interpretation are to be found, they might end up playing somebody else's game. If one's theology of science were freighted with a pre-Christian Aristotelian philosophy of nature, however, the kind of what Koons has been sharing with us, which isn't so far from what was widely assumed by many Christian, Jewish, and Muslim theologians in the Middle Ages, I wonder whether the task of understanding theism in relation to an Aristotelian Everettian interpretation might look rather different, and whether it would afford better prospects for Christian theism. That's what I wanted to say.
Okay, so we're going to adapt the schedule slightly. What I need here is a show of hands for how many of you are speakers or respondents in the room who will be coming to lunch. We can do a count here. 1, 2, 3, 4, 5, 6, 7, 8, you go, 9. So I think that means we have, thank you. I think that means we have 5 extra spaces for lunch because we were limited by staff shortages, etc., to 25 spaces, or we would have happily offered it to you, but there's staff shortages everywhere in Oxford, so it's not this place, it's everywhere. So you're gonna have to fight for those. But actually, what we're gonna do is the responses and the discussion we then put the second half of the lunch hour, like at the last 20 minutes. You're welcome to go get food and bring it back here. And for those who can't join us, and in a moment I'll allocate 5 spaces in a completely arbitrary way. There's a covered market. Actually, if you go out the front of All Souls to the right, there's a covered market which you can enter after about 300 yards, or just about as many meters, or maybe a few more. And it has many different varieties of food from all over the world, and from this place too, that you can get and bring back. We've been told we're allowed to have the food here, so what will happen is those who are going downstairs for a sandwich lunch will have some there and bring a bit back. Those who are going to the covered market, you may also bring yours back. We would converge at, let's say, at 1:45 the next hour, and have the discussion then. A few of us might still be nibbling on the remnants of our lunch or enjoying it, but does that sound equitable? Does anyone really prefer, covered market has glorious food, you got to get it on your own, or we have sandwiches of varying degrees of glory downstairs. So is anyone really keen on sandwiches of varying degrees of glory and is not a speaker or respondent? 1, 2, 3, 4. One more? Well, anyone else? Okay, then we'll see you back here at 1:45 the next hour. Those who are, oh yes, Daniel.
Can we leave these things
Yeah,
here?
you can leave everything here. We'll close the door and it won't be accessible. With anything you want here. I might go through it though. If you're a speaker restarted. I assume some of our friends will be joining us with their what they've acquired, the delicacies of the covered market. And if you don't know about the covered market, it's what the name implies. It's a market that's covered, but it's also an older wooden structure that's one of Oxford's cherished places to go and get your shoes done up, or get some riding gear, or some falafel, or there's lots of ores there. There's really good Colombian coffee inside as well. So with that being said, we are going to reintroduce William Simpson to the chair.
Yes, we're just going to have the speakers have a chance to respond to some of the comments I made, and then we'll just go straight into Q&A until 2 o'clock, is it?
I think we'll lead with 5 minutes, so we will have 20 minutes of discussion. So we will have one back 15 minutes. Yeah.
Who wants to go first?
Yeah, so thank you. Those were really, really great criticisms that the first one I need to think more about. So I wasn't trying to, when I talked about the parthood relation and claiming that the wave function is the whole and the particles are the parts, even though they're in different spaces. I did want to, I guess the first and the third criticism were both about that. So I wasn't trying to say that was a grounding relation. I was just trying to say, so I think in general when we talk about, we make a part-whole relation, we don't necessarily say what the grounding relation is. I mean, this is what I take one of the things like Jonathan Schaffer kind of showed us. You could be, because you could be a priority pluralist, you could be a priority monist, and so just by saying there's this part-whole relationship, there could still be leftover questions about grounding. But this issue about should there at least be necessitation, I want to think about that. I was thinking, I just don't know, because I wasn't trying to capture a grounding relation.
So a feature of the Feignant program of grounding is that there should be a necessitation relation.
I'm not, but that's fine, but I'm only claiming a mereological relationship here. I wasn't claiming a grounding relationship just by, I didn't say that the mereological relationship was grounding. I said it was a metaphysical relationship between the two. So you could just say, okay, you've got this ontology and you've got this ontology. What's the relationship between the two? And I'm just starting from saying it's a part-whole, there is a part-whole relationship. Now whether or not that means that, that tells you, I'm not saying that the mereological relationship itself is a grounding relation.
Okay, but the whole that we're talking about here is the physical field.
Yeah,
and
the
the
wave
parts
function.
that we're talking about here are these three-dimensional particles.
Yes. And I do believe there's a grounding relationship between those two.
Right.
But it's not completely captured by the fact that there's a mereological relationship between the two. So, but yeah, I mean, I want to thank you for engaging with this and raising this question about where.
It seems like something more needs to be said in order for there to be a grounding, if you want it.
Yeah, and I don't think that a mereological relationship is a grounding relation. I mean, it's not just Jonathan. I think many people have pointed. Elizabeth Barnes has a paper on emergence where she makes this point also. But yeah, good. But thanks for pressing me on this. I mean, I was trying to be provocative at that point of the book, and I wanted people to fight me on that. So we can talk about is this okay to call this a mereological relationship, even though they're in two different spaces? And I didn't see why, wasn't seeing anything in the mereology literature to say you couldn't do this. But then the other point you had was something about the determinate. There should be a determinate determinable.
Yeah, I suggested, and maybe someone will contradict me, that X is a part of Y, and the intrinsic properties of X and Y should be determinants of the same set of determinants.
Oh, okay. The intrinsic properties should be okay. Okay, I'll write that down. I have to think about that. I guess I wasn't thinking about that. I mean, I never thought that was the case, but maybe I can be convinced. So, thank you. And then the thing about symmetry, so I did want to talk about, that is something that Valia has pressed me on for a while whenever we talk about this, and I'm happy to bring this up. So I don't think, I think what's happening here is just that maybe you and Valia don't like how I say there are symmetries here, and you want the fundamental on top. So, okay. So it just is going to be the case that in a situation where you have one of these symmetries in the three-dimensional ontology, there are multiple wave functions. And so you could complain, as I think she does, and well, other people have complained that there's not, you don't have any kind of, you have too many wave functions. There shouldn't be so many wave functions here. There shouldn't be a distinction between the wave function where the particles are here and one where they're here. And so at least this is what, so we have too much structure in the wave function ontology. I want to deny that. So the way I'm looking at things is we've got some other arguments that I just didn't talk about today, because I didn't just read my whole book. But there are several arguments for the wave function view. The wave function realism, those motivate you to think the reality is this higher dimensional space wave function, and now it's going to turn out that there are lots of wave functions, maybe too many than some people would want, but that doesn't mean I've taken away symmetries, because there are these interesting relationships between wave functions, and that's what it means to say there's a symmetry. It means that there are these commutation relations, and I'm not denying that there are these commutation relations. Now we wind up seeing these, and they're interesting to us and important when we look at the low-dimensional image that's generated from them. Where there are these interesting relationships of reflections and rotations and so on. That's where you really see the symmetries manifesting. But I don't think I'm not rejecting them. I'm just So that's really all. But we can talk about this more.
Okay, thank you very much.
Okay, I'll just briefly respond as well. So I really appreciated the methodological questions. I think those questions are very interesting. And as for, physicists converge on Everettianism, should theologians follow suit? I think it really depends on your own particular commitments, what your epistemic starting points are, and whether you think science and theology are more fundamental. So if and to the extent that science and theology might come into conflict, which one do you believe with a greater degree of certainty, or which one do you see as the more grounding aspect of your worldview? And that will inform the extent to which you think that theologians should follow. But I think if we look back over the history of the interactions between science and religion, we see this kind of thing happening a lot. So we see particular religious ideas being challenged by science, and then really interesting, intricate, beautiful theologies coming out in response. So thinking about Darwinian evolution, for example, that challenged the idea that species were created in their final forms. And then we've had some fantastic theological reflections on the basis of that later. So I think theology and religion is often and always doing this, if it wants to be outward facing and if it wants to have porous boundaries, which I think that it ought to. Especially if you are a theist and you believe that God created the world and God wrote the scriptures, then you should think there should be some sort of resonance between those two. So I think theology is at its best when it's outward facing, when it's engaging with science, and when science is able to encourage theology to maybe look at some of its views again.
That's helpful. Do you see any sort of mediating role for philosophy, say, for natural philosophy, not something specifically theological?
Mm-hmm. Yeah, and I think...
Professor Swinburne, can you hear what's going on up here?
I can, but I've only just come in, so...
Okay. If you'd like, there's also seats closer if you'd like to come closer.
Yeah, well, I think it's difficult for science and theology to talk to each other until they're translated into the language of philosophy. So I think philosophy can be a a mediating force between them, and it can also be the common language into which you translate them both and then you do some philosophical work. That's the kind of thing that I'm interested in doing. And it's not the only approach, but I think that it's, I mean, it depends how we define science and religion. I don't want to get into that too much, but...
No, that's I think probably have a slightly thicker conception of natural philosophy than you do.
Yeah, okay, yeah, let's open up to Q&A. I can talk for ages about that. Not a good idea too.
Yeah, I listen to the press. I think it's a version of William's order of explanation worry.
Okay.
So, you mentioned decoherence, but it plays an important role, I think, in giving you the localized particles.
Yeah.
Right? And that depends upon, in practice, on very specialized thermodynamic and chemical and other kind of middle-sized object constraints, right? Which then explain, I think, why the wave function has the very complicated Hamiltonian it does, right? So if that's right, then it looks like to try to build the middle-sized world out of the Hamiltonian is sort of going, I don't know, the wrong direction, right? I mean, the Hamiltonian is what it is because the middle-sized world is the way it is, right? Especially, well, anyway, so that's the worry, I guess.
So this is a question that I feel like Howard had asked to George and you in the first section, that I guess I feel like I'm missing something. I agree that the reason why, I agree it's interactions with macroscopic systems that's in general getting you decoherence, but I don't see why the descriptions of those systems can't be given in completely microscopic terms. And so I don't, like, it's not that I disagree with you that in the explanation middle-sized objects are playing a crucial role. I just don't see how that challenges the kind of reductionism that I'm defending.
Yeah, so it'll force me to fall back on the other arguments I'm trying to give about the irreducibility of the thermodynamic and chemical properties. So if they're fully natural fundamental properties, then of course.
Yeah, unless I'm missing, like, I really feel like I'm missing something, like, in that, because, and Howard is too, I think, if we're, so maybe we should keep talking about it, but I think that's the, maybe,
Sam is a finger allowed.
Yeah, yeah.
I mean, epistemological priority doesn't mean ontological priority.
Exactly.
And a thing can be natural without being fundamental on this picture.
Yeah.
I think you seem to think, well, if it's natural, it must be fundamental. If it must be fundamental, it must have its own causal role in addition to anything else. So if the top level has that, it must be influencing things down. Otherwise, it would just float on top of what's happening. And I think you're objecting, and I would object, epistemological priority isn't a guarantee of anything in these cases.
Yeah.
Finger on that. Isn't Rob also holding like this timing constraint? That's also part of the feature, and he has a person that needs to be about ontological objects, and so you don't want like duplication, determination of these things doing more things than they are, and he doesn't think the causal work can be taken over by the lower level things.
That's what we're disputing.
Yeah, right.
So so I don't know, the picture that I'm thinking ontologically is the microscopic, is the fundamental here, but, and then you can explain I think everything, at least in terms of decoherence, can be given that kind of description.
So I guess I don't think it's an epistemological priority then.
Okay.
And that my intuition is giving me. It's that there's a metaphysical explanation here as to why the Hamiltonian looks the way it does in terms of middle-sized features.
Yeah, okay. Yeah, then I want to see the arguments more, and but that's fair enough.
Philip, was that a new question or a follow-up? New question. So you're in the queue, I'm afraid. You're next.
Yeah, I'd like to ask Emily, I can't quite say whether this is sort of vaguely Kantian question or not, but is there a reason to think of branching in terms of fission? Basically, I want to challenge the idea that fission is a good way of thinking of branching, because the thought experiment about fission is about something that happens within the world, whereas branching clearly isn't. And I wonder then if one needs to be rather more careful about one's terms, mind, psychological continuity, body, in order to apply this thought experiment for something that in fact does not happen, to something that apparently is happening all the time. And I wonder if that gets at the sort of the Kantian thing, I suppose, maybe not quite, is the sense that we are illicitly taking over intuitions from our experience to an ontology which clearly completely exceeds or cannot be captured by our experience. And therefore, presumably, we have no reason to think that it will answer appropriately to our intuitions. I wonder what you think about that.
So I think I'll start with the second part first. I think that may well be the case that our intuitions just can't really get us very far in instances of branching. But then, then we're just cutting ourselves off at the knees. We're stopping the work before it's even started. So I want to resist that just to see how far that we can get, even if ultimately maybe it is the case that we won't be able to get particularly far because our intuitions and our experiences are so restricted by if we are experiencing within one branch rather than maybe lots. And the reason I think fission might be useful, I don't think that it's exactly the same, the type of branching we're talking about in FIT and quantum mechanics and the type of branching that happens in fission, but I think it's a useful thought experiment, and the things that I'm interested in occur in both. So an individual, and then there being multiple individuals in the future. On the particular version of Everettianism that I was engaging with, we probably don't have time to talk about all of the different ways we would take that.
My question would be whether one and multiple even really mean the same thing, where we're talking about multiplicity in terms of branching versus multiplicity within. That's, I think it might go even deeper than it seems, but perhaps it's clear what it is.
No. Thank you. So Christopher Oldfield.
Hi. Thank you both of you. I have a question for a listener. And I suppose you addressed Monton's challenge, right?
Yeah, I call it Monton's
challenge.
challenge.
And I'm wondering if Monton's challenge is slightly different. I wonder what you think about this. So let's take Monton's challenge to be, how do you recover a three-dimensional analysis from a five-dimensional analysis where there's multiple dimensions in a configuration space, something like that? And I would take Morgan's challenge to be something more about the manifest image, scientific image difference. So Morgan, as I understood him, in maybe the workshop that became your green book, I heard him once say there's a really significant choice point, and it was about the demands you make on a physical theory. So he said, take Newton's theory. No one ever tells you what a body is. It just says every body happens to be in a right line. It doesn't tell you what a right line is, it doesn't tell you what a body is. It sort of assumes, it takes for granted that someone can go, one of them. And I wonder if there's a different challenge implicit in Maudlin's worry to, say, the Bovian, or the Everettian. Whatever happened to your tables and chairs and the sorts of objects you can pick up in a manifest image? I don't think that's obviously the same. It's quite related to the same as Monton's challenge for how do you basically embed a three-dimensional analysis and a high-dimensional analysis. But I wonder, what do you think of that? That there might be two different challenges here? Or am I just missing something?
There are many, so I was just describing the problem that Maudlin was raising in that quote that I had.
Yeah.
So, yeah, there was no workshop that led to the Green Book, but he's raised many different objections to wave function realism. So, did you want to? But
it might have been.
This is the challenge in the quote.
Yeah.
Was identical to another challenge that Monton raises in one of his many papers criticizing wave function realism. So I'm happy. Can you tell me? I don't know. Did you want to raise a different problem and ask what I say about it, or?
I think
because if you're just saying there are different things that Nodlin says. I totally agree. Yeah.
I think we'll have you close down.
I'll think about that.
Okay.
On to the next session, Sánchez. Press for time. So.
That was our 20 minutes, I'm sorry.
Thank you so much.
I should say, while we have a moment, a comb was found in the coffee room. Well, I clearly need one, so I'm going to appropriate this. If you decide it's yours later, tell me, but otherwise it'll go to my daughter.
Maybe I'm going to sit over here.
Yeah. Howard. Do you want to give me a chair? Would you like to introduce the first speaker and yourself, please?
I've got to grab my stuff.
Don't go overboard on that.
Philip, you want first.
Oh, no.
Slides are up.
But now you are. Let's go.
Oh, so I am on.
No,
maybe seeing the slide. Is that okay? Sit outside.
All right, I'll sit down.
Does that affect things?
No.
This way I get to refute everything you say. Much better.
Right, am I introducing these?
If you'll be so
Right. Tim O'Connor is a professor at
Indiana
University, of course, and is well known particularly for his work on free will and metaphysics generally, philosophy of mind is extremely distinguished in those areas, and I've been reading his stuff recently myself because I'm trying to write about free will, and it's extremely useful and important. And then Goff, who was at Liverpool after I taught there, and at Central European University when I taught there. So he was a colleague, but then he came back to England and is now interviewed on the television and the wireless almost every day of the week. One needs a special Facebook channel of one's own to take all Philip's things in, and he's tremendously active, but particularly famous, together with Galen Strawson, for the panpsychism views, and particularly important in the development of panpsychism from the original primitive theory of the smallism, as it were, to cosmopsychism, and now this agential panpsychism. This is all fascinating, so I've hoped to have a really interesting paper from both of you.
Howard, there's a chair for you here if you want us.
Sorry, I've swapped us around by mistake, but okay, well thanks very much for the invitation. This is really enjoying this conference. It's a really nice interdisciplinary gathering. I want to talk to you today about the mystery of psychophysical harmony. There's something about 5 people are talking about at the moment, but I think it's going to change the world, so we'll see. But however, it's a hard problem to convey to people. And that's not because it's particularly technical or complicated. It's just, it doesn't seem like it's a problem. I'm going to suggest that there's something we need to explain. And what I'm suggesting we need to explain is such an obvious, mundane, seemingly trivial fact of human existence that it really doesn't feel like it needs explaining. George Orwell said something like, to attend to what's in front of one's nose requires constant effort. It's probably not exactly. I think something like this is going on here. Okay, so this is taken from my recent book, modestly titled "Why the Purpose of the Universe." Just say a little bit about that quickly. So it's pitched as a sort of middle way between theism and atheism. It's saying atheism understood as the view that we're in a purposeless, meaningless universe. And it's saying both of these worldviews everyone thinks you have to fit into one of these teams, but both of these views have things they can't explain. Theism struggles to explain suffering. Traditional atheism struggles to explain the fine-tuning of physics for life, and what I'm going to talk about today, psychophysical harmony.
And then I explore a variety of middle ground options where there is cosmic goal-directedness, but in the absence of the traditional Abrahamic God. I'm not going to talk about fine-tuning, but it's come up quite a lot. So in the book, I press this charge that you can't explain fine-tuning in terms of a multiverse, that it's a fallacious inference. It commits what's called the inverse gambler's fallacy. This is something that's been in the philosophy literature for decades, but in typical case of philosophers talking to themselves, nobody outside of philosophy knows about it. And also what I do in the book is connect it to the science of the multiverse, which, as far as I'm aware, hasn't been done before, and try and say you don't get around the fallacy just by saying string theory's cool. Okay, so anyway, if people want to talk about that, I'd be very happy to. But today I'm talking about psychophysical harmony. So, the mystery, alleged mystery, is we need to explain why our conscious experiences and behaviour herd together in a rationally appropriate way. So the most obvious examples involve pain and pleasure. When something feels bad, people tend to avoid it. When something feels good, you tend to go for it. Okay. Of course, not all things being equal, you can persevere through a pain for some greater reward, but obviously this is not just coincidental, the pairing of these things. But this is quite general. In general, our conscious experience represents certain things and we behave rationally with reference to those representations. If my visual experience represents a chair right here, I might sit down if I want to rest. That would be a sort of rational response to that representation. And in general, any historical or sociological explanation presupposes that people respond to their conscious beliefs and desires in a more or less rational way. So why do people vote? Why are people going to vote for such and such today? I thought the election was yesterday, so I can't vote, which I'm a bit gutted about. But anyway, we will give some account of how what they've done is a more or less rational response given their beliefs and desires. Okay, so as I say, this doesn't feel like it needs explaining. Why do you avoid things when they hurt? Just because they hurt. It doesn't seem like it needs explaining. But I think when you think very carefully about it, there is a mystery here. So I want you to bear with me and just take very seriously. I'm just going to mainly focus on the most simple case. Think very carefully about this question for the whole talk. Why do people avoid things that hurt? And I'm going to just basically go through 7 different answers and say why actually each of them is problematic, and I hope we do realise it's a bit of a mystery here. Okay, so first answer, analytic functionalism. This is the view held kind of by influential philosopher David Lewis, pictured here. This is the view that conscious states are just defined in terms of what they do. So very roughly, pain just means a state which causes avoidance behaviour in response to bodily damage or something like that. That's just what we mean by pain. By analogy, poison is defined in terms of what it does, right? When we say something's poison, that just means it kills you when you ingest it. Okay, so this view makes the problem go away, right? Just like there's no mystery. How come all the poison kills people? Well, we wouldn't call it poison if it didn't. So if by pain we just mean a state that causes avoidance behaviour, then there's no mystery here. So this would completely solve the problem. Unfortunately, it's my view at least, not a very plausible view. When I say, my wife's in pain, that isn't a claim about her behaviour or the behaviour of her parts. It's a claim about how she feels. And I take it that's a very different kind of claim to, it can't be at the level of meaning cashed out in terms of behaviour. I mean, I guess analytic functionalism would just say, yeah, I'm talking about feeling, but claims about feeling just are claims about behaviour. Lewis made that in the postscript of his Mad Pain, Martian Pain paper. But there's very strong intuition that that's just not what we mean when we talk about feelings and experiences. These are not just claims about behaviour. And for what it's worth, most philosophers agree with me on this, that the Phil Papers survey of 2020, 60% of philosophers, quite a consensus, philosophers don't agree on much. 60% think zombies are logically coherent. So zombies physically just like us but with no consciousness. It doesn't mean they're possible, but that they're at least logically coherent, and that's just inconsistent with analytic functionalism. Because there you've got something that behaves just like someone who's in pain but doesn't actually feel pain. Because it's not a popularity contest, that doesn't sell anything, but it's at least should give you pause for thought if there's a significant consensus of the relevant experts think this. In fact, you could take what I'm saying today as an argument for analytic functionalism, right? If all of the other options don't solve this problem, then maybe this is an argument for analytic functionalism. Still an interesting argument because it's not a very popular view. Oh, so only 16% of philosophers think zombies are incoherent, and the rest are sort of agnostic or whatever. Okay, that's analytic functionalism. So we're just going to go through explanations of why people avoid things that hurt. Okay, next explanation that I find comes up a lot online. I spend too much time on Twitter. Natural selection, right? Well, I definitely believe in evolution and think we evolved our conscious experience through the process of natural selection, but this doesn't solve the problem, because any evolutionary explanation of the character of our conscious experience already assumes an explanation of psychophysical harmony when you think about it. Natural selection only has a motivation to make me feel pain when my body's damaged if I'm going to respond rationally to that pain and avoid getting my body damaged, right? But that's the very thing we're trying to explain. Maybe I didn't emphasize this. What I'm suggesting is it's a rationally appropriate connection between pain and avoid. Pain gives you a reason to avoid. If something feels bad, that gives you a reason to avoid. And therefore, avoidance behavior, all things being equal, is a rational response. So this is what we're trying to explain. How come behavior and conscious experience are related in this rationally appropriate way? So any evolutionary view already assumes that you're going to respond rationally to your experiences and therefore doesn't explain it, or you'd be going around in a circle. And a way to perhaps see this more clearly is to think of a thought experiment of pain-pleasure inverts. So here's Ned Block, who famously discussed inverted Earth, where people have their colour experience inverted. It's a planet just like ours, except the experience people have when they look at bananas is just like the experience people have here when they look at tomatoes, and vice versa. We could think about a world of pain-pleasure inverts, so a strange universe where when people feel pain, that instigates attraction behaviour. When people feel pleasure, that instigates avoidance behaviour. In that universe, people would evolve to feel pleasure when their body's damaged, because that's going to cause them to avoid getting their body damaged, or feel pain when they eat or drink, and that would cause them to do those things, right? Now this feels more absurd, feels more ridiculous, but I want us to just think very carefully on what is it that's ridiculous about this. I suggest it's not a logical absurdity, right? There's no logical connection between how an experience feels and what it does. That would be the analytic functionalist answer we just considered. If there's no logical connection and we're just in a meaningless, purposeless universe, why should what conscious experiences do, the behaviour that results from them, be rationally appropriate? Right? Why should it be? So I think what's absurd about pain-pleasure inverts is that they're doing the opposite of what they have reason to do. Right? If you're in pain, that gives you a reason to avoid, and they're doing the opposite of that. But why should the behaviour that results from conscious states be rationally appropriate? Why should we need an explanation of that? Okay, next explanation. Where do we take the time from? Was it 7 minutes past? Or does anyone?
It was 7 minutes past.
7 minutes past, okay. Okay. So I'll go to 37 minutes past. Okay, next explanation, slightly more technical one maybe. Hedda Hassel-Merck, fellow panpsychist, has what's become known as the phenomenal powers view. She thinks there's an a priori discernible, metaphysically necessary causal connection between pain and trying to avoid. So she just thinks, so a priori accessible means just through reflecting on the concepts, you can see that there's this necessary connection between feeling pain and trying to avoid. But it's not just a definition, so this is not the analytic functionist, it's not just what we mean by pain, it's a substantive metaphysical connection between pain and trying to avoid, but you can see just through reflecting that these things are necessarily connected. That's her view. Okay, two problems with that. One, suppose Hedder's right. Suppose Hedder's right that there is this metaphysically necessary connection between pain and trying to avoid. Well, there's also a rational connection. Avoidance is rationally appropriate if you're in pain, all things being equal. Seems to me, well, that's a bit of a coincidence. How come there are these metaphysically necessary causal connections that just happen to map onto rational connections? That seems like something that we need explaining. So my diagnosis of what's going on here is she's just misidentifying what is actually a rational connection. So there is a necessary connection here, but it's not a causal connection, it's just a rational connection. What is absurd about pain-pleasure inverts is not that they're infringing some necessary causal laws, they're just doing really irrational behaviour. The other problem, which Brian Cutter and Dustin Crummet, who I'm going to get to, have pointed out, that even if she's right, we've still got the question of, well, how does this connect to behaviour? So we could imagine a world where, people feel pain, they try to avoid. So they feel pain when they feel pain, they try to avoid, but then that causes attraction behaviour. So we've still got the problem of psychophysical harmony there. Next explanation, slightly more technical, a posteriori physicalism. This is perhaps the most popular view in philosophy of mind on consciousness. Maybe Alyssa has something like this view. Which is that there is an a posteriori necessary connection. Well, phrasing it to address this issue, they would say, I take it, that there's an a posteriori necessary connection between pain and avoidance behaviour. We're exploring different possibilities about what this necessary connection might be, if there is one. The analytic functionists say it's just a definitional one, it's just what we mean by pain. Hedder, Hassel-Merck says it's a necessary connection, but it's a priori. These physicalists say it's a necessary connection, but it's only known empirically through doing science. A bit like the connection between water and H2O is necessary, but discovered scientifically. This could go a couple of ways. It could be that pain is just identical to a brain state. C fibers firing, and C fibers firing has its causal powers essentially, sort of Aristotelian type view. Or it could be that there's an empirical identity between pain and some behavioural functional state. It's just not, so it's not about what we mean, it's a scientific discovery. Okay, well, I'm going to give an intuitive and a technical. I don't think this solves the problem, and I'm going to give an intuitive way of pressing that, and then a more technical way of pressing that. The intuitive way of pressing that is it just doesn't feel like an explanation, right? We're asking, how come conscious experience and behaviour are connected in this rational way? To say it just does necessarily doesn't feel any more satisfying than it just does, or they just are, right? They just are necessarily, just doesn't feel like we've given an explanation there. But I think the fuller response is to say that when we're thinking of Bayesian probabilistic reasoning, which I'm ultimately going to get to here, but this is the context in which I'm thinking about this, the relevant kind of possibilities are epistemic, not metaphysical. So a couple of examples to illustrate that. Suppose you're on a game show and the prize is behind one of 3 doors, and you say, what's the odds it's behind door A? 1 in 3, right? But in terms of reality, there's no chanciness, right? The prize actually is behind one of the doors. So we're interested in chanciness at the level of what we know or epistemological situation. Okay, that's a situation where it's metaphysically possible that the prize could be behind other doors. But I think it's clear that in probabilistic reasoning, we will appeal to possibilities that are, in fact, metaphysically impossible. So, for example, think of like when we're thinking about what's the evidence that water is H2O, right? Just imagine you're evaluating the evidence. So you have the evidence, scientific evidence, and then we've got various hypotheses. The hypothesis that water is H2O, the hypothesis that water is a fundamental element, as the ancient Greeks thought, and you'll be seeing, which of these hypotheses makes the evidence most likely. That's how you do Bayesian reasoning. But of course, most of these possibilities are actually quote-unquote are actually impossible. If water just is H2O, essentially, then it's impossible that it be a fundamental element. So it doesn't matter for the sake of probabilistic reasoning what's possible or impossible. It's about what's conceivable relative to your background knowledge in the kind of Bayesian calculation. So I don't think this addresses the problem. And so this is kind of interesting because I said 60% of philosophers think zombies are conceivable, but most of those philosophers think, well, we can't infer that the zombies are possible from that. And we have this debate with people like David Chalmers and myself trying to infer from logical coherence to genuine possibility. The argument I'm giving today doesn't require any such contentious inference, because I think it's going to be a probabilistic argument, and I think what's relevant there is conceivability. So we're not going to be making any such contentious inferences. Don't worry about that if that's a bit more technical. Okay, 10 minutes. So, explanation 5. The big guy, Mr. G. God. So Brian Cutter and Dustin Crummett, two philosophers who have a very good paper arguing that God is the best explanation of psychophysical harmony. Their explanation is that dualism is true, and God fixed up the laws of nature, connecting the mental to the physical in such a way that there's a rationally appropriate connection. Okay, so I think this is at least in the ballpark of the right explanation, because I think we're trying to explain why these are connected in a rationally appropriate way. And they're postulating, well, there's a rational mind behind creation that set it up like that. A couple of problems, though, with this. I'm very motivated by the problem of evil. Familiar problem, obviously huge debate, so that's my problem with at least the omni-God. But also we still have to ask, well, how did God do it? And I think the idea that God just made these she made these psychophysical laws, I think the psychophysical laws are, as Richard Swinburne has pointed to, are going to be incredibly complicated, right? If we're going to have to sort of fix it so that every behaviour is the vast variety of behaviour there might be, the vast variety of conscious states might be, they're always going to be hooked up in a more or less rational way. That's going to be incredibly complicated. In fact, I think, if God was going to do it, she'd do it the way I'm about to suggest. And that shows that actually God in an explanation of this is redundant. People are interested. I've debated Crummett and Cutter on these Christian and atheist YouTube channels. Richard Swinburne and I have also debated the problem of evil in relation to my book on the Unbelievable YouTube channel, after he kindly reviewed the book for the Times Literary Supplement. Lots of good philosophy YouTube out there nowadays. Okay. Right, final explanation, and the one I favour. So I hope you're probably not persuaded, but what I'm trying to say, when you really think clearly, it's not obvious why the behaviour that results from conscious state should be rationally appropriate. Why should that be? Okay, so here's my favourite explanation that I develop in the book, that matter is itself inherently rational. So we don't have a rational mind outside the universe, matter is itself inherently rational. So this is a form of panpsychism, panagentialist view, according to which fundamental physical entities are conscious, maybe particles or fields. Now, panpsychists don't generally think literally everything is conscious, but there will clearly be some. So the particles making this up might be conscious, but it doesn't mean the phone as a whole has its own consciousness. But clearly there are going to be some macro level entities that have their own unified conscious experience, like humans and other animals, or their brains perhaps. So that's the panpsychist view. In some circumstances, conscious particles, let's say, combine to make unified conscious entities. So the panagentialist is a development of panpsychism, a particular form of panpsychism, which says that physical entities with unified consciousness, like particles or the brains of organisms, are never compelled to behave, but are rather disposed to respond rationally to the character of their experience. So this might seem ridiculous to say a particle is rational. But what I want to say is, well, maybe you're thinking, it's because you're thinking of human rationality, which is very complex and the result of, involves mathematics and probabilistic reasoning and so on, deliberation. But I think rationality can exist in very simple forms. And I want to say the simplest form of rational response is, do what you feel like doing. I think that is a form of rational. If I feel like sitting down, one rational response is to sit down. Now, if you're a statistically normal human adult, you feel like doing something, you can deliberate and think, is this a good idea? Do I really want to lash out in anger? But if you're a very young infant and you want the cookie, you're going to try and get it, right? Because you can't deliberate and think, is this a good idea? Have I eaten too much? You're going to try and get it. So the basic idea is particles are sort of like kids. So just to try and make an analogy, let's pretend that snooker balls have unified consciousness. Probably panpsychists will think they don't, but let's pretend they do. Then we've got the white ball hitting the red ball, and the red ball shoots off across the table. Our standard way of thinking about things, the white ball compels the red ball to shoot across the table. On the panagentialist view, nothing compels anything. What happens is the white ball makes the red ball really want to shoot across the table, and the red ball responds rationally by following up on that desire. So basically take that and think about it at the level of particles or fields. So basically, particles have these desires to do things, and because they're so stupid, because they can't deliberate, they don't understand it, they inevitably follow their desires, and we get a predictable world. In the book, I connect this to Bohemian quantum mechanics, if people are interested. It's not inevitably connected, but it does maybe solve some problems with Bohemian quantum mechanics. Anyway, so why take this seriously? Well, because now, once you have this metaphysical view in the background, now all you need is natural selection, right? Because once you've got this idea that physical entities respond rationally to the character of their experience, now natural selection has a motivation to give us conscious understanding of the world and the right kind of desires, because we're going to respond rationally and survive well. Okay, that's the view. So basically, ultimately, I think this is a Bayesian argument. The likelihood principle derived from Bayes theory, if the evidence is more likely assuming theory A is true than it is assuming theory B is true, then the evidence supports theory A over theory B. I just think psychophysical harmony is incredibly unlikely without some kind of directedness towards rationality, whether that's God outside or whether that's matter being inherently rational. If there wasn't some directedness towards rationality, it's a bit like the fine-tuning argument, right? If there wasn't some, then it's incredibly improbable that you would, in general, get this rationally appropriate connection. Much more likely with there's some kind of directedness towards rationality. So the psychophysical harmony strongly evidentially supports some kind of directedness towards rationality. Very, very final, in the last 3 minutes, I just want to make a methodological claim that, a lot of people listening to this might be, even if they can't see what's wrong with the argument, you think, this can't be true, because I think people are happy to believe wild theories if there's hard data to support them, right, like quantum physics or relativity. But it's just some abstract philosophical argument. There's something that can't persuade you of such radical truths. I kind of agree with that methodology, but I would say there is hard data behind what the argument I've just been given. The reality of consciousness itself and what we know about it from the inside is hard data. It's not the data you can get from experiments, but it's real, and so any theory of reality has to accommodate it. And this might connect to Alyssa's very interesting articulation of methodology of metaphysics, that we should just look to physics or science more generally. You can correct me on how you articulate that. I want to say that's all important, but there's another fundamental source of data. the reality of our conscious experience and what we know about it from the inside. So what I'm most passionate about philosophically is we need to get to a point where we take both of these data points as seriously for theorizing about reality, both the data of experiments and what we know about consciousness from the inside. And once we take the data of consciousness as seriously as experimental data, then I think we'll become more open to being taken in wild directions by the data of consciousness. But still doesn't mean you'll buy my argument. But I want to suggest you should be you shouldn't have any methodological concerns about a philosophical argument taking you to wild places, because this philosophical argument is built on solid data. Okay, thank you very much. I'm a bit early.
So I'm going to start by considering a very general view of physical structure that is held in various more detailed forms by many philosophers and scientists. George and Rob would reject it. Alyssa perhaps would be sympathetic to it. So actually the little exchange you were having with Howard and Rob is sort of relevant to what I'm doing. So I'm not advancing this view so much as just putting it on the table in order to explore its implications for middle-sized significance, which is our topic. Okay, so weak emergence. I'm going to define a notion of weak emergence, and as you might anticipate, we're going to have a corresponding notion of strong emergence in a moment. So weak emergence is manifested when we have middle-sized things and events that first exhibit distinctive, you might say non-aggregative, don't read too much into that, distinctive properties and patterns of behavior, best explained through laws directly governing middle-sized entities themselves, but also are wholly physically realized or constituted by smaller entities, and third, conform to the causal closure of fundamental physics. All right, so what is meant by that third clause's notion of causal closure? It's sometimes expressed the way you have it here on the screen. Every physical effect has an immediate, sufficient physical cause. Insofar as it has a sufficient cause at all, every physical effect lacking a sufficient cause has its probability fixed by an immediate physical cause. What do we mean by physical cause? This is, philosophers debate this, but one way people try to pick out the relevant sense for the purpose that follows is to say causes, we might say, that are describable at and only at a sufficiently microscopic scale, perhaps physical chemistry and below. Immediate is inserted there to rule out mixed physical and mental causal histories, right? So we're always going to have a sequence of physical causes, a chain through time. And then sufficient is to preclude the necessity of non-physical contributions working alongside physical causes. All right, so physicalists who shy away from reductionist language emphasize that macroscopic behavior and patterns are best explained by macroscopic properties and laws. But on weak emergence, there is an asymmetrical dependence of the macro on the micro. Ontologically, weakly emergent macro states and behavior are derivative on this view. Although I won't take the time to elaborate it, if you're familiar with John Conway's Game of Life, Cellular Automaton, there are various generalizations of it. I think these cellular automata vividly illustrate how emerging high-level patterns can be distinctive in form, underwriting similarly distinctive causal explanations, while not in any way altering or supplementing the basic dynamics here given by these three rules that drive the world's evolution. So the existence of weakly emergent middle-sized things is relatively uncontroversial. More controversial is whether there are strongly emergent entities. Perhaps we can explicate strong emergence this way. Philosophers fuss about this, and you'll see different ways of trying to formulate it. I'm going to do it disjunctively. So I'll say that strongly emergent behavior of a complex system occurs when reflecting a fundamental emergent law, either the parts of the system at some scale exercise in a coordinated fashion basic causal powers that they do not exercise outside the systemic context. I'll dub this collective fundamental difference making. Or two, perhaps the system itself has a novel, non-structural property or power, a primitive, right, macro level property that makes a difference to the system's activity that again is fundamental. That is, that's not determined by the sum in any sense of the activity of and relation among its parts. You could call this unitary fundamental difference making. So strongly emergent behavior, if such there be, which is very controversial, is not inexplicable, as is sometimes alleged. It's not reductively explicable, it is true, but where it occurs in ways that can be studied and eventually could be predicted on the basis of laws that link them in a dynamical co-evolution with certain structural kinds. All right, it seems to me that human and animal consciousness, and so here Philip and I are on the same page, but where I mean by this, not just experience, conscious experience, but also conscious attitudes and agency, is a highly plausible, and I would think the most plausible candidate for strong emergence. Even so, the considered view of many theorists is to deny it, deny that conscious experience is in fact strongly emergent, just because it entails the failure of causal closure of fundamental physics. But why should we believe the causal closure thesis? Some, like David Papineau, philosopher, infer it from the principle of the conservation of energy. All right, so now begins a very brief physics amateur hour, little interlude, but I'm quoting people who are far better informed than me. The conservation of energy, while Sean Carroll and co-author call it a cherished principle in physics, has a very uncertain status as an exceptionless principle even in physics. So I'm informed that it's known to fail for spontaneous collapse models of quantum mechanics. It appears also to fail for quantum measurement in Copenhagen and Everettian models, again according to Sean Carroll. And finally, Tim Maudlin has argued that in different physics contexts, and specifically when gravity is taken into account, there is, quote, no satisfactory way to define a useful notion of energy that is generically conserved. Now, if these claims by my informed betters are correct, I of course must defer to George here, the upshot seems to be that conservation laws are best seen nowadays as regulative rather than axiomatic principles, useful but often not essential, again quoting Maudlin. Further perspective on energy and momentum conservations provided by a recent article by Kusu and Pitts. They note that it is a consequence of Nether's theorems that there is conservation if and only if there are certain deep forms of time and space symmetry in physical processes. And within a modern physics context of continuous fields, the conservation laws are first and foremost a local, not global affair. quote, given any region of space, the change of energy within that region equals the flow of energy across the boundaries of that region of space. Conservation will thus fail wherever there is a broken symmetry, which circumstance is always an open empirical question. And symmetry breaking is implied by the very claim of any localized factor, such as the consciousness of me, right here, intermittently affecting local energetic states, as the dualist stance of conscious minds affecting brains maintains. All right, so that's the end of Physics Amateur Hour. Now, Papineau speaks of the strong, who's an anti-strong emergentist. He speaks of the strong emergentist as being committed to mental force, and he complains we have no evidence of such a force. But I think that exertion of mental force and the associated concept of energy is the wrong way to think about the efficacy of the will or of consciousness more generally. Conscious states are sensitive to representational, informational content, and not mere physical energy as such. And they are at times causal influences on and effects of conscious choice. That said, I concede that we lack a good theoretical framework for conceiving conscious mind-brain interaction on a strong emergentist picture. Recent dualist conscious field theories interfacing with electromagnetic fields in the brain provide a start on such a model, but they seem better suited to perceptual states than to non-perceptual cognitive states or the capacity of choice. Okay, let me draw on these elements that I've introduced thus far in order to speak to the question of the significance of middle-sized things. So consider a, practically speaking, disinterested, disembodied, and computationally and observationally limitless Laplacian observer of a total world. A world that is devoid of conscious minds, where we grant the physicalist assumption of there being merely weak emergence as regards all non-conscious systemic behavior. Okay? So now you're imagining this hovering above the universe, so to speak, this ghostly mind. What significance would such an observer see in a landscape with intermittent, coarse-grained macroscopic patterns that, like all else, are wholly determined by the fundamental physical dynamics, whose swarming interstices he sees in perfect detail? I suggest the Laplacian observer would regard it as aesthetically interesting that you get these bubbling up macroscopic patterns here and there in this cosmos that's fundamentally determined by microphysics, but of no deep theoretical interest. The macroscopic laws describing such intermittent phenomena are wholly derivative. They are wholly unnecessary to explaining the distribution of matter energy, even in the vicinity of their limited application. And the fact that the initial conditions and fundamental driving factors of the cosmos tend to give rise here and there to pockets of material systems exhibiting such law-like coarse-grained patterns is itself entirely predictable, that is, to our marvelous observer. It would be entirely predictable. All right, now consider a modified scenario including embedded, strongly emergent conscious agents. To a very significant extent on the cosmic scale, it unfolds much as the first one did. Fundamental physical forces and processes giving rise to more or less pervasive, weakly emergent structures and processes. But it also has small eddies where strongly emergent, minded biological creatures fundamentally affect the physical processes in and around them. The immediate effects of their conscious states and decisions are not wholly fixed by the ordinary activity of the constituent entities in and around them at any scope. Finally, within such a strongly emergent scenario, consider how certain of the weakly emergent structures and processes precisely those that are middle-sized, look to the interested and embedded, strongly emergent conscious agents themselves, perhaps ourselves if strong emergence is true of us. Their perspective, their beliefs and interests, and their consequent aims are largely or wholly shaped by middle-sized categories. Middle-sized objects and processes are of deep practical significance to them. And they are of theoretical significance too, since strongly emergent behavior makes a fundamental difference, and one cannot understand such behavior in theoretical terms apart from the agent's practical perspective. A total theory, right, on a strongly emergentist view, on a view on which you have strongly emergent conscious agents who are effective in the world, a minimally adequate theory of how the cosmos unfolds has to take account precisely of, because they're fundamental causal agents, has to take account of their influence, right, in addition to the ordinary microphysical dynamics, and you can't understand the activity of conscious agents apart from understanding how they're seeing the world and what they're attempting to achieve. So imagine a Laplacian observer of such a modified world. In order to formulate a minimal theoretical basis for the world's unfolding, he needs to refer to the middle-sized objects and properties that shape the activity of fundamental difference-making conscious agents. In short, since practical thought informs strongly emergent activity, its content must be integrated into one's theoretical understanding of what's happening. This suggests to me that enthusiasts of merely weakly emergent phenomena are not wrong to see them as of deep theoretical significance. It's just that they have misidentified it. The many varieties of weakly emergent structure have importance within the overall architectonic of the world, first, by providing a stable platform for strongly emergent structure, in some cases, as with the emergence of persons, and second, and much more generally, by providing a structured, middle-sized world for strongly emergent structures or entities to engage, including making possible, if we ourselves are such agents, our own scientific activity and theorizing. Students of the kind of abstract structure and dynamics that is wholly grounded in more basic processes, weakly emergent structure and dynamics, such students explore life worlds and other cellular automata as conscious knowers, hovering over the deep of these abstract, constructions, grasping the varied macroscopic patterns that weakly emerge and their underlying basis. And as middle-sized agents themselves, they tend to ascribe significance to the structured patterns by analogy to the immediate practical significance that the real world analogs of such patterns have for ourselves. It is significance to ourselves and to any other conscious knowers there may be, which knowers we implicitly take to transcend such patterns. If I'm correct, then, our question concerning the significance of middle-sized things turns on their significance to the conscious minds that do or might contemplate them. In a world with merely animal minds, the scope of middle-sized significance is restricted to the creatures themselves, their food sources, and salient features of their habitats as objects of their practical deliberation, planning, and choices. The addition of human consciousness dramatically widens the scope of middle-sized significance. It's not just the widened range of our practical activity. As this very conference illustrates, our collective theoretical, and we might add even aesthetic, interest is wider still, spanning from the heavens to the elements. The intentional content of our theoretical and practical attitudes affects our consciously directed activity in various ways. And so the very wide categorizations of middle-sized objects that we deploy we'll enter into a minimally adequate understanding of natural reality. Finally, suppose that theism is true. How might the reality of an all-knowing cosmic creator, not mere observer, impact the significance of middle-sized things? From God's perspective, creation is an integral unity, and we might well suppose that God chooses the fundamental physics in part for the sake of its subserving macroscopic patterns, and in particular, the value of sentient creatures, and specifically of intelligently choosing sentient creatures such as ourselves. If so, then certain middle-sized things and the structures needed to sustain them are, despite their very late appearance and tiny size relative to the cosmos, at the very center of theoretical and practical significance. Thanks.
Thank you both very much indeed. They were both very stimulating talks, and I have a little to say about both.
It's 30 seconds, but the aesthetics improve immediately. Middle-sized values.
Which are important, as you point out, from our perspective, not from any other. Beginning to say a few things about Philip's talk. And I'm worried about this notion of agency that he uses, and I'm worried about it at two levels, the micro and the macro level. The micro level, in what sense is it free agency or agency at all if what a particle can do is restricted to one or two things, exercising a fixed mass or a fixed charge, and they actually never even choose to refrain from doing that, all those things. So it's absolutely certain that they will all the time do it, and there's no chance, not merely that they can do anything else, but they might even decide, I can only do that, I'm fed up with it, I won't even bother doing that. So that the idea that that's agency seems to be a very strange idea. Now, I don't want to say that if you never do anything other than what you do, you can't do something different. In an interesting way, I'd apply this to theology. A lot of people say that God cannot do wrong. My view would be, of course it could, but it's absolutely 100% metaphysical certainty that it won't. And I don't think you could move from what doesn't happen, and is never going to happen, and you can be sure never happens, to a modal conclusion, and there's no need for it in the God case. But that's a bit controversial. But I certainly think in the case of particles, it's very odd to think the thing is an agent at all, if what it does because something else, well, in some cases puts itself in the position of doing it, or if it's just sitting there being an electron, because it never does anything else, and there's no other option it could do, and there's nothing that, it doesn't even stop and go to sleep. So that's a very strange use of agency, I think, altogether. He said it's very simple agency, pure act of will, but, I mean, normally agency seems to presuppose some kind of decision process, even if a very elementary sort, and there's absolutely no such process. You might want to say that an electron really has quite an active mind, we just can't see it, but that's not what Philip wants to say. He doesn't want to attribute a sophistication there. Now, all the action that Philip considers, or seems to consider, is a kind of desire satisfaction, almost a kind of behaviour with consciousness included, a sort of stimulus response kind of thing. And that's obviously important, but that's not what we think of as being the whole of rationality, or indeed most of rationality. Rationality involves something that he never mentioned, and which panpsychists are cautious of mentioning, namely concepts. The grasp of universals, as well as the presence of conscious phenomena, as in the sensation case. And I've not come across any panpsychists. Most panpsychists do believe in
cognitive phenomenology as well as bare phenomenology, which people like James and Russell in the original forms of his neutral monism didn't. They were behaviourists about that, if they were anything, certainly Russell was. But if you're going to have cognitive psychology, phenomenology, and certainly if you're going to include the rationality in the conscious bit, you've got to have grasp of concepts. Grasp of concepts cannot be constructed unless you're a primitive imagist out of the sensations that you're having. So I don't see how you get to real rationality, even if you can imagine the thing being trained to avoid what it doesn't like because of the way it feels, or to go what it likes because of the way that feels. That's still not going to get you what's happening in our minds when Philip and I are having an argument about this sort of thing, which is conceptually driven, not driven by, unless you're going to give me a kind of sort of Freudian reductionist, any discussion is really just about what makes you feel good in some way or other. But if you're not going to go down that sort of way, then I don't see that any of that is being accommodated. Right. So that's the kind of complexity that Philip wants. I don't see why a robot couldn't have it, more or less. In other words, you do the same job by complexity of organisation, avoiding something that's damaging you or whatever. The consciousness is not really, doesn't have to be doing a lot of work. So that's my worry about Philip's. The trouble with Tim's talk is that I don't disagree with any of it at all. So I want to say I want to say some, I think, were elaborations of the thought. Peter van Inwagen denies the reality of complex physical objects altogether. They're just atoms arranged table-wise. I put it differently in something I wrote in 2016. I talk about conceptual reality and, as it were, real reality. Something is conceptually real if we've got a concept, and that concept fits the things it's meant to fit, by and large. So the concept table fits what it's meant to fit. So tables are conceptually real. Things are really real if they're there whether we have any concepts or not. They're there just because they're there, as it were. And I agree with Tim. It's only if the world is closed under physics, that's the only really real bit. The rest is conceptually real if there's some point in noticing it, so to speak, or if you want to introduce the concepts. I want to make 2 points in connection with that. What would have to be the case for complex physical objects to be more than conceptually real? If you were an emergentist, a strong emergentist of the C.D. Broad type about chemistry, where when 2 or 3 are gathered together or more, as it were, in a molecule, it behaves in a way that physicists couldn't have predicted in principle. Does that make molecules really real? Or is it just the case that after all, people show no properties if they're just on their own? Normally, you've got to interact with them to find there's a property there at all. If they started showing extra properties when there were a lot of them interacting, would that mean that they were further objects, or just that they were still just collections of things that behave differently when there were a lot of them near to each other? I think the only case in which you'd have to say there was a really real new object was if what it did had a teleological significance, say, for its own preservation or reproduction and all the rest of it. Because that only makes sense in the context of it being the sort of object that it is when it's come together. Whereas just in the chemical case, the C.D. Broad case, that's not so, I think. It just is when you get more of them, they behave in ways they wouldn't if they were on their own. So it would need something irreducibly teleological in order for that not to be, for there to be real objects further down. That, of course, would justify, wouldn't justify Peter van Inwagen's attempt to say that despite him not believing in complex objects, he is real himself, and that organisms are real. But I don't think it does in his case, because he's a physicalist, and as I'm going to say in a minute, if it's just happening for the physical reasons, and
understanding of it teleologically implies a certain interpretation of what's going on, I'm not sure that it really would get him out of the problem. But I want to just mention, I got that a minute too late. Something that I argued in 2016 against Dennett. If you have this conceptualist picture, which is very, very similar to his interpretation of this picture of other minds, you've got to be a dualist, because if there's something doing the interpreting, it must, as it were, be an intentional system itself, a genuinely intentional system. And if complex objects that are purely physical are only conceptually real, we can't make ourselves real by understanding ourselves conceptually in a certain kind of way. And that's very like the reason which Hume decided his own theory of his version of bundle identity didn't work. He thought complex objects were only real objects because we decided to group the things together. And you can't do that for yourself because there's nothing to do with the grouping together. Similarly, I think, so what Tim says is right, and it's an argument for dualism. Because the very fact that we can conceptually create these things means that we're different kinds of things out of the things that are only created conceptually while being complex. So I think that's an interesting, entirely consistent with what Tim says. So I'm sorry that my colleague and Lutz Gauss lad I'm disagreeing with, but I hope not unsympathetically, but asking how you deal with the real intellectual, rational side of the conceptual. And Tim, I have no more thing to say except yes, and even more.
Yeah, what I mean by rationality, I'm having a very crude notion. I just mean responding to reasons, thinking or acting as you have reason to do. And Howard said, well, if it's just pleasure, pain, that's just stimulus response. I don't think that's right. I think it's a very nuanced form of rationality. If something hurts, that gives you a reason to avoid it. And in responding to that, of course, often you do just respond, before you think about it. But insofar as you're consciously avoiding the pain, that is rational responsiveness. Likewise, when a cat goes for the dinner because it wants the pleasure, that is a very simple form of rational responsiveness. I think that's I think we just need to think carefully about why is it so obvious people are going to avoid pain. It's because it's obviously the rational thing to do. And we're just assuming that people are, if something's so obviously the rational thing to do, they're going to do it. But then, well, that needs explanation. Why should people respond rationally? Maybe we could explain that in evolution, but I said, no, evolution presupposes an answer to this. So that's one way. So I do think this is a form, it's not just what a robot has, it's a very simple form of rational responsiveness. Yes, it's very different in human beings, because, as Howard says, we have conceptual understanding of the world around us. What I want to say is, it's exactly, on this view, it's a wonderfully simple view. There's just one kind of causal principle. Things respond rationally to the character of their experience. But if you're a very simple animal or a particle, or that has one form, but that exact same disposition to respond rationally flowers in a very much richer way in a being that has conceptual understanding of the world around us. But it's the same disposition. So I want to say, me and the particle and the cat have the same disposition, but it manifests in a different way because I've got much more conceptual understanding. And how do you explain conceptual understanding? I don't know. I wasn't trying to explain everything. I'm trying to address a quite particular part. And I agree with Howard. There are deep challenges that Howard in his work has very well articulated. I didn't understand why, because I was going to mention God, and I don't understand. I mean, is this really agency if they would never have behaved differently? I mean, I'm not necessarily. I just discussed in the book whether this could be libertarian free will. You needn't necessarily think of this as libertarian free will, just rational responsiveness. But yeah, I mean, God. If you think of God as
could God have tortured children for fun? Or maybe God's omnipotent, God has the ability to do that, but it's metaphysically impossible for God to do that. Whatever you say about the God case, I would say something similar about particles. In a sense, they have the ability to act otherwise, but they're never going to exhibit it. But anyway, even if you want to say they couldn't have acted otherwise, fine, it's not libertarian free will then, it's rational responsiveness. And yeah, very, very, very finally, I didn't say anything about how this connects to middle-sized objects, and that's because this view inevitably involves fundamental causation at the level of organisms. That's what you need to make sense of why we've evolved conscious understanding. So the idea is that it's not just the particles with the fundamental rational responsiveness. Any macro-level unified whole is also involving a sort of fundamental causation where it's rationally responding to the character of its experience. And then natural selection has a motivation to give us the right kinds of desires, the right kind of conscious conceptual understanding, so we respond rationally to it. So it does involve fundamental middle-sized causation.
All right, I'll just briefly comment. Howard suggested, so I spoke of weak emergence as ontologically derivative. I start off that way. And then I proposed that weakly emergent phenomena gets bootstrapped, you might say, into being of fundamental theoretical explanatory significance in the presence of strongly emergent subjects who treat them as practically and theoretically important. And Howard wondered, well, isn't this a kind of argument for substance dualism insofar as we, or minded creatures in general, alone have the ability to confer a kind of reality on other complex systems? Whether it's a kind of substance dualism, I'm not sure that you're going to automatically get that. Because it seems consistent that you could think of something along the lines of Aristotelian hylomorphic entities, irreducible but materially composed entities, and say everything that I said here. So I'm not sure that you automatically get there. Now, yeah, thinking about the nature of subjectivity might push you towards a stronger kind of dualism.
Yeah.
But yeah, all right, that's all I'll say.
That's do we need a microphone?
I think we're managing without, aren't we? But if there's problems, I'll go around the front.
Yeah.
Thank you. I have a question for Philip, but that was such a beautiful talk, yeah, so I really love that. But I wanted to ask a question for Philip. Your talk was like fascinating and the view is super cool. So I'm a type A physicalist, or like I aspire to be a type A physicalist.
I got misidentified.
I didn't know if you said that I was a type B, or I didn't know if you were talking about ASEC, because I think you had a picture.
No, I thought you were a type B as well.
But you
I
had
had
a
a
really nice
picture.
picture.
I didn't think that was you.
Okay.
But I thought you were type B, sorry, I got that wrong.
Okay. Well, one thing you didn't mention, I mean, when you were complaining about the type A, is there are these dissociations. Like, there are people who have a sensation of pain, but then they don't want to, they don't actually withdraw from it, and then you have the dissociation in the other direction too. So I thought the type A physicalist should be connecting the two, and then, connecting one kind of pain. So pain is ambiguous between all of these different types of things, and then the sensation, which is the one that you're focusing on when you're talking about zombies or whatever, going away, is just something that kind of comes along for the ride. So I don't have to make it rational that a person with that sensation that wants to withdraw. I just need to make it rational that the person that has the other kind of pain that's analytically connected to the desire to withdraw wants to withdraw, and then this other thing just comes along for the ride. I don't know.
Yes, that's
it.
it.
Talk about this kind of dissociations when you're talking about this?
Yeah, I should have said something about it. Just in case people don't know about this type A, type B, this is from David Chalmers. So type A physicalism is close, maybe? The analytic functionalist position I started off with. So type A physicalists think zombies are just logically incoherent. They just don't make sense. whereas type B physicalists think, oh, they're perfectly logically coherent, they're just impossible. And for what it's worth, the latter is the more common position. But yeah, no, I should have said, so there do seem apparently empirical reasons to think people can have pain without it hurting. So I should have said what I'm talking about is the hurtiness. Is the, insofar as you can distinguish the qualitative and the affective bit, I'm talking about the affective bit, the bit that feels bad. I'm saying, how come there's this connection between feeling bad and avoidance behaviour, which sounds like an odd question, but I really think that it isn't. But if you're a type A physicalist, Alyssa, you do just avoid this problem altogether. So maybe, and as I say, you could see this. My friend Keith Frankish, I think, you could see this as an argument for type A physicalism. Because look, if you don't say there's a definitional logical connection between feeling bad and avoidance, then it does seem a question. Well, why do they go together in that way? So you could turn my argument on its head, and we'd have to have a different argument about type A physicalism. I mean, doesn't it just seem that that's not what we mean when we say someone's in pain? Something that could be cashed out in terms of behaviour. That's not an argument. That's just a statement. That's not an argument. We could talk about that. But yeah, we don't necessarily disagree on that.
Okay. Richard.
First, just to correct a misapprehension. Philip kindly quoted an argument of mine saying that if there are to be contingent laws connecting conscious states and brain states, there would have to be thousands and thousands of separate laws. I think the way you put it suggested that I was using that as an argument against God having created them. But I wasn't in fact doing that. On the contrary, my point was that only God could. It would need a rather God-minded person to create all of those laws. I was using it as an argument that it would be very difficult for us to discover those laws, because you wouldn't have enough instances of them to find out whether they are generally in operation.
Yes, no, you're quite right. I was thinking, I said that sort of on the fly, and I was thinking of that exactly the misapprehension that as I was saying it. But yes, I suppose I was saying just the similarity to what you said, that these laws would be incredibly complex. And then I was making the point, well, look, if we can have a simpler theory that explains this without incredibly complex laws, that would be better. So that, the analogy to your argument was simply that these laws would be very complicated. But yeah, obviously I agree that you're not using it to argue against God.
How many people want to ask a question? All right. That's right.
Me?
Yeah.
Timothy, thank you for a very clear paper. I have three quick things. One is conservation of energy in this argument. Okay, whenever you say conservation of energy, you must ask on what scale are you talking about the energy, because the different scale is different. And if you have, for example, a crystal in which there are phonons, there is energy transferred from the crystal level to the phonon level. So in fact there's an interlevel transfer, and it is perfectly conceivable that a similar kind of thing would happen in a neuron, for instance, or whatever. So that's the first one. But also, Anderson famously talks about emergences being due to broken symmetries, and Noether's theorem says that that symmetry is related to conservation of energy. So Anderson is saying energy will not be conserved, and it's probably related to what I was just saying. That's point number one.
This is
two,
the Anderson Morris different guy. Yeah. Okay.
Point number two is that I talked about rational thoughts yesterday and the power of algorithms. But what I think is interesting in the general context of what we're talking today is that most people, and actually most causation in the brain is not due to rational thoughts, it's due to narratives. And narratives are a form of explanation which help us to understand things and make sense of things. And there's a wonderful paper called Conviction Narrative Theory, which talks about the power of narratives and how they're causal in the context of the brain. That's the second point. And the final one is, when you were talking about weak and strong emergence, you didn't separate out synchronic and diachronic. And I think the argument of the reductionist is perhaps true in the case of synchronic coordinate. But the question is, what's the situation going to be in the next microsecond, and I think it's in that context that the argument is right.
Good, yes, I do think of strong emergence dynamically, right? I think that's the right way to do it. Good. Survive that. Okay.
Richard, did you have a follow-up?
No, but I had a slightly different point to make. You argued that natural selection couldn't deal with the correlations you were talking about. I think following up point over there, we ought to be clear about just what the correlations are. Pain can be used in different senses. The word pain can be used in different senses. And sometimes it's used just as the name of the nociceptor, the bodily injury, and other times, especially of course by those who study bodily injuries, in the much more natural and common sense context, it's used to as a name of a kind of sensation connected to a desire to get rid of that sensation. Now, of course, it's not always connected with that, because there are some unfortunate people who don't have the desire to get rid of it when they have what seems to be the same sensation as normal people do. But it doesn't, not merely does it need a desire to get rid of the bodily injury, it also, in order to be useful, it also needs, the human agent needs to have a correct belief about what is causing this. And so, I think the way that you should phrase the connection is what is sufficiently puzzling, is that bodily injuries lead to sensations of a sort that most people desire to get rid of and are connected with a belief about how to do so. Now, natural selection could play a significant role in explaining why that correlation exists, because if there are people who don't have the desire to get rid of it, they have to be looked after so that they don't mind falling down the stairs and so on. And they would be quickly eliminated if there weren't people to look after them. And likewise, if natural selection didn't, and if evolution, if natural selection didn't produce right beliefs about the causes of our sensations, then also we'd be in trouble. Now, natural selection can only operate on what's thrown up by the genetic material at the bottom. And if the genetic material threw up anything that didn't have the desire to get rid of it, or didn't have the right beliefs, then indeed it would be eliminated. So, assuming that one of the things that genetic material throws out is that there are people who have the right desires and the right beliefs, then they are likely to survive. But if natural selection, if genes do throw up other sorts of desires and beliefs, then they would be quickly eliminated. And so it seems to me that natural selection can explain if the genetic material throws out competing sorts of people, why they are quickly eliminated. Now, of course, that isn't going to be the whole story, because one will want to know why among the material among what the genetic material throws out are people of the right sort. And maybe, and that is something that does need explaining, but if it throws up all sorts of things, then natural selection can explain why many of them are eliminated.
We've only got a few minutes left, so I'll keep it quite quick.
Just quickly, I mean, I should have been clear. I mean, desire is also a bit ambiguous. It could mean something functional, behavioural, but insofar as we're just talking about a felt aversion, I suppose my issue is it's logically coherent to have a world where felt aversions lead to attraction behaviour and felt repulsions lead to, felt attractions lead to avoidance behaviour and felt repulsions lead to attraction behaviour. That's logically coherent, and you know, the beliefs would all work in the same way, and those creatures would evolve to feel pleasure when their bodies are damaged. So we still need an explanation. I don't disagree with what you said needed an explanation, but I think we also need an explanation, strange as it sounds, why felt aversions lead to avoidance behaviour if there's no logical connection. That's, yeah.
I think we must move on, Richard. We've got
Sorry, yes, all right.
Yeah.
Okay, thank you. So thanks to both of you. My question is for Philip, in fact, and I think it might be related to the two previous questions. So I think I'm one of the people who still have to be convinced that there's
most people.
And so I was just wondering whether you couldn't describe the relation between, I don't know, phenomenal experience and so pain and pain avoidance behavior as an ordinary nomological regularity, and so what the crucial difference between that nomological regularity and other nomological regularities that we have in the world is.
Good. Yes. Well, you could think of it that way, but the point is, I want to say there's that nomological regularity. It reflects value considerations because it's rationally appropriate for pain to go with avoidance, pleasure to go with attraction. So this is striking that these things that are not logically connected happen to be connected in a value-laden way. So it's maybe a bit like the fine-tuning in physics. Think of all the numbers that could have come up in physics. They're the ones that are right for life, which is something of intrinsic importance. So like, how is value getting in the laws of physics, seemingly? So similarly, how it seems like how things have turned out respects value in the sense that rational appropriateness is an evaluative notion. That's the thought.
Okay, great.
We've got time for one more quick question. Well, you have to be quick. You can both question and answer, Father.
So I'm curious because I think this. I apologize for Philip again. Both talks are wonderful. I think I might be a panagentialist, but not a panpsychist. And I think there's a way of reading Aristotle to say that he would be as well, in the sense that why is it that Earth goes down? Because it has a natural desire to go down. That desire is not conscious laden, but a fundamental aspect of what the physical of what it is to be the sort of thing that is Earth. I think you could update that to something. What is it to be the sort of thing that is a electron, to be attracted to certain charges and avoided from others? And as we go up the scale, then that fundamental notion of tendency, that fundamental notion of directedness, leads to a more complex vision that becomes consciousness. And I'm curious why you couldn't start with the agentialism, panagentialism, that builds at higher levels of consciousness. Why do you need to bring the consciousness down? What is the psyche doing at the lower level?
Yeah, I mean, it's interesting. If you could make sense of rational responsiveness without consciousness, then maybe you could do that. I'm not sure that's quite what you were saying, but I suppose also, I mean, you could have a view, and maybe a lot of people at this conference have this view, where there's just fundamental rational responsiveness, but it just pops up at higher levels, probably Tim's view. But I think the panagentialist view that would kind of solve the problem, I think, but this panagentialist view I described is a more simple, elegant, unified picture of reality, which I think is what makes it very attractive.
We now go for a simple, elegant cup of coffee. How long? What's the break length?
30 minutes, and we're going to do the talk.
The whole like that. Back where we were before.
Thank you both.
presentation ratio has gone way, way down. Now, that being said, tonight, for those of us, that is speakers and respondents, who have a speaker's dinner tonight, it's going to be in the hall of this college. There's a correction. We've been bumped to the hall, which is not what normally happens. Like normally they say, "I'm sorry, the room isn't available. We're going to have to give you something else." But we negotiated it. We went in the back room. We plied them with wine, and they said please, and compliments, and they said please come to the high table. And so we're very honored. There is not a dress code. If you have a tie, wear it. If not, don't worry. There is not a dress code. If you have a tie, wear it. 6 o'clock, if you like, some of us are going to walk over to New College for Evensong there. It'll be a little different from the Pusey Evensong. It's longer, but the New College choir is one of the better choirs in England, and therefore the world. Now, that being said, I'm going to introduce you to someone that I've had the pleasure of knowing and interacting with socially, religiously interacting with him socially, and philosophically. We've done a few of these events together over the years, and that's Dr. Daniel de Haan, and he is currently the Frederick Copleston Senior Research Fellow in Philosophy and Theology at the University of Oxford, and in all modesty, his interests are mainly philosophical anthropology, moral psychology, phenomenology, neuroscience, and metaphysics. There's a longer list, but we couldn't afford an extra sheet of paper here. We didn't have a grant for it. But Daniel de Haan is someone, there's a few people like this. One of them was here earlier, and one of them is still in the room, that whenever I speak to him about something, I come away having learned something. What I've learned, there's a danger, is that we tend to agree on quite a lot of things. So I'm going to rack my brain during the presentation for the things that I find most disagreeable and make my response based just on that. So, Dr. de Haan, would you please take the podium, or as you like.
Thank you so much, William and Jonathan and John for organizing, and there are other people I think who've organized as well, and thanks for the kind invitation. This probably is a bit of a talk that's maybe shifting gears in the way that John referred to, but I think we'll have some points of overlap with others. And that's a pretty tall order to require that everyone learn something. So I'll do my best.
No, I just need to learn something.
Oh, fair enough. Okay. In that case,
that's my
just the normal.
Solve my abstract will solve that problem. All right. So let me get started to make sure I get it within time. So my title of my talk is Why Middle-Sized Causal Powers Matter for Scientific Experiments. And I'm going to disappoint the people who disagree with me by not getting into the detailed arguments that I would need to get into to defend the view. So it's more of a rival image, and hopefully we can get into discussion and over drinks even better arguments and exchange on those issues. The discoveries and purported theoretical implications of scientific experiments range over phenomena that are infinitesimal to middle-sized, to those gigantic, galactic, and even cosmic events. The gravity of much theorizing, however, has tended to amass in assigning fundamentality to the extremes of this picture, while demurring the reality of middle-sized objects like us. And in this talk, I want to give us some grounds for holding our scientific image of humans and the world cannot be so radically incompatible with the manifest image of humans in the world that we start with and that we still live and breathe within. This manifest image of the world, even as it's enriched by scientific images, as I understand it, requires the fundamentality of middle-sized objects like us. I want to illustrate why we could not discover the existence and causal powers of the smallest or the largest of objects or phenomena without the ontologically irreducible middle-sized causal powers possessed by humans, who, as scientists, fabricate middle-sized technological artifices which they employ in their experiments. If these humans or their lasers, reactors, particle colliders, or interferometers didn't have any of the fundamental middle-sized causal powers, then they could not conduct the controlled experiments, leading to theoretical results concerning the existence and causal powers of either microphysical or cosmic phenomena. And I'll focus on the medium-sized powers of human scientists, indispensable, I believe, for performing scientific experiments. But I think someone could extend this argument with some complications to certain scientific artifacts that are also indispensable for scientific experiments,
and what sort of irreducible causal powers they might have, like lasers, reactors, particle colliders, or interferometers, arguing that they have some proprietary causal powers not possessed by any of their components or even aggregates of them. But I won't try to make that case here. So first, a few quick assumptions. So one is working out of the framework of a kind of sparse ontology, and part of the way that we prune that ontology is through the use of like an Eleatic principle or something like that, that the kind of things that exist are the things that have causal differences, make causal differences in the world. Second, one could buy into some sort of like Cartwrightian informed ontological naturalism, a kind of ontological naturalism committed at least to the existence of whatever is required to achieve effective and true scientific inquiries. And so many ontological naturalists following Quine maintain that our ontology must recognize the existence of what is disclosed and required by our best scientific theories, but we can expand this in a Cartwrightian sort of way by drawing attention to the things she talks about with nomological machines and what's required actually to set up a scientific experiment. And so our best empirical descriptions and explanations also require the existence of entities that are needed to make our best empirical methods and techniques effective. So we should extend the Eleatic principle to those things as well. Third, I'm not going to be, unfortunately, having time to make arguments for the fundamentality of medium-sized arguments, but I do think that we sort of have a point of departure where the onus is to try to undermine that. That's actually the point of departure, and some of the arguments I'm going to be, or some of the account I'm going to be giving is going to give us resources for thinking that's true. But I think we have available quite a few of these models of how we could defend this. And one that hasn't been mentioned yet, but I think is worth mentioning because it's complementary to a lot of things that have been said today, is Ross Inman's book on the fundamentality of the familiar, which is a pretty detailed Aristotelian defense of middle-side objects against priority monism and microparticularism, microparticles. But I think that the onus is on those who want to reject the fundamentality of middle-sized objects. And so I'm going to provide some illustrative resources for making clear how cosmic the scale of burden is to overcome this manifest image that's enriched by scientific images. And even though my argument doesn't rely on hylomorphism, the kind of medium-sized objects view that I would have would be a kind of hylomorphic one. But I think that some of the things I have to say could be also worked out in terms of something more like Jessica Wilson's view about strong emergent objects. It's a pretty similar view, as well as features that are similar to Carl Gillett's, if you're more familiar with his view about scientific strong emergentism. And in those pictures, what's important is that the emergent wholes and whatever powers they have that are proprietary to them as a whole are always going to be realized in code temporally dependent on the manifestations of the powerful parts that they have. And so Gillett has an account of macretic determinations, which is similar to the way that form functions in some hylomorphic accounts, and that form plays a role in which it's determinative of the relation between composed and component entities. This is how Gillett defines macretic determination, such that composed entities determine some of the powers of their components through role shaping or role constraining. So that's not a productive. This is like displays the view of downward causation. It's rather the form and the organizational factor is playing a constraining or controlling role on which parts' powers are being coordinated, and that's going to bring about the kinds of co-manifestations or the inhibiting of manifestations of the powers. So it's not so much a downward causation or a productive kind of causation. It's rather a constraining, controlling role that's influencing what the lower level powers are doing by virtue of this form or this macretic determination. But then I also think that they have proper proprietary powers, and the powers I'm going to be talking about are the powers for rational embodied control, the kind of powers that are indispensable for a scientific experiment. So what's necessary for performing scientific experiments? Here's what I'm going to provide as a kind of manifest image of what's required. And I think that I'm coming out of a conflicting tradition of philosophical inquiry, a more Aristotelian account, and it's going to be at odds with sort of the point of departure of much philosophy of mind as a rival tradition of inquiry, and a lot of analytic metaphysics. There are points of convergence and translation which are too complicated to get into, but this Aristotelian tradition has a lot in common with some of the claims and theses of the radical and activists in embodied cognition, as well as some of the more classical and active embodied theorists like Evan Thompson. It has quite a bit in common if you're familiar with Thompson's most recent monograph on the blind spot, why science cannot ignore human experience. So these are at least allies to the kind of project that I'm envisioning. So here's the manifest image I think we have to start with. Not starting with physics and a scientific image of humans in the world and how do we reconcile the mind or humans to that world, but rather a more Aristotelian one where we have to start with a manifest image, and the scientific image is one that enriches that, but doesn't radically revise it. I think we can distill the panoply of features required for performing scientific experiments down to a scientist's middle-sized power for exercising rational, embodied control over physical phenomena. In physics, scientists orchestrate the collision of proton beams in a large hadron collider. In chemistry, scientists synthesize an extraordinary range of substances, like ammonia from nitrogen and hydrogen. And in biology, scientists can edit genomes using CRISPR. This distillation down to three constitutive, interconnected powers is not a reductive explanation of scientific experimentation. It's rather what Strawson would call a connective one. None of these three factors, rational, embodied, control, is more primary or basic than the others. Rather, their interconnection and coordination is one of mutual presupposition. I'm going to examine each of these in turn and then come to my conclusion. So, rational. It should be uncontroversial that scientific experiments are rational. Being rational is a personal level attribute in contrast to subpersonal level attributes of a human person's nervous and endocrine systems. An agent is rational insofar as it's a person who's observing, thinking, acting, and can be intelligently constituted and guided by reasons, as opposed to non-intelligently and mechanically processing information or responding to stimuli. This notion of rational therefore excludes much of what cognitive scientists and even functionalists in philosophy of mind call reasons or rationality, which are often ascribed to overtly subpersonal level objects, states, networks, and processes. Being rational on this account comprises observing, thinking, speaking, acting intelligently, and voluntarily according to reasons, and includes both practical and theoretical reasoning. Understood reasons can intelligently govern and guide what one is thinking and what one's doing as a medium-sized rational agent. To exercise practical reason is to perform actions intentionally, and one does so voluntarily or at will with respect to the commencement and or the continuation and or the cessation of some overtly observable or unobservable psychological behavior, like calibrating a laser or performing calculations in one's head. Human actions are intentional because they actually realize and embody one's practical reasons or intentions for acting as one does. The embodied psychological behaviors of scientists are not mere reflexes or instinctual responses, for then their behaviors would be non-rational. Similarly, the embodied psychological behaviors of scientists engaged in scientific practices are not instances of faking or incompetently calibrating a laser for an experiment, for then their behaviors would be irrational. That is to say, they would be acting against the norms of rationality for truthfulness, integrity, the development or the deployment of scientific competencies in intelligent, intentional, and the voluntary calibration of a laser for an experiment. Now, human actions are voluntary insofar as scientists perform their experiments at will. That is, they have a two-way ability to perform an experiment phi or not to perform an experiment phi. And this, of course, drastically underdescribes how much more complex the performance of an experiment is. For it omits the social collaboration involved in most scientific experiments, which rely on the coordination of multiple scientists intentionally and voluntarily performing a scientific experiment by working together. Scientific experiments require many medium-sized scientists cooperating and exercising their powers for rational embodied control together. This brief account also obscures how, within such complex ongoing activities, as collaboratively performing an experiment together, a team of scientists is comprised of individual scientists who must intentionally and voluntarily deliberate together about how to enact what they will phi, whether they will phi, when they will phi, where they will phi, how they will phi, and why they will phi in this way at that time rather than in phi-ing this way and at that time. So they have to have considerable rational control in collaboration about the ways in which they exercise their powers for embodied control in order to conduct rationally controlled scientific experiments. It would not be difficult to explicate in more detail and with greater depth beyond this surface level survio the myriad ways rationality is constitutive of performing scientific experiments, including experimental intelligence required to identify and overcome contravening and confounding factors to achieve the kind of nomological machines that Nancy Cartwright has in mind. And we can find a litany of such examples in the display in the methods and critical discussions of scientific studies. Embodiment. In order to give some focus to the wide-ranging issues of middle-sized embodied agency, I shall enter into its significance by fleshing out some of the more salient connections with respect to rationality. We can start with the fact that human rationality is the embodied rationality of social animals. In here, we find narratives containing stories of many kinds of middle-sized biological, psychological, and social causal transformations and interactions. Humans are allotricial mammals who are unable to exercise their rational capacities for intentional and voluntary action for many years after birth. They don't start off with the abilities that I just described. It takes a considerable time for them to gain them. Humans only learn how to exercise these capacities in virtue of the social scaffolding that nurtures, cares for, and educates humans into becoming the medium-sized animals who can exercise their medium-sized rational capacities for linguistic, practical, and theoretical interactions with other animals. But even this enabling and later engaging in embodied rational activities presupposes the rational transformation of their many embodied capacities that we share with other animals, such as capacities for enactive perception, motivation, emotion, associative and social mimetic learning, and the palpably embodied haptic abilities for manipulating physical phenomena. For example, engaging in scientific observation and experimentation requires rationally transforming one's perceptual capacities to achieve sufficient observational acuity to select and discriminate intelligently among what's relevant versus what's irrelevant within various kinds of observable data. Engaging these scientific activities also involves the rational transformation of one's embodied capacities for motivation and emotion, which enable the kinds of discipline, persistence, resilience, and passion required for the arduous and painstaking work that comprises scientific experimentation. So there are a lot of medium-sized powered transformations of our own medium-sized powers that are required for engaging in scientific experiments. Experimental work is, after all, full of long, grueling, and tedious hours of trial and error, accompanied by sometimes seemingly endless dead ends. Furthermore, because humans are rational animals, they neither can exercise their rational capacities ab initio, nor can they immediately rationally transform their embodied capacities for an active perception, motivation, emotion, haptic manipulation that constitute the kind of these embodied rational activities I described. There's in fact a long, drawn-out, socially informed ontogenetic process of enablings and transformations of proto-rational and later rational capacities that's worked out through many phases of human development. And because development is essential to a human embodiment, being socially dependent in myriad ways throughout life is also essential to being embodied rational agents. So we can't even learn how to exercise our medium-sized powers without exercising them by education with other medium-sized rational agents. To become sufficiently educated is to have one's proximate potentialities for becoming a scientist. To become sufficiently educated so as to have one's proximate potentialities for becoming a scientist requires not only that all of our capacities for perception, motion, motivation, language, intelligence have been enabled and cultivated by the right caregivers, it also requires being provided with ecological and social resources that are needed for engendering these basic human ontogenetic transformations. It also requires a vast educational infrastructure populated by competent educators that can prepare developing minds to become potential initiates into scientific experimentation and theorization. But even that is not sufficient, for what's ordinarily required today is a still more advanced educational formation that can transform educated potential scientists into fully initiated and collaborating participants in normal science. And this depends on elaborate social institutions with instructors, mentors, and colleagues all working together. And finally, the growing number of scientific experimental mega projects like NASA, the Human Genome Project, CERN, the LIGO Virgo, also depend on extraordinary international political and economic resources and cooperations, and the institutions and populations that make them possible, in addition to the publicly and privately funded universities and other research institutions we ordinarily identify with normal science and its research. In short, the essential embodiment of human persons is manifested in human beings developing independent rational animals. And scientific practices, including experimentation, are constituted by their own distinct forms of embodied human development and social dependencies. And once again, these personal level developmental factors from the manifest image of middle-sized humans are indispensable to scientific practices. I think you have to tell a really powerful error theory to sort of discount the role that these are being played. And this is the manifest image that we come out of, and so I think it's a burden of everyone to sort of, if wants to give a radical dismissal of this account, has to give such a kind of an error theory and rival account of this manifest image that we start from. Embodiment also sets in relief the constitutive nexus, wherein rationality and control are intertwined. For we exercise rational control both over our own inactive perceptions, emotions, desires, and beliefs, and also our own bodies and other bodies. I don't have the space to argue for it, but George von Wright and many others have, that our basic concepts of causation are in fact sourced from and continue to depend upon our inactive engagement as agent, as patient, with respect to objects in our environment. And that is how we learn to discover our own causal powers and their limits and their extent. Our inactive embodied controls the source of our elementary experiences of causal interactions, including the discovery of these limits and extent of these powers. But our ability to become rational agents also relies upon other middle-sized social animals and their powers to raise, care, and educate us. And finally then, it seems that our conceptions of causation, our rational concepts of entity, along with principles like the Eleatic principle, they're discovered and bound up with the exercising of these developmental account of middle-sized powers for rational embodied control. So our very concepts of causation are constituted through this learning process, and it's very hard to disentangle them from that. All right, control. The myriad illustrations of humans exercising rational embodied control over physical phenomena are endless. And I'm just going to limit by focusing on how rational embodiment pertains to control within scientific experiments. Roughly, rational embodied control consists in the ability to make difference with respect to the inception or continuation or the cessation of directed and purposeful movements or changes of one's own body and of surrounding bodies in the ways one intends to make a difference with respect to them and their capacities that they afford for movement and change. Adult humans can ordinarily control whether and how they walk across a room insofar as they intentionally initiate, continue, and terminate taking steps across the room. But if one's leg has been anesthetized or one suffers from tendinitis or vertigo or other disabilities, it can be difficult or impossible to commence walking across a room. Some events we either do not or cannot initiate, but we can nevertheless control either an ongoing flow or an outcome by modulating the influences of various factors. For instance, when we try to inhibit a sneeze or reduce a fever by taking paracetamol, shut off the mains of feeding a burst pipe, divert floodwaters with sandbags, or steer a kayak out of a fierce river current. Human bodily movements are characteristically, though not always, rationally guided, purposeful, controlled bodily movements, in contrast to mere mechanical or purposeless, which is not to say directionless, bodily movements. Rationally directed and controlled hand movements, among other haptic movements, are manifested in the complex, ordered, and purposeful activities that comprise making a fire, a loaf of bread, buttering toast with a knife, replacing a transmission, calibrating a laser, surgically installing an optogenetic optical fiber within the medial inthrorhinal cortex of a rodent, manufacturing and installing the quadruple pendulum system supported by an active seismic isolation platform of the mirrors within the LIGO laser interferometer gravitational wave observatory interferometers, whether in Washington or in Louisiana. Clearly performing a scientific experiment falls in this enormous list of embodied forms of rationally controlled engagements we have with the world. And without the discoveries made possible by these scientific experiments, humans would be oblivious to the hidden properties of nature. As Ram Hare writes, and this is a quote, "The Umwelt is that region of the world which is available to species by virtue of their capacities to register and explore it. The human Umwelt is bounded at any moment by the human capacities for perception and the instruments currently available to them. The ontology of the Umwelt was greatly illuminated by Niels Bohr. He realized that human beings could ascribe only dispositions to the world behind appearances. He also realized that those dispositions were defined by the available experimental equipment. They are, in the last analysis, Gibsonian affordances, not occurrent properties. There is indeed a world behind the observable, but it's an Umwelt, and its properties for the human species are the affordances it has made humanly discernible through scientific experimental apparatus. A scientific experimenter attempts to exercise causal control over every known relevant factor that can be controlled, while also mitigating or intelligently identifying and accounting for all the factors which cannot be controlled or eliminated. And insofar as the experimenter, or often enough experimenters, can achieve the construction of a rationally controlled experimental context, something like what Cartwright calls a nomological machine, they can thereby either allow natures to do whatever it may do, or they can direct and even force nature to disclose and manifest its powers. If this kind of rational embodied control was delusional or impossible, then we would have to discount countless scientific discoveries and theories grounded in experimental results, like for instance the 1910 experimental results of Robert Millikan and Harvey Fletcher that purported to isolate and measure the charge of an electron by their ingenious oil drop experiment. The performance of the Millikan experiment can now, through the developmental social rationing up effects of innovations in scientific understanding, education, and technology, be taught to and enacted by college physics students. Briefly and simplistically, in the Millikan oil drop experiment, aspirated and ionized oil droplets in an upper chamber fall into a lower chamber that has two parallel horizontally charged plates. Gravity pulls the oil droplets down, but the electrical traction or repulsion due to the oppositely charged plates can work together to pull the oil droplets up. By turning off and on the potential difference between the charged plates, Millikan in 1910 could, and college students repeating and reenacting the experiment today can, manipulate the movements of the charged oil droplets either to fall slowly under gravity resisted by drag, or to move upwards, the additional contribution of electrical force from the charged plates. This is an experimental setup that allowed Millikan to perform an experiment to measure the charge of electrons. And we could duplicate this with many, many other examples of how experiments function and the kind of causal powers they have to exercise. So, let me conclude with not so much arguments as provocations. What if we evacuated causal powers from middle-sized objects? Strategies that attempt to argue there are particles organized in functional roles so that the fields or particles are rational embodied control-wise need to give a complex account, I think even a radical error theory, of how we can replace or give up this paradigmatic understanding of causality and ourselves as irreducible middle-sized agents, exercising rational embodied control in our scientific experiments. Provocation would be how to preserve the existence of these scientific discoveries, of these fundamental entities that rely on our causal interactions with them. If scientists do not exercise causal control, proprietary causal control, over physical phenomena, then why are photons flying back and forth along the arms of the LIGO interferometers? If scientists did not cause this, then scientists have not performed a controlled scientific experiment to detect gravitational waves. And similarly, if scientists did not cause the proton beams to fly through CERN's Large Hadron Collider, if they could not control the trajectory of them into ATLAS and CMS detectors to the extent that they understand their massive experimental apparatus to do just this, then scientists did not perform a controlled scientific experiment to identify and establish the existence of Higgs bosons. So the provocations are this. So given the manifest image and its connection to the enriching scientific image, I think this has to be the image for us all. And anyone who wants to discount this has to tell a narrative of how their own life went through these kinds of transformations, how they would have had to have some sort of self-understanding that was similar to the manifest image that I just described, but then they nevertheless came to discover, in a similar kind of way of causal interactions with other middle-sized objects, that there are rival arguments, or rival theories, or rival images, and arguments for them, and tell a really detailed, radical revisionist picture that still allows them to maintain the positions that they hold, but also to discount all of their causal powers in playing any role in that. And how would they still nevertheless be able to maintain the evacuation of our own causal efficacy as middle-sized objects, and evacuate those causal powers that are needed for discovering and establishing the existence of the causal properties and powers of cosmic or microphysical events, and that we can still maintain that these things do exist. So from a kind of Eleatic principle, if we can't, we're only going to discover the existence of these other objects if they somehow interact with our own causal powers. We're not going to know they exist if we don't know the causal differences they make, but we're only going to discover the causal difference they make by joining them as causal power partners. And so we're going to have to be able to exercise our own causal powers and coordinated manifestations with these particles in order to discover their existence. So without our own middle-sized causal powers, we're not going to be able to perform the kind of experiments that allow us to discover their causal powers, let alone their very existence. So those are the provocations, and thank you very much for your time.
Thank you, Daniel. I would like to affirm the first parts, sparse ontology, ontological naturalism, and so forth, and then start with the manifest image. I think I'm in agreement that there needs to be a manifest image, and this is one way of speaking of philosophical anthropology. And as far as I can tell, the manifest image is an updated Boethian image of man as an individual substance of irrational nature, which is affirmed by Thomas Aquinas. Differently from Boethius, Thomas Aquinas thinks that it implies dignity and relation. He sneaks that in his treatise on the Trinity, whereas Boethius had treated it in his pushback against Nestorius and others, and Eutyches and other purported heretics. But the backdrop, I think, might look something like that. What does it look like for an individual substance of a rational nature to do that rational thing? I like substances and individuals and rationality and all that. But I also like sin. And I'm a bit emotional, you know, and I have these passions in me, and all of these things are bound up in me. And as much as one might make an account of me that could be subjected to modern rational choice theory, they could probably make a better account of me that's subjected to something like irrational choice theory or non-rational choice theory, which is even more predictive of what I'm going to end up doing today, tomorrow, and especially next year. This is how insurance works so well. So I'm going to give you Daniel to Haan and add sin. Knowing Daniel actually is proof that maybe there are some people that were saved from the effects of the fall, but I'm not one of them. So I can look inside this Boethian person, and I'll look inside rational, voluntary, embodiment, and control, the 1, 1b, 2, and 3, and then causal efficacy at the end, and just give a suggestion of what it might look like if we're less than we think we are. And my analogy here is, in the background, is something like Thomas Aquinas' very optimistic vision of mankind is defensible, I think. But also, it's more likely for him to come upon it in his own age when relative peace abounded and he met more persons like himself and unlike himself, and when Europe hadn't yet been torn apart by massive religious wars and other things. Thomas Hobbes, though, tries to get to similar ends as Thomas Aquinas, but he does this after having been exiled he who would be Charles after Charles, King and Martyr, had lost his head, and then had to make his way in the world under the protection of the second most powerful man in the realm. Now, Hobbes' account ultimately affirms much of what Thomas Aquinas affirmed, which is Boethius' account of our agency, of our substantial identity. But he takes sin and our effectual life exceedingly seriously. And famously, the ordering of the world can best be explained by passions that produce peace, rather than by something like rational embodied control that produces peace. So, very briefly, rational. Something like the capacity to reply to reason, to act according to reason, is what I understood you to be saying. Again, best case scenario, I already suggested irrational choice theory and other ways that we might get at this, which wouldn't preclude reason, but would always understand it to be limited, curbed, and often a second or third choice of humans rather than their first choice, unless they're by coercion or by suggestion or by very good training or by virtue made to choose something routinely that's reasonable. It's a way of saying that our first nature is more irrational than our second nature, or what could become our second nature. 1b, as far as I understood, was this voluntariness, that voluntary that came up, which you focused a lot on how that made us collaborative in the way we tend to pursue the sciences. I don't know if any of you are present in universities, There is collaboration, and there's also exceeding secrecy, competitiveness, greed, coercion, things that are just precluded in advance of discussion. And I'm not talking about political things or ideology. I'm talking about within each of the disciplines and departments. And it differs country to country based on how the faculties are arranged, right? So collaborativeness, I think, really would have to take into account the whole broad vision of humanity and all of its. You have to take account like Dostoevsky's version of humanity as much as de Haan's version. Now, Thomas Kuhn dealt with some of this implicitly in talking about ordinary science and the pressures under ordinary science to maintain the paradigm. I understand it's a bit outmoded now, but there are truths within those books that I'd suggest we might return to from time to time. Embodiment. I liked the move from embodiment to institutions. This seems natural. The things that are true of our bodies cause us to form certain institutions, which is especially why the most successful regimes in world history for providing peace start with the fact that other people are going to threaten us, not that other people are going to love us and help us and give us rights to push against them. They don't have to be called rights. If you don't like rights, if you don't think they exist, that's fine. But they give us something to push against government power and to push against power of others. And those are the very regimes that we've enjoyed. And that meaning the institutions that might descend from embodiment are less like institutions of voluntary, rational, peace-loving collaboration. They're more like good fences that are put up that make good neighbors out of us. We can think of the, well, I'll pause there. Control, rational embodied control. I like this. This echoes something we've come together on what is it? I'm sorry, what's his name? Your favorite philosopher. McIntyre. It's the end of I betrayed my number one rule. Never speak at a conference that I'm organizing. Never speak at a conference that I'm organizing. I got 1 more minute left. This struck me as something descending in a McIntyrean way of accounting for us without wholly committing to one or another vision of what's behind what's behind the stage. But again, rational embodied control tends to result in institutions that exclude all kinds of possibilities for very, very long periods of time that have nothing to do with the truth or the falsity of those things. And for some writing on this, I point you to Paul Feyerabend and his Conquest of Abundance or things like that. And just to the ages of ossified science, like obviously falsifiable things that weren't able to be tested because of the way this control is exercised within institutions that have other interests for maintaining a status quo other than truth and pursuit of those things which we would pursue if we were all Dehanians. And I'll leave causal efficacy out. I think that can come up in the discussion if necessary. And pause there with just the reminder that something was uncovered by Hobbes and those after him. And I'm not a Hobbesian, but you know, you got to give the guy some credit. That is, by a careful study of what human bodies tend to do everywhere and at all times, he was able to offer a re-articulation of a natural law world that took our emotional life, our affects, our passions, our most likely responses, the child in all of us, really, really seriously, and dealt with those passions that produce peace. And certain passions also seem to produce science.
Alright, so this was obviously a very incomplete picture, and so I don't think the manifest image that I was portraying would be one that would be at odds with the sort of complementary points that you made. There would be sort of disagreements about how we should think about things normatively, but I mean, part of the Aristotelian account of the kind of 4 character types of the vicious, those of weakness of will, those of self-control or encrotic, and then the virtuous. Those are like 4 different character types where every individual is sort of moving in and towards. And so there's going to be different configurations or coordinations of rational embodied control. So even the vicious and the acratic still are engaged in types of rational embodied control. It's just they have a different coordination. of their rational embodied control. Their passions or things like that are rather in the driver's seat, rather than reason and having conformed or harmonize their passions with their rationality. So that's going to be part of like Aristotle's normative picture about the kind of different developmental ways in which people come to exhibit. And so I don't think I disagree with any of those things. That's quite very much a true feature about human beings. The point about corruption and institutions, I mean, this is definitely a very Macantirian point, as well as how institutions become corrupted by pursuing external goods. But part of the critical spirit of rationality is the way that it can eventually come to identify and recognize those corruptions and overcome them. So you might even take the replication crisis in the social and psychological sciences. There was a pursuit of external goods for an extended period of time rather than the internal goods. Publishing got out of hand. P-hacking was occurring too much. There was a prestige in certain kind of publishing of positive results. None of the negative results were being published. These were not seen as proper internal goods to the discipline. These external goods were pursued to such an exaggerated extent that it became oblivious to everyone in the community that all of these textbook scientific experiments actually were unreplicatable. And so it was not less rationality, but more rationality, more critical scrutiny, and sort of self-correcting feature of the rational of the scientific practice that actually led to the critical recognition of this replication crisis, and then also attempts to return to the internal goods of what would be good scientific practice, good normal science, and how can we try to replicate these experiments, and how can we go back and look at all these experiments and make sure that they are actually replicatable. So there's much more to be said about that. But I think the causal efficacy, all of this was meant to be just trying to give weight to a manifest image that the way in which we discover causation is through our own exercise of causal efficacy in the kind of ways I described as rational embodied control. And that causal efficacy extends into our scientific experiments. And then as I rushed through at the end, the key point was there that we only discover the existence of these fundamental microparticles that someone make more fundamental than us, have all the causal power, not us, that we only come to ever discover them because we exercise the causal powers we do, and that we couldn't discover their causal powers independently from our exercise of our own causal powers in our scientific experiments. And so I think the onus or the burden is a rather radical one of how do you insist on the existence of the causal powers of these fundamental entities, and yet discount the causal powers we had to use to discover them. And that was the kind of the crux of the argument. So I'll leave it there. Sin is, I don't like sin.
You don't like the idea of sin, or you don't enjoy it?
You painted a picture of me earlier that suggested one thing. So it's a part of the picture.
Yeah,
it's not part of this picture. Yeah.
Let's open it up to the floor. How much time do we have now for Q&A? When are we meant to move? 15 minutes. So let's have just a discussion for about 15 minutes. We're about 5 minutes behind. Yeah, go ahead, Alec, and then Vera.
Yeah. So thank you. So I was wondering. So
you stand.
Yeah. So I was thinking about bringing this back into conversation. Professor O'Connor's talked earlier. I was wondering whether you had any thoughts about whether these arguments could they be localized just to human or animal consciousness and rational procedures, or do you think there's a similarly powerful argument in the offing for the ineliminability of the medium-sized causal powers of inanimate objects as well?
Yeah, so I think I'd have to know quite a bit more, and you'd have to tell a pretty complicated story about you might mean a lot of things by that, but I was thinking of the scientific artifacts, and so what kind of irreducible powers does a reactor have to have, or what sort of irreducible powers does a collider have to have? I think you'd have to tell a much more complicated story about probably bits and parts of some of those apparatus, and some of them might be irreducible in their causal powers, and some of them would not be, and whether or not they become properly irreducible entities that are the bearers of these irreducible causal powers, or if you could just have them have irreducible causal powers that couldn't be exhibited by any of their parts or any of their parts in aggregate. I think that's a story that I don't think I'm competent to tell, but two, I'd be open and interested in hearing someone try to tell a story of that kind. But then, as far as other kind of medium-sized objects go, it would be a different kind of causal story for why you thought like gold had proprietary causal powers over the subatomic particles that it's made out of. But that's not going to be because gold performs scientific experiments.
Because gold makes me feel so good.
You and the hand scientists.
Vera, do you want to jump in?
Okay, thank you so much. So this is very interesting. And so I'm a little bit puzzled by the ontological conclusions that you seem to draw from this argument. So I think even a hardcore reductionist could agree that science has middle-sized objects that causally interact with other middle-sized objects when carrying out experiments. But the reductionist would just say, yeah, okay, so there are those putative higher-level causal interactions, but eventually they can be reduced to lower-level causal interactions. And I was just wondering what you would have to say about that.
Yeah, so a couple of things. One is I don't think there are psychological laws, which is going to deprive some of the higher level of things that the reductionist is going to try to use via bridging principles to reduce to the lower level. I think that some of the psychophysical identity claims are pretty extravagant, and so trying to claim that these higher level powers are identical to the neural powers, which are identical to the biochemical powers, which are identical to the other. So that's part of what a response would be. Part of it is I think there's a kind of holism about rationality, and so what exactly you're trying to grab onto as the types that are going to have physical types that they could be identical to is I think going to be quite difficult.
Well, they might not be identical to, but they might be reducible to in some other way. So, for instance, they might, I don't know, locally identical to the physical properties, things like that.
So, but what are the coordinates at the psychological level? Are they their laws, or what are the variables of discourse?
Well, I would think that there are also psychological laws. So I was wondering where you respect to that.
I'm certainly a nomenological anti-reductionist and maybe a nomenological eliminativist. So I think causal powers do all the work, and laws are just abstract descriptions of regularly manifesting or always manifesting causal powers.
Okay, right. But so then, if there are psychological causal powers, why shouldn't they or couldn't they be reducible to physical causal powers? I mean, so I think it doesn't matter whether you talk in terms of laws or in terms of powers. For the purposes of this argument.
Yeah, so I mean, I think it's a little bit harder to understand how the identity relations would work for the causal powers account, because I mean, part of it is there's a slight disagreement here about just even these traditions of inquiry and how they approach it. And so some of the moves that you've already presumed are moves within philosophy of mind that from like a rival ontological point of view, those moves don't even make sense. So that's part of the way that they're kind of ruled out. But the alternative approach, the kind of hylomorphic account that I'm going for instead is the medium-sized objects are composed out of the lower level powers, but the lower level powers, they get their coordinated manifestations by the way the higher level powers are exercised, and they're structuring and organizing the way in which these lower level powers are behaving. But you just don't have the lower level powers doing the sorts of things at all that could be characterized as identical to reasoning. I mean, it's not like these are physical bodies organized rational organization-wise, and that has the kind of causal efficacy that I think that these rational body control has.
Okay, right. So you would, I'm sorry.
Yeah.
Go ahead.
No, okay.
You're the last hand I saw, so you can just keep going until someone else puts their hand up. All right, well, keep going and then we'll tell you.
Okay, sorry. So you would object to something like a Schumacherian subset view of mental causal powers?
Yeah.
Okay. And so what's precisely the argument? So except from claiming that there are those higher level powers that that the lower, or the combination of the lower level powers couldn't do what the higher level powers do?
Well, part of it would be what's the motivation to think that they should be reduced in the first place? What motivation do I have other than like, here's this theory and these people want to have this theory where we have an account that these things are fundamentally identical to these lower level things, and part of the onus is why should we even begin to think that's the right kind of picture for how we should think about these sorts of things?
Okay, so it might be general proximity considerations, so things like that.
Yeah, I think that's late stage ontology, not early stage ontology, and so like there's already like systematic disagreements early on, and so like parsimony is a reason for getting rid of who we are and what we are, and engaging in like having motivations and even having parsimony, playing a rational controlling influence on the way in which I evaluate theories. That seems like not a feature about physical particles in motion, but parsimony is like a proper rational constitutive norm, and it governs the way in which rational organized behavior occurs. So why do I take parsimony seriously? It's not because particles are organized in rational parsimony principle-wise. It's because I take it to be like a governing feature of how I engaged in rational body control and theorize.
Alyssa has a little one, and then we'll go here. It's a jump, the 30-second one.
I just can't resist just because they're not getting rid of, I'm not a subset, proper subset person, but they're not getting rid of it, they're just trying to understand it. So I just think that's like a really uncharitable characterization of what like Jessica and Cindy Shoemaker were proposing, that they were getting rid of ourselves and what we do. They're just trying to understand it in terms of some other theory that's like very powerful and able to explain our
I mean, not on the direct point of that debate, but explanatory power-wise, if I'm your friend, Alyssa, if I were given the pleasure of being your friend, I knew a lot about you, I would have more predictive power about what would happen to all of the stuff you're made of than if I knew all of the natural science in the world. Right? So like the priority of first substance, which is also a Boethian point and Aristotle's point and whatnot, over second substance, still has much more predictive power, at least in all the first substances we find. And that does tell us that if there's a science that doesn't take that seriously, it can't take first substance seriously, that something's missing in its knowledge of the world and its explanatory power. Or thinks, or has the conceit of reducing it always to something below, or no.
Maybe I just don't know what you mean by not taking it seriously.
Do you think the picture, part of the claim about the not getting rid of is that it does get rid of this manifest image. It says that manifest image isn't correct. It's saying that there aren't irreducible causal powers.
This picture that Vera was just talking about is a non-reductive physicalism that says that you have all those powers. It just explains how they're related to physical powers.
So specifically the Shoemaker sort of non-reductive physicalism is what you're referring to. Yeah, I'd have to think a little bit more about the details of that's not a go-to philosopher for me in sort of my background for thinking about non-reductive physicalism. So I perhaps was premature in that, but I think that there's probably going to be still some systematic disagreements that perhaps I'm wrong to describe it as a kind of getting rid of, but yeah, I'll just have to think about that more on that specific example. Typical kinds of non-reductive physicalism, though, like I think Davidson's account is going to miss out on some of the features that I was describing in the manifest image, and then I think a lot of realization functionalists are missing out on a lot of the pictures. But it might not be the case for some of the others.
We saw a hand. We saw a hand here.
My question's similar to Vera's in that I'm a bit puzzled how you get your ontological claims. And if I understand you correctly, you're saying that the appearance of denizens of the manifest image acting is epistemically prior to those of the scientific image acting. And there is no evidence that the objects of fundamental physics exist without the undoubted appearance of everyday objects like art scientists acting rationally and with mid-sized powers. But what ontological conclusions must I draw from this epistemic priority claim? Are you ultimately advancing a sort of indispensability argument for the existence of mid-sized objects and powers?
Yeah, that's right. And so, but I also think like the very origins of the scientific image comes out of this manifest image. That we only ever begin working out the scientific image because of a kind of finessing and transforming and honing of the way in which we exercise these powers out of our manifest image. And that scientific image can revise as it does and has features of our manifest image. But that even our discussions of what it means for things to exist, those classifications and categories start from within the manifest image, and then they get enriched by scientific images, and our conceptions of causal powers start. So just even the ontology you describe starts out of a manifest image, and it gets revised and enriched and revised, but not necessarily radically revised, through theoretical inquiry, including metaphysics and scientific inquiry. So I do think that it's not just an epistemic claim, it's actually the source and the very story of how we begin to even think about ontological claims and causal claims.
So there were two more hands. Let's have those two, and that was Mark and Ewan. And then if there's time, we'll add more in.
Thanks, Daniel. So this is a kind of a related argument, which it just come to mind as we're talking about middle-sized scientists and microphysical particles. Are you familiar with the whole Patricia Churchill and 4Fs argument?
4Fs?
It's evolutionary.
Oh, yeah, sure, yeah.
Being that because humans have evolved to maximise our ability to kind of do the 4Fs. Jonathan's love of sin is related to this. So 4Fs are feeding, flying, fighting, and reproducing.
And the others.
That's right. So because we hold in those ways, how can we be confident that we have a rational ability to actually discern or, do experiments, do science on 4Fs? So just a similar kind of argument. I'm just wondering how it relates to what you're doing and if there's a similar response.
Yeah, so part of it would be a kind of rhetorical argument of even like laying out the scientific evidence for that already presupposes the kind of rational powers that I'm describing. We could only ever discover that's a truth about ourselves in a kind of limiting way. Because if it was as true as you were saying, we actually wouldn't be able to engage in the kind of scientific practices that would show that a large portion of our history, the majority of our history, was a history governed by those factors, but it wouldn't be enough to show that that's the entire picture of us, because if that was the entire picture of us, we wouldn't have been able to truthfully arrive at those evolutionary conclusions.
I find the example of the replication crisis interesting. I mean, it took a heck of a long time for this finally to come out, and the damage it's done culturally along the way is evident in this. Every time someone opens his mouth and says studies show, the second half of the sentence is almost always going to be bullshit, right? So like the idea that there's a trustworthiness implicit in these, which has been shown especially in social sciences, but also moving more toward harder sciences to be specious at best, or at least it'll take us a long time to know whether this is the case. The damage is often in the reception of science and in its cultural imports and in the trust in this, and it takes so long to undo this, and perhaps more skepticism along the way is what a shorthand for what I was suggesting. Taking those bits of us seriously that tend to manifest in our own hearts most often, and that they might manifest in groups in ways that they're not diminished but increased. You were, and we'll get to you very shortly.
I've been wondering about the best way to ask this question, and this is my current attempt, which is how much of the argument with reductionism is an argument about the nature of rationality in it. In the sense that it seems part of your charge is a sort of performative self-contradiction charge to anyone who makes a reductionist argument based on the scientific image. But it seems perhaps that the contradiction only comes in if rationality isn't something that can be reduced to procedure, which is where I take it probably that the example of the experiment, which in some sense runs itself. That in fact people don't know what the experiment is doing, but it gives its results despite the incompetence or the scatteredness of the operators. Perhaps is actually pushing against precisely that point, the idea that rationality is not reducible to something. So I'm wondering if is that close to the heart of the point, or am I barking up the wrong tree?
I'm going to have Rob say his tiny point very quickly, and Dan responds, and then we'll have to cut it.
Well, I just wanted to contribute to the discussion with Vera and Alyssa, and to go back to something you said earlier in the talk, which was that the onus of proof is on the reductionist. Right? I think that's an important point to make. What I object to is the a priori certainty that it must be reducible or it's nothing, right? And you can see that having real consequences in the academy as well. That kind of whole take no prisoners attitude.
Well, do you want to quickly respond?
I'll tell him later. I think I need to talk to him a bit about more what the question is. Yeah.
Well, we've got some red meat out there now. Let's see what the next session brings. we're going to, before we thank Daniel, we will say there's going to be a short break, 3 or 4 minutes if you need to use the toilet or something to set this up for the panel. A bit longer of a break than we've had between them, but we will try to get started in 3 or 4 minutes. So thank you so much for your attention.
hard limit tonight, 5:45, because Evensong's at 6, so we'll get cracking. I've calculated that our panel is a full 25% of our gathering, which means it's fairly sizable. So that will, we'll get some issues here, I'm sure, but let's see how we go. First of all, it's my great pleasure to introduce Professor Andrew Steen, our very own Professor of Physics. Thanks.
My contribution should last 10 minutes or less, and it's intended to be, as it says in the programme, a sort of reflection stroke synopsis. So my way of interpreting that sort of task is to say I will, some of the time, try to say in my words what it is I think I heard, and then the relevant speaker can tell me, no, you got that wrong, or not. But often, in fact, for communication between people, it is actually quite valuable for person A to say something, person B to say back what they think it was, and then, we can see where we've got clarity. But of course, I will also introduce a few thoughts of my own, and I'll occasionally pose a question which people might want to reply to. So if we come first to Professor George Ellis, I should say. I've, in each case, given a brief reminder of what the sort of subject was. I've not copied the title, but broadly, George Ellis was talking about four categories of causation characterise why specific things happen. I've read a few of Professor Ellis's papers, and I want to just remind people, or reassure people perhaps, that when he talks about top-down causation, most of what he's wanting to say there is simply to re-emphasise a standard part of the way we understand science. I've said most of what he's doing with that phrase is simply reminding us that boundary conditions, are part of what is needed to be talked about in order to understand any physical configuration. And he wants us to see that they are central to the account and ought not to be seen as just an afterthought. Now, he also goes towards emphasising a stochastic element in physical behaviour. And not that he said so today, but I know from his work that he's interested in, for example, the use of the stochastic trajectory way of formulating what we mean by a density matrix in quantum physics. So the density matrix can be reproduced mathematically as a summary of a set of trajectories, and each one of which might involve random processes. And I think what I want to say, and George will tell us if I'm wrong about his thoughts, but clearly this is a way of seeing it. Many people would want to say, well, if quantum field theory, so the underlying theory, does not agree with that stochastic jump way of thinking about the density matrix, then so much the worse for quantum field theory. Okay, so the point is that quantum field theory doesn't necessarily win all these battles about different ways of looking at a given physical theory. And he emphasises the idea of causation as driven in a downward way, enabled in an upward way. So it's the idea that the macrophysics is still important, but what it does is provide an enabling framework for what then goes on. Okay, and of course the causal closure only when all levels are taken into account. So he's saying quantum field theory on its own does not present such a causal closure. I have to say I agree, but what does it matter what I think? Okay. Professor Koons, options for a quantum hylomorphism, which is something to do with pluralism, I understand. I'm not familiar with the term hylomorphism, but I think I've learned today what it is a bit. I felt that he did a good job of setting out issues which I am aware of, issues surrounding how to interpret quantum physics, the measurement problem, and all those things. Interestingly, the notion of stochastic behaviour came up again. If there are fundamental laws governing composite objects, how can this be possible in view of the fact that we think there are macroscopic laws? How can they be both? And he offers that maybe it's because there's a stochastic nature which leaves room for further types of law, or it could be that quantum mechanics is itself only approximate, or that it has limited applicability. I think my job as a physicist here, who knows a lot about quantum mechanics, is to say, yeah, all of those are entirely plausible. None should be just rejected out of hand. I would just say, though, coming now to Bouverie, which came up in the discussion, those accounts do struggle very hard to formulate a convincing relativistic quantum field theory. So I think that Bouverie, worthy though it is not seen by many physicists and philosophers for this reason to be a real contender. It just is too hard to get quantum field theory, relativistic, and so on out of that approach. And then on the point 5, is the dynamic law of quantum mechanics grounded, or how it is, if it is grounded, how? So I heard from Robert something about the Aristotle, can't pronounce that word, use of the idea of the essence of the substance may give a grounding, and I was trying to ask myself, what are you really saying there? How would I evaluate the correctness of any answer you might give on that? So I don't know what to make of that. Yeah, I'm going to go for too long. Tell me how much I've got long. I'm going to have to join this.
Another few minutes.
Yeah, okay. So, yeah, here I just want to make a point of my own. The question about, is the physical world itself as a whole isolated? Well, I just want to say that quantum physics can't give answers to questions of that kind. And I want to just suggest that what we can reasonably expect from quantum physics is guidance on how parts of the physical world influence one another. Let's let that sink in. It sort of goes against the idea that there's a universal wave function which we are all sort of trying to figure out and then interpret. It says, no, that isn't necessarily the way to see what quantum physics is about. I found Hans Halvorson's interjections very helpful. To who's brave enough to disagree as well as and thank people. Yeah, and George said some interesting things about Hamiltonian and Hilbert space, but I'll move on. Okay. From Alyssa Nate, so excuse me if I'm mispronouncing. Yeah, I found that was interesting and thought-provoking, but for me, it seemed to me that the three-dimensional space-time perspective, which you sort of end up trying to recapture, seems to me, well, surely that's the explanatory one. Yeah, you're sort of putting the cart before the horse, it seemed to me. I want to add that, for me, a ket is mathematically correctly said to be a vector in Hilbert space. But from a physical point of view, I think it's somewhat of a mistake to use the word state to refer to this ket. A ket is a tool in search of a job. There is no wave function of the universe, or at least that phrase is like talking about the velocity of the universe, or the mass of the universe. These are highly questionable concepts. Yeah, anyway, we could discuss that further if you would like. From Emily Quershi-Hurst, I found that to be fascinating. I found the lefty-righty discussion helpful to really make us think about questions of human identity and exactly what would a variety of people have to offer on this. I love the foregrounding of the plight of the individual sufferer. I hate the idea that we talk about these grand principles as if somehow we can just ignore what would follow for human experience if what we were saying would be true. I think we mustn't lose track of what we are really saying. And for me, I have to say, by all means, come back to me, but I really struggle to find any clothing on the Everettian emperor. Okay, the goal is to get physicists to think more broadly. That came up in discussion. That's a good goal, I think, of these things. To get the physicists and others who talk about these things to really connect what they're saying about science to what they're saying about the rest of human experience. Yeah, so Philip's talk again, clear, fascinating. I wondered whether the argument about reason and physicality is like the one championed by C.S. Lewis, and of course he's not the only one to have put it. You can tell me later or in the discussion. That argument which he makes was also, counter-argued by Van Inwagen and I dare say others. I'd be interested to know how all these things talk to one another. And then coming to Timothy O'Connor, Weak and Strong Emergence, really clear talk, really helpful to me for that reason. I like the thought that ultimately I learned about the notion that how strong emergence, as he put it, sort of bootstraps the ontological significance of the weak version of emergence. And I confirm, as was already confirmed by George Ellis, yes indeed, energy conservation is not universally applicable in physics, important the concept though it is, it's not universally useful. And I think what contemporary physics has to offer about things like the strong emergence picture is neither this is right nor this is wrong, but rather, yes, it is open to us to think that way, to say strong emergence is how I think is really happening. physics as we have it so far is unable to either, give you a reason to say a definite no or a definite yes to that. I'd like to also hear from others about the arguments from John Lucas and Roger Penrose concerning whether, in fact, human mathematical reasoning exceeds what a Turing machine can do. This seems to be very close to some of the things that were being talked about. And then this final talk. So I'll say briefly, I think what I got from Daniel de Haan, I agreed with what came up in discussion, but much of the time I was thinking, okay, that is what is going on in science, but I'm not sure quite what is the disputed point you want to arrive at. But I think we then got there in the discussion afterwards. I made a few notes to myself on this, but I think I'll leave it there because I think that's more fresh in all of our minds, and I should start there. So, thanks very much.
Thank you very much, Andrew. Now, I'm not because the panel is a full 25% of us, and we have a boundary condition of 5:45. I'm not going to allow the panel to get into no, I didn't mean to say that. I meant this. What I'm going to do instead is to ask the panelists, not in any order, to contribute a very, very short thought for the day, something they've learned, something they really disagree with, or something they're pondering. I'll go first. I was very relieved by the short exchange between George and Timothy O'Connor about strong emergence being diachronic, because I've been worrying about that for the last few weeks, and it put my mind to rest. So thank you for that point. A thought for the day, please. Who would like to go first? Andrew's already given his.
Well, one thought I think that occurred to me was that the question, Andrew actually touched on this, the question of the nature and status of laws of nature is really central to a lot of these other disputes about physicalism and emergence and so on. I think. My guess is that those who take laws of nature to be the absolute bottom line, which don't need any kind of groundings, we say in metaphysics, that working now? We'll keep going on. Yeah, all right. Are perhaps more inclined then to a reductionist or to a physicalist kind of story, whereas if you take, as I do, the idea that you have to talk about causal powers and essences of things, and the laws of nature then are just a sort of summary of the way things are naturally going to interact with each other, that actually pushes you in some way out of the direction, gives you some grounds to take powers at these composite levels and other kind of levels more seriously. Okay.
George, are you next?
Yeah, I think so. Where I agree with Robert, he had various options in there, and I think for me the key thing, if I had to say one thing what I'm saying, is that I believe that quantum mechanics has limited applicability. And if you try to understand real systems, real quantum chemistry is applied to molecules as they're changing their shape and so on, you find always that you actually have to use classical concepts in order to apply the quantum physics. You can't apply quantum physics to everything because then nothing is there that you can hang on to. And that's even the double slit experiment. You can't say that the slits are quantum because you have to describe them classical. So I think the use of quantum theory is actually, it's incredibly important, of course, but you have to ask yourself all the time, what's the domain within which it's applicable?
Does any of the other... Oh, Philip, please.
I always instinctively like to think about methodology. We've got a debate here. It seems to be the central debate is like, are middle-sized objects fundamental in some sense? In this conference, most people are on board with that. Saying philosophy more generally, probably the more reductionist story that maybe Alyssa is sympathetic to is more dominant. But how do we settle this? Do we need to think ordinary objects exist at all? If we do, what is required for them to exist? Could it exist if there's just particles arranged in a certain way, or the wave function made in a certain way? What is how are we deciding this? And the way I like to think of it, just to give my own answer, that it wasn't what I was talking about, but I guess kind of Cartesian and epistemologically at least, I think the evidential starting point for me is we have the conscious experience as we do, and so we need a theory of reality that can account for us having the kind of conscious experiences we have over time. And if we can do that without there being middle-sized objects, great. If we can't, so you know, that's the thing we really know to be real. I'm not just about solving the hard problem. I mean, like, to account for the regularity, and yeah, that's how I would say, that's like what I would judge this all on. But anyway, maybe people have different methodological views.
Alyssa, were you?
Maybe, I guess I wanted to agree with, in the last session at the end, Robert, you said something like, we shouldn't just take this, we shouldn't just think it's like a priori settled that all of these objects can be understood physically. I think that's right, and I think that in general, yeah, I don't know what the percentage of philosophers in full survey said they were physicalists, but I would guess it's a very high percentage.
52%.
Really? That low?
Well, 52% for pro-physicalist, 32% against. The others don't like the question or something. it's not quite Brexit. 52%.
Okay, I'm surprised it's that low. But, okay, well, in any case, I think it's interesting that it's, well, I thought it was a more dominant position than that, but there's no good argument for physicalism. It seems like the only argument for physicalism that is supposedly, I don't know, that isn't like clearly wrong is a causal argument, but almost every physicalist is a non-reductive physicalist, so they have to reject. It seems like, so, yeah, it's very puzzling to me. I think we have to be clear about like why we're making this assumption. And I mean, I do make it, and I think it's just because it's been very successful for us, but to say that it's a priori or there's some good argument for physicalism, I think is, yeah, it's just not correct. So, yeah.
I've been around longer than you, and I've seen a lot of failures of physicalism over the years, so I'm less impressed by its success, to be honest.
Two other people left. Would you like to offer anything?
Well, I also found Tim's claims about how the weak emergence was coming out of the strong emergence, and that was sort of like a priority approach. And then also, I like Philip's argument about some of the functionalist accounts and how it's sort of missing out. The inverted pleasure-pain account, I really liked that sort of argument in particular. So I found that really helpful.
Well, I noticed that our two scientists here on the panel represented what I most often hear among physicists when I hear them talk on these questions, which is a certain modesty about theoretical frameworks and just how far they can be extended. And there's a bit of a contrast with the philosophy of physics crowd, who tend to make very strong claims about a kind of universal framework.
The Haans is an exception.
Yeah. Hans is an exception on the one side, Sean Carroll's an exception on the other side.
Sorry, I can't count. 3 people left.
So mine's just a kind of broad and general thought, but I really appreciated just seeing a snapshot of how much disagreement there was about what is fundamental matter, consciousness, middle-sized beings. And I think a meeting like this, which is interdisciplinary, is so helpful. And I think actually, if we don't all talk to each other from these different disciplines, we're not going to come to an answer. Maybe we might not anyway. But I think talking to each other is the best way to get there.
Thank you. So let's throw things open. So I'd be interested to hear any thoughts for the day that everyone at the other 75% has, or any questions for the day to any particular members. I think Howard, you had your hand up first.
Right. I think this is relevant. Daniel Haan was the only person who mentioned Cartwright's philosophy of science and the dappled view of the world. But I get the impression from Hylomorphics, even though they don't always bring it in, that really it's lying behind a lot of their thinking. So how many of the people who are sympathetic to hylomorphism on the panel will say, yeah, that's probably more or less the right view of science, all the science is, okay, and whether they think it's an essential part, a necessary thing, in order to get the Aristotelian picture going?
That's a hard question. I would say almost necessary.
That was an almost necessary. Sorry, can we have the?
Well, because of the prestige of science, and if And I think she's one of the spots of science that does really support the kind of modesty that Jim was talking about, right? That the laws of nature are always contextual, they're applied in particular situations, and this tendency we have in philosophy to extract the mathematical formula and say that's the most fundamental thing in the world and that's what controls everything is something that she's pushing back on very effectively in looking at how science is actually practiced.
In the connection to hylomorphism?
The hylomorphism? Yeah, so
that's what he was saying.
Right, oh yeah, right, sorry. Yeah, so that's a good question. So
Can
it has to do with the
can you hear at the back? Sorry.
process. I think hylomorphism is all about a plurality of different kinds of substances and parts of substances at different scales. And so it fits very nicely with Cartwright's pluralistic sort of approach to sciences, where again, particle physics is not the absolute monarch in the picture, neither is it in mine.
I mean, I would be inclined, if what the physicists at this conference are saying, like George, that we have absolutely no reason from physics to think there's no strong emergence, then I don't think we need the kind of Cartwright view. But then I think, listen, you say you're sympathetic to David Papineau, who thinks, no, we do have good scientific reason to think there's no strong emergence. Then maybe you need to bring in something like Cartwright to say, no, you've got the wrong idea about science. And I don't know how to sound like I'm not a scientist, but it seems to be different scientists say different things about whether science gives us empirical grounds for doubting strong emergence. And if it doesn't, then I would say we don't necessarily need the Cartwright type view.
And George, on the devil world.
Just a comment, you must be careful which scientists. The scientists from fundamental physics whose whole focus is on particle collisions are a very different crowd from the people who work in condensed matter physics and deal with actual real emergence. It's the latter people who deal with emergence, and those are the ones you must listen to.
I have found that talking to different scientists.
I'd just like to recommend anyone who wants to think, bring Nancy Cartwright and Dapple World into, the discussion. Don't forget to read the review of her book by Philip Anderson. It's quite a critical review. He thinks she, strongly underestimates the sophistication of what the physicists like him and others really think about and do. So just read the review and that will...
It's an absolutely scathing review. I was reading it last week. He accuses her of not understanding science. But, yeah.
It's helpful for understanding Cartwright, that review as well. It's sometimes a bit tricky to read.
Any other members of the panel coming in on Dappled World? No? Okay, there was another question at the back. Yeah.
So I think this is most naturally directed at Dan, who's maybe the most vociferous in favour of the medium-sized objects. But I was wondering generally whether we could shed light on the question by extending the concept, maybe metaphorically, towards the mathematical. So we might think that the number one is comparable to, say, a chair has a similar relation, and maybe the power set, the empty set, is something like a discovery of fundamental physics. And so might we have the same worries about reduction as we maybe have about reducing personal agency to something physical when we talk about or reducing the natural numbers to set theory.
Please will someone else answer, because I didn't understand the question.
I think
unless you ask it again.
I'm guessing, is that a question about reducibility in mathematics compared with natural sciences? Is that...
Something like that. So the typical set theoretic reconstruction of arithmetic, I guess, is what it has in mind there. Right. Gosh, I don't know. I'm not I don't think about that. My first initial reaction is those are really quite different things. Very different things. But
it does get back to Wigner and the unreasonable effectiveness question again, as nearly everything does, in my opinion.
Can I just weigh in on that? Since
Rabbit, yes.
Dissertation is on this. That is that people like Aquinas will
say that to recognize anything, you need form, and just the one is not a number; it's a principle of number. So if I ask you how many Hubble bulbs are in this room, the first thing you need to know is what is a Hubble bulb, right? And so, in order for you to count, you need to know what the thing is. So that's a very traditional account of mathematics and the natural numbers. The natural numbers are based off of form and the recognition of similarity and difference. And the set theoretic reconstruction of the natural numbers, I think, is highly abstract and a very different way of getting at things that you can get more naturally through form and matter or through systematic accounts. So I do think that there is a parallel there, but it's perhaps not obvious to everybody.
Yeah, I know there's some interesting work being done in there in Aristotle's philosophy of mathematics and all that stuff.
Anyone else on the panel? Okay, I think several hands up now. I think that you were probably earlier. Yeah?
Yeah, it's just on the mathematics thing. So one big difference in mathematical reductions is typically the problem is that there's too many ways to do it that all work. Whereas in physicalistic reductions, the doubt is that there's any way of doing it even in principle. So that seems to be pretty stark.
And I think you had a question as well, didn't you?
Yeah. So I just want to share the. I agree. There's interesting way of thinking that consciousness of Philip's way of thinking that consciousness is a type of hard data that we all experience it and we have to take it into account of our worldview. But at the same time, when I think why physicists are more skeptical about such arguments, I would say, is that science has taught us that a lot of statements that we think are true, like by our intuition, eventually turned out to be false somehow. I mean all the special relativity or general relativity or the quantum theory, at least in certain interpretations of it, I think physics as well as mathematics in certain way, informal way, showed us that intuition is not always a good advisor on what is true and what is not true. So I think why physicists could have some problems with this accepting the substances of middle-sized matters. I mean, I'm opposed to being too skeptical, but at the same time, some skepticism I think is appropriate because the intuition could lead us away. Would you agree?
Perhaps Philip and Timothy could both comment on that.
I guess I just think Descartes got something right when he says the thing we're most certain of is our own conscious experience. All you can ever do, how do we know anything? How do we know we're not in the matrix? I don't know. All you can do is start with what seems most evident. And I would say the reality of our own experience and maybe some mathematical truths are more evident than anything else. And therefore, they ought to have. I mean, it doesn't mean we're not confused about some things, or some of our intuitions about consciousness may be wrong, but I suppose how I would characterize the data is very quickly, if I think about I'm feeling pain and I attend to my pain, I think I'm feeling like that. I think I know we're pretty close to certainty that.
But I also feel that times it has the way the times goes by is constant. Yeah, I have the feeling like this, but eventually it is true that when you move, your clocks click in a different place.
Yeah, but then we don't have that same kind of Cartesian certainty about the reality. There's how time feels and how it really is a separate thing, but how pain feels and how it really is, so yeah. I mean, I'm not saying. I guess if there was some strong empirical reason to doubt my view of consciousness, maybe there'd be a difficult tussle there. I suppose I don't think there are such reasons, but I certainly think the reality of consciousness should be given a hell of a lot of weight.
I think we get into problems with the use of intuition when we extend it beyond its natural, reliable limits, right? So on analogy to sense perception, it's pretty good about discerning the properties of middle-sized objects within this room. When I look up at the sun or the moon and naively estimate how far away it is, we get into trouble. It's just not meant So similarly, you might say, yeah, if I try to take intuitions about how middle-sized objects tend to work, certain kind of proto-physics type, assumptions, and I insist on foisting that on the quantum level, then I'm going to get into trouble. But intuitions about middle-sized objects and how they behave, we need to believe that there's some measure of reliability, right? Just for science to get off the ground. I know what I'm looking at when I'm, consulting a measuring device and so on. So there's a tricky balance there.
Okay. Would any other panelists like to? Oh, Alyssa, yeah. No. Would any other panelists like to come in on this? Otherwise, Richard has a question next. No. Okay. Richard, go ahead.
In all these discussions about the reduction to the physical, no one's given a definition of the physical so far, and it's often not given in books which write about these matters. They're apt to say, well, physics is anything rather like our current physics, but of course what counts as rather like. My own view is that the way to carve up the world along the joints is to say there are two categories of things, the substances, properties, events and so on, those to which there is public access and those to which one person has privileged access. Anything that physics deals with, anything any future physics will deal with, will be a public thing in the sense that any physicist, duly equipped with the right apparatus and so on, will be able to find out about it as well as anyone else can. Whereas, when we are in pain or have a thought crossing our mind or form an intention, yes, other people can make a quite good guess at what we are feeling or doing on the basis of our behaviour. But of course we could use that as evidence if we wanted to about what we are thinking and doing, but we have an additional means of knowing about it, that we're actually experiencing it. And that there's two categories of things and they fall apart like that. And the one is clearly different from the other because the one entails the non-existence of the one. Something being physical entails that it's not being mental in this sense.
So physicalism, is it related to physics? I'd love to hear from a physicalist and a physicist on this one. I think, Alyssa, would you like to take this?
Yeah, but you stacked the deck with a bunch of physicists that aren't physicalists.
So the issue is not about physics is at the moment, but what any future physics or past physics would be like.
But I don't have like a, I think, I don't have a very standard view about this. I mean, I think it's right, you can't give an a priori definition of the physical. I mean, you can give an a priori definition of the physical if you like the way you just did, and then that's going to be important for you to kind of describe your metaphysics. For me, I'm interested in the question about how far we can go in explaining things in terms of quantum mechanics and other things. I don't think it's analytic that we can. I just think that's like a worthy enterprise, and I think that's what most physicalists are doing. So for me, the idea is we're talking about current physics. So I'm not, as a physicalist, I'm not trying to claim that there is some physical theory in the future or that we can imagine that's complete, because I agree with you, there's no kind of way of giving an a priori definition of what would be like a future theory that is still close enough to physics. I think the interesting physicalist position is that the theories that we have right now, quantum theories like general relativity, like proposed extensions of those, are have the resources to explain things like consciousness and agency and chemistry and all of these other things. So I think physicalism is really only an interesting position if it's about our actual current physical theories that have been formulated and empirically supported. If we're just talking about speculative theories, I mean, we're not talking about anything that's ever been empirically supported, or we even know what we're talking about. But I'm just one physicalist, and I do not have a mainstream interpretation of that position. So.
Thank you. So we have 1 minute left. Can we hear from a physicist? We have. I know George would you like to be the last person to speak, George?
I want to offer two resources to this group for people who want to know about strong emergence in physics. The first is Philip Anderson's famous paper, More is Different. If you haven't read it, you should read that one. But the one which is more important is Bob Laughlin's Nobel lecture. And he talks about supersymmetry, about superfluidity. And it's a superb statement on the nature of strong emergence, the inevitability of strong emergence in physics. And he discovered the fractional quantum Hall effect, which is a wonderful example of strong emergence in physics.
Can I add something on that? It is quite important.
30 seconds.
I emailed at great length who you just mentioned, and we're back to this issue that it really wasn't clear whether he was talking about weak or strong emergence, which is what came up last time. Can I just say, should we name a pub for those that go to Edensong as well?
If you want to do that out there and collect them in the quad, but we're gonna lose time.
We need to finish, so please can we show our appreciation. Thank you, everyone.